Welcome to HashiTalks Build. This is a new edition of the HashiTalks series, and I'm super excited to have you all here. My name is Kareem Satirli. I'm one of your MCs for today, but I'm not the only one. What you see today, what you will experience today, because we've tried to create an experience, let's be honest, is teamwork. And I think you're really going to like what we have. Before we start, though, a quick call out to our community code of conduct. As with any live event these days, we expect you to focus on being a nice person. We have a chat for you on YouTube or live on Twitch. No matter where you are, please be nice and considerate of other people. And while we work on getting all of this set up, 1 second, as we're doing live events, some audio always starts playing in the background, which is what's happening right now, of course. There we go. Apologies for that. We'll give people about 3 more minutes to join before we kick off with our first session. And, while you're here, get yourself something to drink, because we've got a loaded program. We've got a heavy schedule that we're not going to read out because there's too much good content. But I'm excited, and you should be excited too. If you've ever been to a HashiTalks, you'll notice that we're doing things a little bit differently today. We've got way more technical deep dives than we've ever had. Normally you come to HashiTalks and we'd answer questions for you like, hey, how do I do this with Terraform? How does Consul do that? Today, we're going to be answering questions like, what happens under the hood when you use that option in Consul, when you try that operation in Vault and Nomad? We've got cool demos coming up. We've got a lot of amazing stuff. We'll also show you some of the things that can make you a better engineer, maybe even a better person, that are not related to HashiCorp products. And with that, I think I see the numbers are climbing nicely. Thank you all for joining us. I'm excited to have you here. I'm excited to start this journey with you. I'd say let's kick it off by having our first talk. In the background, Hans, if you're ready, let's switch over to you and hear from our favorite beekeeper.
Hello and welcome to my talk, Auto Configuration of Consul
Sometimes there's some delay as we get things set up.
My name is
because
Hans
doing things live
and as you can see, I'm a beekeeper.
Be problematic. But we're making this up as we go along.
Beekeeping is really one of my hobbies that I like the most to some degree. One of the reasons I got bees is like, obviously I like bees and I like honey, etc., etc. But I'm also a little bit anxious about bees. Like, it's always weird when they're flying around you, and like similarly with wasps and stuff. So there was also this like strange feeling, and I wanted to change that, or I wanted to challenge myself to like get over that, and which is part of the reason really why I became a beekeeper. And now I have my bees for I think 3 years, and they're doing great, and like I'm getting the honey, and it's like I'm always fascinated by how great it is to have your own honey and to harvest your honey, and how bees turn stuff into honey. So that's absolutely fascinating, and I like it a lot. So feel free to ask me any questions. Like if you want to get into beekeeping, like have questions around beekeeping, feel free to reach out on twitter.com/Hans-Hasselberg. I don't know everything, like by far. There are many things to learn, but maybe I can help you. Obviously, similarly with Consul topics, right? Feel free to reach out. I might not be able to answer your question, but I can help you find the right people or the right place to go and ask stuff. And I'm sure we will find a solution for your problem as well. So in my talk, the talk is like split into two halves. So the first half is like I'm building up a case. I'm building up a console client configuration that is secure, like in terms of like console features, in terms of features console provides, like what bits should you turn on to have a secure console client configuration. And I want to really highlight how hard it is to do that, and what really how hard it is, and like show the burden kind of thing. And then like then I want to show you how you can fix that, and what are ways to mitigate some of that, and what are some ways to make your life easier as an operator. And let me go back a little bit. I forgot the work stuff. So I work at HashiCorp. I started working here 3 years ago. In the beginning, I worked on the console core product, and my talk is also related to that. So it's stuff I worked on at console directly. But these days I'm working on the console cloud platform. And that's also amazing, because like while my talk is focused on the client stuff and more, it's like more content from my previous responsibility, the other half, like managing the service, is something we are now offering to you, and I highly recommend you check that out, because it is another step into forward to like less work, less operational stuff for you, and more freedom to build your own applications, etc. on top of console. So I will come back to that and show a little bit, like show 1 or 2 screenshots how that looks, but I highly recommend you check that out. So running console securely is hard, and I hope it's no just because there are so many things to consider, like obviously the environment you are running console in, like may it be a kube cluster or virtual machines on Amazon or Azure, and then what about security groups, what about networking, what about VPCs, etc., etc. And so these are all the things you need to consider as an operator, but also all the security related console features. And in my mind, there's just a lot to it, and it's very hard to be on top of it all. So, and I hope I can like help you with that with my talk. This talk is, as I said, focusing on console client configuration related to security, because I think it has an interesting spot right there. That's an interesting piece of configuration right there, because it is in contrast to console server configuration, for example. Console server you almost never change. You only have 3 to 5 console servers usually, and this is not a lot of console servers. In contrast to your clients, right? You have usually tens or hundreds or even thousands of clients that are running, and you are spinning up new clients, you are deprovisioning clients, and there's lots of churn and lots of change, right? And it's important to build your system in a way that is secure and resilient, and not brittle and falls apart easily, because that only creates problems for you. For all the content that I'm going to provide, I highly recommend you check out our learn.hashicorp.com platform. It has all the content I'm covering too. There are interesting guides that walk you through different aspects, and you should definitely check it out if you don't know what I mean when I say certain things. This is one of the screenshots of our cloud offering. This is the stuff that I have been working on. Not the console cluster limit, but the primary and secondary cluster. We are in the process of porting federation to our cloud platform, so you can federate clusters across multiple regions, and that's amazing. I think our cloud platform is great, and you should definitely check it out. It will help you with running your console servers, because then we have to run it and we are hand-holding your server clusters and make sure everything is going fine. Let's jump into our topic. Running console. This is a console client configuration, almost as easy as it could be, right? There's nothing to run without any security. The things you can see over there are just the bare minimum to get a console client running. In that state, there's nothing preventing an attacker that's in your network from taking over your console cluster, from DDoSing it, from stealing the data, from impersonating servers, anything, right? There are many things. Like at this point, your console cluster is totally open, and any attacker, or even like you yourself, right, with good intents but with a typo, could do bad things. So there's nothing preventing anything bad from a cluster. This configuration has an encrypt key, like it has the encrypt stanza and then something. This is running console with gossip encryption turned on. So console has multiple layers of communication. One, the lowest layer, if I might say so, is our gossip protocol implementation. Gossip protocol is a membership protocol where every console agent is participating in. These are console clients and console servers, and they are all equal, treated equally. And this layer is for communicating and discovering healthy and unhealthy nodes. It is built in a way that is high performant, performs up to thousands of clients, and like I said, it's a special protocol. One of the reasons why it's so performant, it's based on UDP. Problem with UDP is like it's not easy to encrypt, which is why this is a symmetric key, right? In contrast to an asymmetric key that you have when you are using TLS, for example. Unfortunately, TLS is not available on UDP, which is why gossip layer is encrypted via symmetric encryption. So this is a secret you have to put into your console cluster, console client, in order to be able to join an encrypted console cluster. This configuration is like already much bigger. Like it has 5 more lines, and it's running console with gossip encryption like before, but now we also have TLS enabled. What TLS does is it's encrypting the other path of communication, the RPC path, and that's always happening when clients are talking to servers. It's always that way. Yeah. Clients are talking to servers for everything, basically. The servers are maintaining the database with the key value store, with the service, the registered services, etc., etc. So whenever a client looks up data on the servers, it's using the RPC communication, and RPC communication is, in this case, TLS encrypted, which is great. And how it's done is we are providing a CA, a client certificate, and a client private key file. So that's a client can use the CA file to and the cert file and the key file to communicate securely with the console server. Verify server hostname is also a very important option. It makes the client verify if it's actually talking to a authorized server, so to speak. So you should definitely have that as well. At this point, every communication layer is encrypted, so that's great. Gossip encryption and TLS, that's absolutely great to have. Next thing is turning on ACLs. ACL is our access control list implementation, which allows you to restrict access. So for example, you want your agent, the agent you are spinning up and you are registering, you only want your agent to be able to register itself, right? Obviously. You don't want it to be able to register another agent. Even though that doesn't make sense, it should also be forbidden, because in case somebody else gains access to that machine and has this agent token, you don't want that person to do anything else except for the limited scope, basically, that it should have. ACLs are also useful for many other things. For example, for other operators or other console users, you can hand out ACL tokens for them to authenticate with that are limited in scope. So for example, the one person can only see the key value store, the other person can see the services, or and so on and so forth. So ACLs is an important system, and depending on what features you use in console, what other features, for example, connect our service mesh, ACLs really become a necessity. Otherwise, like, parts of connect don't make sense. For example, our service mesh allows you to define who can talk to whom. And if there are no ACLs, everybody can set up these rules. And there's really no point in having these rules if everybody can set them up. So this is what ACLs are good for. Unfortunately, it requires you to create an agent token. And it also requires you to make the agent token proper with the proper access. Okay, so, but now we went through all of that, right? Great, congratulations. We got that far, and it was not easy. That was a fast run through the different security features in console that you can use to secure your cluster. And now you learned about all these things, and while talking about it is easy, enabling security is much harder, right? So the transition is, as you can imagine, if you want it to be seamless, it's hard to transition from no ACL to ACLs. It's also hard to transition from no TLS encryption to TLS encryption. There are ways in console to do that, to gradually turn it on, but it requires lots of work. Anyways, you did that, and your console cluster is pretty secure. But is it the end? No, it's unfortunately not the end. Because now you need to make sure the gossip key that you are using to provision new clients is stored securely. Where is that key stored? It's a symmetric key. It's a secret, right? It needs to be stored encrypted. But how is it fetched during the provisioning? Is that secure? Because if it's not secure, if it's just on some public endpoint, then there's really no point in having it at all, honestly. And when you rotate your gossip key, which you obviously do every once in a while because it's good practice, just in case it leaked, then you want to rotate it to make sure to invalidate your old key. You obviously have automation, you should have automation in place to also update your provisioning infrastructure. And the TLS certificates, the certificate pair you're using for the client, how do you generate that? How do you access your console CA? Where is this stuff stored? How do you securely generate client secrets, the client certificate pair? And how do you send it to the new server? Is all of that secure? Because otherwise there's no point in having it. Unfortunately, right, that's how security works. And because you were doing all the things properly, you chose a sensible expiry date for your client certificates. That means they're expiring, and that means you need to renew them. How do you do that, right? Did you ever think? I mean, few people ever think about that, but you also might want to rotate your console CA. Is that even possible? Then let's have a look at the ACL agent token. You want to make sure it has the least amount of privileges, obviously, and the same problems that I highlighted for the gossip key and the TLS stuff applies here as well. Like, how do you generate the key in the first place? Is that secure? Because you need a management key to generate the client key, agent token, sorry, and all of that, like, it's just like, if you think about it, it's almost a never-ending rabbit hole that you are getting into in terms of like what needs to be done, not only to use the features, security features, but also be actually secure. And as you can see, that's hard. And honestly, at my last job before HashiCorp, I was managing a console cluster. And I can tell you, I never rotated the gossip key. And I never rotated client certificates. And I didn't enable the ACL system. And that's perfectly fine to some degree. That's perfectly normal. People do that all the time. I just wanted to let you know, I just wanted to share what I learned with you, basically, because I think we should get to a place where we all can do better, like, because we know we can do better, and now I want us to do better. And let me show you how we could improve the situation. So one of the, I mentioned there's a feature that's like not very widely known, I think. I might be wrong, but that's my guess. It's autoconfig. And the documentation says, when starting up, but before joining the cluster, the client agent will make an RPC to the configured server addresses to request configuration settings, such as its agent ACL token, TLS certificates, gossip encryption key, as well as other configuration settings. So that's autoconfig. And doesn't that sound amazing? Like, what if we could just like remove all the stuff that we just talked about, the TLS certificates, the gossip key, the agent token? If we could just remove that from our console client configuration, get rid of all the problems we have with it, get rid of all the maintenance burden, etc. Like, that would be amazing, right? But the question is like, how is that still secure, I wonder? So let's look at the configuration, like how it would look like with autoconfig enabled. So we still have all the regular stuff, and we still have the CA file, which is necessary to verify we are talking to a proper console server. But then we only have a little autoconfig stanza, which mentions the server it should go to request the initial payload, and an intro token. And the intro token is like, it's not shown at its full length. This is a JWT token. Yeah, and I stripped almost the entirety of the token just so you can see it on one slide, but there's really not a lot to it. And if you compare that to our old configuration, right, which had the encrypt key, it adds the CA, the certificate file, the key file even of the client, and the agent token. These three secrets are just gone and in a way replaced by the intro token. So instead of taking care of three different things, you are taking care of one different thing. And that's obviously much easier to do. Also, because of the nature of the intro token. The intro token, and this is just one of the ways to set up autoconfig. It's the easiest way, and in my mind, the thing you could do in your infrastructure as well. So in my example, the intro token is a JWT token, and the JWT token is a base 64 encoded signed JSON blob, and it contains different things, almost whatever you want basically. It contains like there's a structure that's already a given, and in that structure you can put in your own data. So for example, my tokens that I'm using for my examples have the node name, and so that when I want to put a client with a node name client1, I'm generating a JWT token with the subject client1 and an expiry of 30 minutes, let's say. Then I'm taking that token and handing it over to the provisioning, and the provisioning starts the console client. The console client sends this token to the console server, and the server, on the server side, it does a verification, verifies that the JWT token is properly signed with a public key that it knows. It verifies the claims inside that token, which is the node name in that JWT token matches the node name of the client that wants to register. And if all of that is fine, it will go ahead and send the certificates and the gossip encryption key, etc., to the clients, so that to the clients that requested the stuff, so that it can continue with bootstrapping. This is how it works. And in my mind, that's pretty amazing, because you are replacing all these different like ORs and security features with one thing that's pretty easy to do, generating the JWT token. If you have more questions how to do that, or want to see a demo or whatever, reach out to me and I can show you. I don't have time during our presentation, unfortunately. The certificate stuff is all coming from, we didn't build the certificate generation, etc. for autoconfig. It was already there because we already have also code and the infrastructure in place in console for our service mesh implementation, which is also using certificates extensively. And so we are just using that for autoconfig as well. Yeah, there we go. So, and then this RPC endpoint, basically first it validates JWT token, and then it just bundles up all the information, like generates certificates, fetches the gossip encrypt key, the latest one, and some other information, and sends that down to the client. And that way we can, like, really quite beautifully provision clients, basically without having to provision any secrets except for this JWT token. On this slide you can see the server configuration that's required for the client portion. I mean, it's just showing the autoconfig stanza. It is like, if you look at it, it's a little bit, but then again, it's not that much. It has a public key that is used to verify the signature. It has a claim mapping, so you can map the subject of the JWT token to the node in console, basically. And then it has claim assertions where you can say, okay, I want to check the node name against the node name that wants to register. And as you can see, the assertions are configurable. You could add whatever you want. You can also put in your own stuff. You can check the data center. You can check the weather, basically whatever you want. So this is just to show you what's required on the server. It's not a lot, I think, and totally reasonable to do. Yeah, that was my talk. I hope you took something away. I hope it helps you operate your own cluster and your own clients. Feel free to ask any questions you have. This is me with my son beekeeping. I figured I started with the bees, so I can end with the bees as well. Yeah. I hope you enjoyed this talk. I wish you lots of fun in our next sessions. Let me know if you have any questions.
So the beauty of these live events is that sometimes you try to set up stuff and you might have a situation where you just lose your audio feed, no matter how much testing you do, which is exactly what is happening here. But we're going to make this work despite not being able to hear each other properly. And you're going to see the amazingness that is technology. So first of all, welcome back, Hans. Glad to have you here. And that was a beautiful talk. It's good seeing you again at HashiTalks.
Thank you, Kirim.
Awesome. And now I can actually hear you. That's even better. See, the beauty of things getting fixed in the back end is just amazing. So first of all, I love the call out to asking you questions about beekeeping. That's probably my favorite part about this event. There has been some good stuff. For our audience members, if you're into beekeeping, you should definitely follow Hans on Twitter. He posted some really, really cool stuff a while ago. You got a new bee, you harvested about, I was gonna say 150 pounds of honey, like 70 kilos, something like that.
Yeah, exactly. So that was our first harvest round. I think maybe 1.5 months ago, and we just got another round in that was like 100 pounds. So this year is going great.
This year is definitely going great. I think we could all use a little more honey in our life, so that's definitely one of the cooler things. So I'm curious, if people look at autoconfig and think, hey, I want to implement something like that on my own, or I want to work on that, what's one thing that you came across while working on it that made you go like, hey, I wish somebody would have told me that this is the right way?
Yeah, I guess at least while I was setting it on my own. So I didn't so autoconfig feature, like I didn't work on that specifically. I worked on a feature that's similar but not as powerful. So I worked on the version before basically. And with autoconfig, I imagine the biggest issue with setting it up for yourself is the JWT stuff. So the way to authenticate. And I tried to show briefly how I did it with a static JWT token, which is, in my mind, the easiest way to do it. And I encourage people to try to set it up so that they can just see how it works, right? How you set it up in your infrastructure afterwards, that's another story. It requires processes, etc. But I think as soon as you have it working once, I think you will see the benefit pretty fast. Yeah. So definitely, in my experience, getting it to work and like understanding what it is, that's really the hardest thing. And unfortunately, we don't have learn guides for that because our learn team is so busy creating guides like across the whole organization. But it's certainly something I'm rooting for and trying to get in.
Actually a great call out. It is that we don't have these, but fret not. If you want to learn new stuff, learn.hashicorp.com. We have currently 500 plus guides. And I'm pretty sure now that we've made this call out, something for this will come sooner or later. I know we have a couple of folks from the Learn team joining us later on. We had workshops yesterday with a handful of them. So let's see if we can use the power of this live stream to get this information out there.
Yeah, sounds good.
Totally forcing people's hand. It's beautiful. So you're joining us from Berlin. Potsdam, actually. We have a ton of people joining us from all over the world. If you're joining us in the chat, let us know where you're from. I saw somebody from Trinidad and Tobago. Super cool. It's amazing that we get to reach so many folks with this event, and I'm really, really grateful for all of you being here. Hans, before we head to the next session, what's your one thing you would want to tell new contributors when they look at the console code base?
Yes, that's a good question. So I imagine, I mean, if you're asking it like that, I imagine, I mean, most contributors, like that's a hard question. Like, I guess, like most people coming to the console code base are probably using it and have something in mind they want to do better, right? So you are coming, you are using console and then you found a bug or you're missing a feature. And then you are coming into it and like trying to figure out like how do I do that? Like how can I fix this bug? Like what's the overall structure, etc. And you just browse through the code, etc. And I would encourage you to open a PR and maybe even add a sample implementation, but don't go above and beyond. Just you should be making sure, like with the maintainers first, you are going into the right direction. Like if it's a small bug fix, it might not be such a big problem because it's not that not lots of work involved. But if it's something bigger, you should definitely make sure it's going in the direction that the maintainers have in mind as well. And yeah, and then the next thing is I would like to ask for patience because like there are really lots of open issues, unfortunately, or like thankfully. So we are always thankful for if you are opening an issue or like creating a PR, but it's really lots of work to work through all of them and like include the community PRs and work into our daily work, which is like usually pretty different to what the community is doing. So yeah, we are trying our best really and to work through the issues and PRs, but it is not easy. And yeah, but I would definitely encourage everybody to contribute. We are looking forward to your work and contributions and ideas.
I think this is actually a beautiful call. What I'm reading between the lines is that if I'm thinking about adding a big feature, not just a documentation fix, I should probably have some pseudocode in there just to showcase, hey, this is what I'm thinking of. No tests, no actual code, doesn't have to work, but more like, hey, this is what I have in mind. And then go
Yeah,
from there.
exactly. Yeah, exactly. Because console is a very complicated code base, and why you have something in mind that seems like totally obvious to you, like why isn't it implemented already? It might not be the direction we want to develop console in, or it might be that basically we have other considerations that we still want this feature, but like want to develop it differently, or like introducing a new thing that's related. So definitely check it out. Communicate with the maintainers and see what they think. And yeah, otherwise, like we love all the contributions and we are looking forward to get more of them.
Actually, I like this because what you're saying is trust us that we'll get to your PR. And I think that's really it. If you're contributing from the outside, you might not see all the things that we see. You might not have an idea of the exact roadmap because roadmaps are hard. Not just internally, they're also hard externally because once you set something up, people expect it to happen and preferably, 3 weeks before you committed to it, right?
Yeah.
So send us your PRs. It's always welcome. Check the contributing guidelines for any repository you work in. And let us help you. But also don't be dismayed if it takes a little while. These are good call-outs, Hans. Thank you so much for coming back for this HashiTalks edition. And we'll see you in the chat.
Yeah,
Hopefully.
thanks for having me. It was great and looking forward to the rest of the sessions.
Me too. I'm super excited. Before we switch over to Megan, who works on the Google Workspace provider, a quick call out to a few other things. We run regular community office hours. So if you're more interested in, I've built this feature, but how do I use it? That's where you want to be. We'll have a link for Megan's community office hours from a week ago up in the chat later on. That's the same chat you can use for asking questions. So if you want me to ask Hans something about beekeeping or console, both is totally in scope, let us know. We've got about 30-ish more sessions coming later today and during the day. No matter which time zone you're in, eventually you'll have to go to bed. And that's going to be hard because there's a lot of good stuff. But trust me, it's going to be worth it. And we'll have the videos up later. So with that, I would like to hand over to Megan. And let's talk about the Google Workspace Provider.
Hi.
Hello and welcome to my talk.
Hi. I'm Megan Bang. I'm a software engineer here at HashiCorp, and I've been here for a little over 2 years now. I started working on the Google Terraform provider, where I'm still working, and recently I began working on the new Google Workspace provider. Today, I'm going to tell you about how the experience of starting on a major provider shaped the vision and design of the Google Workspace provider, how I used what I learned from the Google provider to quickly forge ahead through some of the otherwise more significant pain points of developing providers, and we'll finish with a look at some new things I learned as I was navigating the territory of building a provider from scratch. First and foremost, I want to really underscore how beneficial it was to have the experience of contributing to a pre-existing provider and learning from all the more experienced engineers on the Google Terraform provider team. By reviewing their code and collaborating with them on reviews of my code, I picked up a lot of unwritten best practices that I was able to carry forth when I started defining the Google Workspace design. Specifically, a great advantage of the Google Terraform provider is that the majority of our Terraform resources and even some of our tests are auto-generated using a tool called Magic Modules. Magic Modules was developed by the team at Google and consists of templates for Ansible, Inspec, and Terraform. Developers on our team populate YAML files that mimic the REST API specs, and Magic Modules fills in the templates from there to create the Terraform code. As with everything, there are periodically some customizations that we need to do to make all the APIs work nicely with Magic Modules, but even then, we have a well-organized way of handling those customizations that make things pretty uniform throughout the Google Terraform provider codebase. Let's be honest, having auto-generated code is a really helpful way to see the patterns of what the code needs to do, while also making sure function naming is clear and consistent across the entire codebase. This was a big thing I wanted to bring forward into the Google Workspace provider, as it's great for onboarding a new maintainer and maintainability in general. We didn't auto-generate any of the Google Workspace code, but we tried to follow similar patterns for each resource and data source. Prior to starting the project, we had done some research into whether we wanted to adopt the community-written G Suite provider or write one from scratch. We chose to write it from scratch so that we could implement the consistency of the code base, as well as there were a few things we wanted to implement differently. A main difference being custom schemas and user attributes. That being said, we found the community provider and much of its implementation very helpful. I'll speak to these things a bit later. So to begin, I created a new repository using the scaffolding provider template on GitHub. I browsed through the files a bit to get familiar with our scaffolding project, see what I needed to customize for Google Workspace, and made those small changes first. The next thing I wanted to get working was authentication. I wasn't around for implementing authentication for the Google provider, so this was something I knew that I had to learn, but also I was very interested in how it worked. This was one area I was incredibly grateful for the community-developed G Suite provider. I was able to go between the Google provider authentication and that one and notice the differences and go from there. In the Google provider, there are a few options to authenticate. You can provide an access token, a credentials file, a user email for impersonation with either of those, or use the default token source. We use the OAuth 2 Google package shown here to authenticate. You can pass in the hard-coded token to a credentials object, or call credentials from JSON, which will create a credentials object for you. This is the typical and suggested use case. In either case, you can have the option to impersonate a user's credentials, so long as the service account is set up correctly. All you need to do is supply the desired user's credentials and an OAuth 2 Google option for impersonating credentials, and again, the package will take care of it. Scopes is also an option to be defined here, although by default, the provider has scopes set that you can do most anything. Google Workspace functions a bit differently. After discussing with the team at Google what needs to be set up, they pointed out that for the Workspace APIs, a user must be impersonated, and domain-wide delegation needed to be enabled on the service account. Unfortunately, domain-wide delegation can only be enabled in the console, so I got that set up in GCP, then headed over to the admin console, where I needed to use the client ID that was generated by my service account and set it there along with all the scopes that particular service account has permission for. This differs from the Google provider, as the service account there is not limited to any scopes other than the ones defined in the provider. On Google Workspace, however, the OAuth scopes need to be set in the provider and in domain-wide delegation for extra security. So after I set that up, I attempted to copy and paste how Google read the credentials and added the impersonated user, but it still didn't work. The Google team said I needed to set the subject. However, I didn't see that option anywhere in the OAuth 2 Google options. I hopped on over to the community G Suite provider to see how they did it and saw the OAuth 2 Google package had a different function available, namely JWT config from JSON, which returns a JWT config object that has an option to set the subject. This is where I was able to add the impersonated user email. This config object creates a client, which we can then use throughout the provider. Once I got authentication working, I wanted to write some tests for it. I wrote them to closely resemble the tests in the Google provider, checking for invalid credentials, credentials stored in a file, and credentials stored as a string. I was able to get this working locally, then had to decide how to run them in my GitHub test workflow. So I switched gears and learned all the things GitHub Actions. Okay, not all the things yet. My knowledge of GitHub Actions is still very much a work in progress. Google credentials are stored in a JSON file. However, GitHub strongly suggests not storing sensitive information as a JSON object in its secrets. So my first action item was to figure out how my credentials would remain a secret without storing them in GitHub secrets. Enter HashiCorp Vault. The Vault team here at HashiCorp has written a Vault action where I can retrieve the private key data as a GitHub secret. So I spun up an instance of HCP Vault, and you can see in my test workflow how I retrieve the credentials, then decode them and export them in the steps I need. Because I needed a GCP service account and the appropriate permissions attached, I ended up setting up my Google infrastructure and my Vault roles and backends in Terraform Cloud. It took some time, but now that it's working, it's pretty slick. After that, the real work began. I began by writing resources and data sources as explained in the tutorial at learn.hashicorp.com. As most developers do, at least I hope, I did a lot of copying and pasting of previously written resources, then rewrote the attributes of the schemas to match the resource I was implementing. I'd then go into each CRUD function and replace the guts of the function with the new attributes, and any customizations specific to the resource I was working on. A big hurdle we had to address with a few of our resources was eventual consistency. And to be honest, I'm still learning how to do that best. I'm expecting we'll have changes in the future, But for now, the TLDR of our solution is that we monitor the E tag until it's changed, and as often as we've requested a change. Okay, so we prioritized our first release based on what was in the community maintained G Suite provider while adding some additional data sources. The Google provider has a very nice helper function that will reuse the schema and read functions of its associated resource. So I tried to add data sources along with the resources to be more thorough. There have been a few difficult attributes that I've had to contend with. The main one being custom schemas on the user resource. Custom schema is difficult for a few reasons, primarily because it doesn't have consistently defined fields. The user will name and define a schema in the schema resource, then reference the name of that schema and define its attributes on a block on the user resource. Attributes like this are particularly difficult because we can't validate the fields are correct on plan. In this case, I did a validation on apply that would read the schema's fields and its associated value types, then loop through the user-defined fields to verify they were indeed on the named schema. Then we check the supplied value was the previously defined type. Due to not knowing what type the value will be, the user has to supply a JSON string for attribute values. This added some complication because the int types were unmarshaled as floats, so we had to account for that here. Ultimately, what I learned from writing the Google Workspace provider was a lot about Google and Google Workspace authentication and the difference between the two, a little about GitHub Actions, but a really neat technique to keep Google credentials secret in GitHub workflows, and some unique ways to handle validating fields with schemas defined outside the realm of the resource. I hope what I've learned from this experience will help you to create amazing Terraform providers. If you have any questions about how to contribute to any of our current providers or how to begin writing a provider from scratch, please reach out to me at mbang@hashicorp.com. Thank you.
That was beautiful. I was like learning from Megan because of the humble way she presents things and just, does amazing stuff. To me, amazing. Like, hey, you know what? I'm building this provider, so I'm just gonna add GitHub Actions like it's no big deal. If you have some time, I highly recommend checking out the GitHub repository for the Workspace provider and having a look at the way the workflow is set up to retrieve the secrets. Megan goes into that a little bit during her talk, but it's definitely worth checking that out on the code level and, maybe just doing the same thing I did, which is, copy it over and use it in your repository. No need to reinvent the wheel. If you're into GitHub Actions, good news for you. We also have Mo Khan from GitHub, from the GitHub Actions team, joining us later today to give a talk about basically some of the cool things of GitHub Actions that you might not know about and how you can use them. But now it's time to hit our next session and introduce our next speakers. We've got Daniel Schmidt and Ansgar Mertens joining us from the CDK for Terraform team. And I would say, if you two are ready, let's switch right over there and then bring you back for some Q&A.
Hi, and welcome to our talk, CDK for Terraform Deep Dive. In this talk, Daniel Schmidt and I are going to show you the technical stuff under the hood that enables the CDK for Terraform to work. And I'm Ansgar, as you might have read and seen, and I'm joined by Daniel Schmidt, and we are both senior software engineers on the CDK for Terraform team. And yeah, we are happy to show you some of the internals today. So, short intro to refresh. The CDK for Terraform allows you to define infrastructure in your favorite high-level languages, so like, for example, TypeScript, Python, Java, C#, and most recently Go. And under the hood, it works using Terraform. So you got all those Terraform providers and modules that are available to your power, kinda, so you can use them. And how that works is what we are after today. So let me give you some overview what we're going to cover. So first, we're going to have a short look at the CDK for Terraform Stack and Python. And then we will see how we generate the Docker provider that is used there for TypeScript first, and then translate it to Python, and then execute the CDK stack. So that's the synth operation, and then to deploy the stack so that we have our infrastructure available. And yeah, let's start off with CDK for Terraform Stack and Python. So this is a shortened example that you can also find in our docs. So what is defined there is the stack and some resources and Docker provider. So we're having the Docker provider at the top, then an image and a container. What this does is just run Nginx locally on your machine when you deploy it, but it serves as a simple example, and so we can cover more technical things easier. And what else is missing for this to work is the instantiation of an app and the stack, and then calling the synth method. And that's what we're going to get into later. And yeah, so what wasn't shown before, because I had to make the shorter, was the import. So we import from imports.docker, and that's something that's not available in the example, that's generated. And how these bindings for providers, for Terraform providers are generated is going to be our first topic. So we are going to generate it in TypeScript for the start. This is an overview of what's going to happen under the hood, so you get a rough understanding, and I'm just showing you code after code. And to generate those provider bindings, we do cdk get. So that's a command from our CLI. And this is going to invoke the so-called constructs maker that we have something internally, and that can generate the code for providers and modules. So at first we'll get schema, so for providers via Terraform, and for modules via some utility library, and then it will generate the code. But let's just jump into it. So to specify the providers you're going to use, you put them into your cdk.tf.json config file under Terraform providers, for example. And for this Python example, use the Docker one. So we put there the reference to the Docker Terraform provider. And later on, when you run get, there's some constructs maker initialized, and that one is going to get some constraints. So in the end, that's just another representation of what we just put into our config. And then it's going to call generate method, or the CLI is going to call generate method on the constructs maker. And this is going to first start and invoke the generation for TypeScript, because all other languages are based on that, but that's something Daniel will get into later. And so this generate TypeScript method looks like this. So I've shortened it a bit, but you can see at the bottom there's some GitHub logo which just links to the source code. And yeah, you could see it in full length with all error handling there. But for the generate TypeScript thingy, it first will to jump into read schema. And that's where we are going now. So we are not caring about the rest of the code for now. So jumping even deeper. So if you remember, for the providers, the first thing at the bottom left will be get the schema via Terraform. So this is read schema. It does both, so for providers and modules, but it's simplified for the providers now. So I removed all code for the modules, and this is the version for the providers only. And what it will do is it will create some temporary directory, and there it will write a main.tf.json file containing a definition of all the modules used so that we can invoke the Terraform binary we have. So for example, it could be the one locally with some init, and then Terraform under the hood will do its work and download all the providers. And then we invoke Terraform again with the command provider schema in the format JSON. And then we take this output and return it. So we get some schema definition for the provider that contains what resources, data sources, other configuration is needed for that provider. So let me jump into the version for the modules. For the modules, it's the same code, so it's also initializing it, so it's the same init, but this time it's not going to call something on Terraform, but it's rather going to call another helper method, which is called harvest module schema. So that one looks like this, and it's abbreviated, of course. It will look into a file that Terraform creates. So that's the .terraform/modules/modules JSON file, which contains information about the modules that Terraform downloaded, such as the temporary subdirectory where the module code is in. And then it will go in there and look for every file it finds for the modules and call this convert files method or function. And that one is imported from the helper library we have, which is called HCL2JSON. And I'm not going to go into that detail now, but what it does is it takes all the HCL that is the code of the module in the end and converts it to a JSON representation so that we can use JavaScript magic to look into it and see what we need or how we would interface with a module or with this module. So back to the generate TypeScript one. We are now done with read schema. We've got information in this schema variable about the providers and the modules. And now we're going to do some data mangling. So I kind of commented that out. And then we check whether we have providers and or modules and instantiate Terraform provider generator and or a new module generator. So these two classes will create the TypeScript code. They will just write a file to disk and have like add some method and everything to it. So that's something you could see in detail in our code base, but that's too abstract, not too abstract, but too concrete probably for this. So I skipped it, but instead I'm going to show you their input and the output. So we are treating this as a black box. So for the Terraform provider generator, the input is what we got out of Terraform when we told Terraform to describe the providers in a JSON place. And we get something like this, which is heavily shortened. It was a lot longer. But for example, we can see there's an attribute to the Docker image resource, which is called name, and it's required. And if we now have a look back or forward at the output of the Terraform provider generator, we can see that there's an image resource created, among others, and that one has some name attribute. And it creates some getters and setters and uses that in the synthesized attributes. So in the end, when we are going to interface with Terraform, we can get that information out again from the code in the high-level language like Python, TypeScript. And for the modules, it looks similar. So the input this time is the JSON representation of the HCL. So it looks a bit different. So for example, for this, I used the VPC AWS module or AWS VPC module, and it takes a name as an input, which is not required this time, but you can still pass it. And for example, among a lot of other outputs, it has the VPC ID of the VPC it creates that's going to get passed out of the module. So I choose those two, and now we're going to have a look at the result of a module generator. So what files it writes onto the disk in TypeScript that you could use in your CDK for Terraform TypeScript stack. And this looks a bit like this. So you can pass in a name, you can get the VPC ID output. So we suffix them with output to have no collisions with inputs with the same name. And I inlined some function call what it does under the hood when you get an output. So it just returns the address that Terraform would use, or you would use in Terraform if you want to point to some module. And yeah, synthesize attributes get some inputs. It's heavily shortened, but yeah, that's the gist. And well, now this is TypeScript, and I promised you Python. And so this is why I'm going to hand over to my colleague Daniel, who's going to show you how those Python bindings are created so that we can use the same thing to interface with Terraform in Python. Yeah, take it over, Daniel.
Thank you, Ansgar. Now, let's talk about how we get these TypeScript definitions over into Python, the language we want to actually use in this example here. We do this through a tool called JSRI. JSRI is a program that translates the TypeScript definitions over to Python, and at the same time it also includes a runtime that we use then to have like the communication done between different threads of the CDK program. So for a CDK program, the things that we actually manage in the end are constructs, which is a library also by the AWS team, and this library defines our infrastructure that we want to have as classes that sit in a tree, and these constructs can have side effects, and they can have and they can interact with each other. So that's basically what we want to get out of the run program. We want to have a tree of constructs, and let's take a look how that's done. So in general, we have the communication here between JSRI and our program code, and JSRI is run inside of a Node.js process and the program code in the language of our choice. That's where we need the runtime for. So we can see here the provided TypeScript definition. We have a image class here, which extends from the CDKTF Terraform resource. So our project's baseline is this Terraform resource that has some functionality in it that we commonly need. And you can see for the methods that we expose, we run this getBoolean attribute or getString attribute method. This is part of our token system. So the token system keeps track of the references from values to another. For example, if we want to use this image here inside like a value of this image, for example, name, inside of our container later on, we want to have this in the end be a Terraform link, so a Terraform expression that links the image to the container. So we want to use like a reference, a Terraform reference here. So that Terraform then knows how to make this happen in the end and apply the code. If we move this over here to through JSRI into Python, we can see all of this token system magic that we had before is gone, because the implementation actually lies in TypeScript. It's not in the generated Python code. Generated Python code just uses JSRI get. We can see here for name and for latest to get the value from the Node.js runtime. So the Node.js runtime, in a sense, holds all source of truth here, and we typecast it and expose it to the user. So that's what the JSRI wrapper code actually does. It's not that much. The main functionality lies inside of the generated code and inside of the contracts we write ourselves. So let's talk about how the execution works then. We execute when we run cdktfsynth. The synthesis command is there to translate from the CDK program over to the JSON that defines the spec of the like the Terraform spec. So that's the synthesis we have to do. And we do this by invoking the Python program first, because we need to get the information that you provide, like the user provides to us for the program and what the program should do. So this is run through the app command that we have in the cdktf JSON. You can put in there whatever you want in general, but in the end, this all here for the CK works through constructs. And we're gonna see how that works a bit later. When the code is executed here, for example, the first line would be now this Docker image we want to instantiate. So we give it a name, like give it the context, which is self, which is the stack we're currently in. We have the name of the Terraform resource, which is Nginx latest here. And we have the name of the image itself. It's the latest version of the Nginx image. And we define that we don't want to keep it locally to the provider here. Under the hood, this actually triggers a create call through JSI. The communication here is done through stand in, stand out. You can find more on the official JSI website about how specifically this communication works, but we're going to go through the different forth and back between these two here now. So in this create method, we specify through the fully qualified name which resource we want to create. So in this case, the image from the Kreuzwerker Docker provider, and then the args we pass in. And it's the same as we passed, but as the underlying values. So in this case, the JSI by ref part here denotes that we have a reference here to a Terraform stack. So we could have a different Terraform stack here as well. If you have like 2 or 3 stacks for your application, those would be like different numbers here, different names. And for the second argument, we have a string literal that we can just pass over, nothing to be done with that. And the third one is actually an object. So this is in JSI a struct. And the struct has also like a fully qualified name. In this case, it's the image config. And then some data in it where you could find all the other literals we put in there. JSI does with that the work internally, so it builds a construct, it executes the TypeScript code that actually builds the contracts to be precise, and then it gives us back whatever the TypeScript code says. In this case, it says it's a reference, and it's a reference to this Docker image with this specific ID. So we got that created now. Now the interesting part is, what do we do when we have references between different parts of the code? For example, here in this container, we want to use the image that we previously defined. So we do in the Python code docker image.name. What does happen on the hood? So on the hood, we have Python that calls the get API of JSI and wants to get the name property of this specific object reference, which is the reference to the Docker image we declared earlier. And what we get back is a OK message again, so it worked. And the value here you can see is a Terraform reference string. I broke it a bit down so it's a bit easier to read, but in the end we want to have a Docker image with a specific name, which is part is the stack we have, which is Python Docker in this case. The other part is the name that we had, and the last part is a hash over the scope it's in. So if you define a different scope, for example, a different stack you want to define, or you have a different class that extends from resource and defines its own scope, those would be denoted differently. So we have a bit, we make sure that we don't have double identifiers here. So you are sure you can use the same variable inside of the same scope here. And yeah, that brings us everything we need to actually create the Docker container. So we can see here the create API is called again with the container. We get the stack from earlier, and in the struct in the container config, you can see that the image is actually passed or again truncated because these things are pretty long, but you get the idea. The image from above is passed here, the Docker reference and the Terraform reference, and Terraform will later on resolve that and make the right deployment hierarchy out of that. Now we get back the container from the JSI code, so get the reference again, and we're done with the program. It's not longer in this case. And now what's happening under the hood here is we want to have the HCL JSON, which is the same as here, like normal HCL, but in the JSON format that is easier to define by programs. How's that done? So we, as I mentioned previously, we have this tree of constructs that is created, and we like the most top level construct we have is the stack construct that you have to use, and the stack itself has a unsynthesized method. This unsynthesized method is called by JSI to ensure that side effects will happen. And the side effect of these stacks is to create this this HCL JSON here. We do this by traversing the entire tree that we have of items, the entire graph of these constructs, and we call on each of the parts of the constructs a to Terraform method that we define that serializes the data down, and these are all combined, and in the end we get this HCL JSON. So you can see here in the beginning we have the required providers here. This is part of the CDKTF JSON, and it's inline here. So the entire file is like the only thing you need to deploy is this one file, and Terraform will know everything around that by just getting this one file. We see we have also like providers key that defines the Docker provider, and if we want to pass some parameters down to the provider, we could have done that and they would be here. And we have some metadata in the beginning just for us to know which stack this is, which version, and next we need the resources. So we have the Docker image here. You can see this long identifier we had earlier is used here as the key for this Docker image, and all the specification is on that level, and again with the double slash we have the metadata again that gives us an idea around where the thing is in the call hierarchy and what the unique ID is and so on, stuff we could need for debugging later on. And last but not least we have the Docker container, and you can see here that the Terraform reference string is used again. So we have the reference made from the image to the container. So Terraform will know when deploying that it has to first deploy the image and then the container. And that's how the internal communication is done. So Ansgar, how is this actually deployed in the end?
Yeah, thanks, Daniel. So let's see how we can deploy the stack. So we now need to interface with Terraform and do a bit more magic, maybe, to get this written config into the cloud. Not the config, but the resources provisioned in the cloud. So what we're now going to do is we're going to have a look at CDKTF deploy, and that one is going to first check which stack, as the CDK for Terraform allows multiple stacks, which stack is going to be deployed, and then it's going to invoke the Terraform CLI and let Terraform do the work for us, so we don't have to reinvent the wheel. So let us first look at the starting point for determining which stack to deploy. So when the synth is called or runs, there's also in your output directories like cdktf.out a manifest.json file written. For our simple example, it just contains a single stack, Python Docker, but it could contain more. And here we can see the synthesized stack path, which points the CDK for Terraform to the direction where the cdk.tf.json file is. And we need to tell Terraform to deploy this, or the infrastructure which is in that file. And when you invoke the CLI command, we do one more thing. So we also determine where the Terraform invocation is going to happen. So for example, if in that stack is a remote backend defined, that would be, for example, Terraform Cloud, we would check whether the Terraform Cloud workspace is a remote one, so with remote execution. And what this does is it wouldn't run Terraform locally on your machine, so the process, but rather in Terraform Cloud. And depending on that, we set our internal Terraform that we're going to use. The alternative is using the CLI one, so the locally installed Terraform, what you normally do. So I'm going to go with that. And yeah, let me proceed. So at one point we have this Terraform, which is now a wrapper for our CLI kind of, and we're calling the deploy on it. We're passing a plan file. That's something that would happen previously. We would need to look into the source, and it would, yeah, there's a lot more happening. But the gist of it is we're going to invoke this deploy, and we get some updates so that we can show in the UI when some resources are updating or finished updating or creating. And yeah, by this, let's have a look in the to the concrete implementation of this deploy. So the deploy for the Terraform CLI is going to invoke the Terraform binary that's available locally, and it's going to do a Terraform apply with autoproof set, because we ask our user first if he's sure that he wants to deploy that infrastructure. And so we're setting autoproof, so Terraform doesn't ask again. And then we're also passing state file options, so that's information we have where Terraform has its state, because that's different for the different stacks. That's something CDK CLI handles. And also the environment for the process is put in this spawn of the subcommand. So for example, you could set some TFVAR environment variables, and they would work in that stack. And yeah, let's look further as this is it. So now it's after you invoke Terraform, the resources are in the cloud and you're done. And by that, I gotta thank you, and or we gotta thank you for being with us today. And yeah, I hope you liked it. If you have any questions, ask us. If you find any issues, file bugs, check out GitHub, check out HashiCorp.learn, where you can learn more or do some guides to get started with the CDK for Terraform. But as you've heard this deep dive, we suspect that you have some prior things that already happened with the CDK for Terraform. So yeah, thank you, and yeah, have a nice day.
Welcome back. That was another beautiful session. So Ansgar, Daniel, you're both here, and I want to ask, 0.4 has been out for a while. When is 0.5 coming?
Soon. So the planned release date that's also visible on our GitHub milestone is, I think, Thursday next week. So yeah.
Awesome. In general, when we have new CDK releases, we also have office hours. I think yours is planned for the Wednesday next week, if I'm not entirely mistaken. Super exciting. The thing I like about your office hours is that you always bring a demo. So I have to ask, are you bringing a demo for next week?
Sure, we are.
Awesome. So new release, always exciting. Are you excited about that new release? Have you worked on any features? Is there something you're especially proud of, or maybe just like glad that it's finally out there?
Yeah, totally. We have some really cool features lined up. I'm currently working on a convert command. So a lot of all of our docs are HCL, obviously. And we want to make it super easy for users to use the CDK. So you just go to the docs, paste your HCL stuff over and run convert, and you get like proper CDK content out. You don't need to interfere too much with it. And you can also, when you initialize a new project, you can do it from a already existing HCL code base. So that should make testing it out and giving it a try super, super easy.
Should make things a lot easier. That is an exciting feature. I'm hoping that gets demoed during the office hours. Ansgar,
Sure.
do you have anything for 05 that you're excited about?
Yeah, I am, and I have. So I worked on a different topic. So there's a new CLI command coming up, which is called watch. And that one watches your source files and synthesizes them when you do changes, and also deploys them. So this is for the development and not for production. If you dare to, you could, but I'd rather use it with dev personally. And yeah, it's like hot reloading, but for infrastructure. And yeah, I'm very excited. And yeah, we will, of course, demo both of them next week.
I mean, that's half the IAC work anyway, right? Like you just fix it in post-production and production and live. That's the right way. Obviously, it's not. If you're listening to this stream and you're hoping to learn important stuff, listen to the speakers, not necessarily to me, because I'll make fun of stuff like this. But I'm curious, on the note of learning, you two work together. When you write code, obviously there's going to be reviews. How do you do reviews? What do you look for in code, and how do you determine, hey, this thing that Daniel wrote is good?
Should I go for this?
Yeah, please do.
Okay. So my approach for the first perspective is always I try to understand how the new code kind of achieves what it is supposed to. So mentioning that, of course, I most of the time kind of know what was trying to be achieved by that. So the goal of that change at first. But for our issues, we all have the context most of the time. So that's often a given. But afterwards, when you look at the implementation, you often kind of see some kind of edge cases that you, as someone who wrote it, wouldn't have seen it while doing it, because you're like, oh, I need to get this not done, but I'm working on these parts, and sometimes you kind of know, like, oh, okay, these parts work if I use them in a certain way, and for other things, always good to see with a second pair of eyes if something could have been left out. So that is one part, if there's something that was maybe glanced over. But on the other hand, I always want to understand how exactly the code works. So how the data flows, so for more complex features, for example. And also have a view of the experience that the user will have in the end. So if that was affected by it. So questioning, for example, whether the CLI argument sounds idiomatic or like something you would expect, or whether it's a bit could be seen or interpreted in two ways. So that's what I look for.
We had that for the convert command. I first had an input called file, which was for me the output file. And Oscar was questioning, is that output file, input file? What is it then? And now we converted to standard in, standard out.
Yeah,
I think that makes sense. I mean, those are widely understood terms, but they also might be, loaded with a lot of meaning. So I appreciate when people write software and think about how is the developer experience of this going to be, or well, I guess in this case, the user experience, because somebody using the CLI. I like this. Do you ever share do you have any videos or written material on how you do code reviews? I feel like we can all learn so much from one another by just seeing how other people do this. I'm curious.
Yeah, we actually recorded our last session. So the convert feature was pretty big and intense, and had a lot of interesting problems that need to be solved. And we did a review session, which is a deep dive with Ansgar posing questions around every corner and every niche. and me trying to explain the whole concept, what I built. And yeah, that's going to be online soon somewhere. Not sure.
Yeah, I really had to stop Daniel at a lot of times and go back and like, could you go back to these lines? What are they doing? So I really tried to understand and not just glance over it. So it was quite long in the end, but I think that's an interesting piece. And it can also serve for others in our team if they were like, okay, why is it the way it is? So they could view this or speed up or talk again.
Yeah, we'll definitely recommend speed up. It's 1.5 hours of full length and mostly us discussing implementation details.
You know, I don't think that's actually a bad thing. I mean, we all love the let's code sessions, you know, where you see somebody code something, but that, you know, is still very specific to what they're doing. Whereas the let's review, sometimes people have a lot more time because two people also see more than one person. And it's like, hey, well, I did it this way because I like that. We'll make sure to get that tweeted out when it goes live, because I think definitely in the spirit of build, this is very much the kind of thing that you want to learn from. Also in the spirit of build, what have you two been building in your spare time? Any interesting projects? Ansgar, I saw a couple of trees behind you. That looked kind of cool.
Yeah, but yeah, they were not that hard to install because I moved them from apartment to apartment for the last years. But yeah, for the first time, for this time, I actually built something because the ceiling is a bit higher here. So I had to build some kind of box beneath it out of wood. So that was very joyful. And yeah, there are also similar projects going on all the time. So I'm not that much into woodworking, like for the peers that do it in an artistic way and not like pixel perfect, so everything to the millimeter. I'm more like, okay, if it works, it works, but it's built out of wood, but not ugly on the other hand, so like kind of the middle way. But yeah, that's an example.
I think that's actually a good example. Woodworking is such a rewarding thing to do, even if you're not building it, you know, to the millimeter. And let me tell you, I'm exactly like that. I do it because it's relaxing and not because it needs to be pixel perfect. But as a quick preview, we'll have breaks later. And normally, you know, like in a break, you just get a countdown. We actually have a couple of HashiCorp employees who love woodworking record their woodworking studios and workshops. Let's call them workshops. Where you get to see some cool stuff. So, you know, while you grab your coffee, definitely check out the break video, because we want to show you how you can build stuff that's not just with code. With that, thank you two so much. I think we're ready for our next session. And in the meantime, if you have questions, feel free to join the YouTube chat, ask there. We're always around. And, you know, we'll ask them to our speakers. I think that that is definitely the nicest part. So with that, next up, we've got Thomas Herv from Datadog. And if we're ready on the backend, let's switch over and learn about how OpenAPI saved the day. And here we are. Sometimes switching things in the backend a lot harder than you might expect. Yes, we've done live events before, but sometimes things still go wrong. Thank you, Thomas, for staying with us, and welcome.
All right, let's do this.
So when you're ready, exactly. switch on over and the floor is yours.
Okay, let's go. Hello, I'm Thomas, and today I'm going to talk to you about the Terraform Datadog provider. So I'm the team lead of the integration tools and library team at Datadog, and I've been responsible for the maintenance of our Terraform provider for about a year now. We also take care of the various open source client libraries that Datadog produces to talk to our APIs. This presentation is mostly intended to provider writers, but hopefully to also anyone that have to maintain SDK and API documentation. So a little bit of history of the Datadog provider. It was first published in 2017. Since then, it's been heavily used both internally by our SRE engineers, but also by customers to manage Datadog resources. So like monitors, dashboard, dog configurations, or semantics tests, the list can go on and on. In 2019, we realized that it was getting tough to keeping up to date with regard to new products and new features that our backend teams was releasing. A new feature required a change to a third-party Go library that's maintained by the community, and make a release of that library to be able to use it in the Terraform provider, and then only then you can start changing Terraform code. So we wanted to improve that workflow. And it also fits in the general story about improving our API documentation and our SDK to make them more accurate and more up-to-date with regard to the backend implementation. And so we looked for solutions that could help us. And that's where OpenAPI enters. OpenAPI give a way to document HTTP API in a language agnostic interface. And in practice, it's a YAML document which contains all the endpoints that your HTTP API produce. And for those endpoints, you can see that you have the request, its parameters, the response, the authentication scheme that it's going to use, the errors, everything that's going to help you to consume that API. So here's an example of a Datadog API, the list dashboard. So we have some description that's going to help understand what it's doing. The operation ID, that's very important for SDK. The parameters for the request and the response. And here you see you don't have the response directly, but you have a reference to an external resource that's going to be defined in the schema elsewhere. So using that document, you can then generate code and documentation that customers can use to talk to your APIs. So we first look at a project called Terraform Provider OpenAPI. That's a very interesting project that I recommend looking, but the system that it uses is that it generates the provider at runtime, which is an interesting approach, but for our purpose, we wanted to be able to transition the existing code base without breaking users, so it was not an option. We wanted to have something that's not runtime based and something that's more static. So we chose OpenAPI Generator. So what is OpenAPI Generator? It's a Java project which runs templates to generate code in your language of choice. You feed it an OpenAPI specification, and it parses it to create a Java model, and then feed that Java model to templates to be able to create concrete code files. So it supports more than 100 client and server generations, all the common ones, Java, Ruby, Python. And in particular, it has a really good Go client support that's very interesting for us for the Terraform provider. It has various entry points directly using a Java executable, but you also have a Docker image that's provided for us, and even a public API, so you can generate code without installing anything. In our particular case, we did have customization that we needed to make, so we couldn't use the public API. So we chose the Docker image that allows us to generate all the SDK that we're interested about. So it's a little bit like under the hood what happens. That's a concrete example. So you have a sample template section at the top. You may recognize that's a mustache template. You have all the sections that are going to be rendered at runtime. And you feed it the OpenAPI specification, so like the ones we saw before. And here you see the example for the list dashboard endpoint. So it's going to replace the operation ID and the data return and replace it in your template and generate a concrete signature. Obviously, we have hundreds of lines of templates and hundreds of generated code that goes with it. So what was the migration? So the first phase was twofold. One part was to document all the APIs that we needed in the document, the Terraform provider in OpenAPI. So that was probably the toughest part because we didn't have any OpenAPI documentation matching our backend. So it was a really long and tedious process. In particular, when you create an API without having OpenAPI in mind, you have several constraints of OpenAPI that are going to be tough to model. So we had to take the API into consideration and see how they could fit into the API model after the fact, which was tough. And that took us a long time to do manually. And in parallel, we started generating our Go client. So that lives at that repository, Datadog API Go client. And we had to make contribution upstream to OpenAPI generator because we have some particularities like API living on different backends. We also wanted to support our authentication scheme directly. So we contributed those upstream to make sure that it was able to generate a Go client that fit our needs. But after a while, we had a working Go client with all the needed API. And so we started introducing it in our Terraform provider. So we were able to replace all the previous API calls by calls to the new library. And that part was relatively smoothness compared to the part before, and mostly because we have extensive testing in our Datadog provider, and that's what I like to talk about a bit. So provider testing is really critical to make sure that when you send your provider to customers, it's going to work as expected. And we have a large amount of tests in our provider. We use a testing organization in our real deployment, and that allows us to run the full workflow resources for real against the real API. And those tests were a real-time server in the migration because we're able to automatically check that changing from the old client to the generated one didn't break anything. And we had good confidence that we could make the change and not break users. Some of those operations in our test are not cheap. So we also use another technique that we call cassettes. We record all HTTP interaction happening in test using a library that's called GoVCR. So it creates a big YAML document that contains all the HTTP requests and the corresponding response happening in the test. And we also store the time at the test, at the time of the test. So with those, we're basically able to replay and mark all the HTTP calls happening in the test and without eating the network for real. And that's a tremendous time saver for various reasons, because once we have the recording, we can focus on the Terraform data structure handling, which can be difficult at times, without any network calls and the reliability issues that come with it. And then you can also focus on testing that the Terraform state is populated properly. And again, without any API calls done for real, without any resources created in your backend. And this also has the benefits that we know exactly what's done by resource during this life cycle because we see all the API calls that are done. So when we see a new request appearing in our recording, you can say, okay, why is this new request happening? Is it because of that new calls? Does it match what we expect? And when an existing request is modified, you can check what are the new parameters that are changed, or if the body payload is changed, we can quickly pinpoint exactly what changed. So that's a good sanitizing phase on top of our existing assertions in the test. Another tool I wanted to mention is Terraform plugin doc. That's something that was released by HashiCorp last year. It generates the Terraform documentation directly from the resource schema and from given templates. So you can see an example here. You have the schema of the priority element, the description, the type, and the fields that are specific to Terraform, optional, computed, required. And it's going to generate some markdown containing all the information that the user needs to be able to actually use that resource. And previously, we had to make sure that the documentation was in sync manually. So this is a great time saver again. And because at release time, we just have to run a script that generates all documentation, and it's going to update our markdown, and then we can publish the registry and everything is in sync. So the next step for us after we migrated our client to using our generated client is to look at how we could improve creating new resources. So we wrote a custom OpenAPI generator that goes directly from the OpenAPI spec to the Terraform resource using the calls of the generated SDK. So that's using OpenAPI vendor extension. That's another thing that really nice with OpenAPI. You have ways to add custom annotation in your specification. And those annotations are surfaced by OpenAPI generator, so you can use them when you create a generator. And this way we can identify the schema that's going to be used for the payload, and then we can identify all the operation that maps to resource, so the create, update, and delete phases. So for now, our generator doesn't generate completely functioning code. So it generates a functioning schema and all the method boilerplate that's used by Terraform, and it also generates test skeleton. But it's a very fast bootstrapping phase. That means you can create a new resource from scratch very quickly, and then you just have to fill some logic and fill the test, and you have functioning resources directly from the OpenAPI specification. So here is a quick schema explaining the workflow. So when you have a change in OpenAPI specification, you have the Datadog API client Go, which is one artifact generated by OpenAPI generator. And on the other side, you can create new resources using the Terraform Datadog CodeGen project that we have internally in OpenAPI generator to create new resources, and also Terraform plugin doc that helps us generate the documentation as well. So what are the next steps for us? The main thing is to be able to keep our OpenAPI specification up to date. As I mentioned, we have to write it manually, and we still have to maintain it manually today. And that's a pretty tough process. So we want to close the gap with the backend code to either generate part of our spec, or at least be able to detect drift between the spec and the code, so that we're able to detect when a code change is going to require a spec change in the future. And I think that's the main part. If I had a magic wand and I wanted to change something, it would be, if we started from scratch using OpenAPI, we'd have a process in place that would allow us to keep both in sync, and we would be in a much better position. But that's how it is. So Israel's lesson is to start to think about SDK and documentation of your API from day one. And the other thing we want to improve is the Terraform embedding process. Because we want product teams directly to take care of the resources in our provider. So it's important for us to have a really smooth process so that they can quickly write code and write tests, and everything is easy for them to push their new resources in the provider. So as the closing note, I want everyone encouraged everyone interested to check out OpenAPI generator, which Datadog product sponsors. Thank you.
Generated code is definitely a nice and useful thing. Let me quickly stop your screen share so we can actually have a conversation.
Okay.
And that should work. There we go. Beautiful. First of all, thank you for sharing this. I like generated code because, as you mentioned, it's so much easier to keep things in sync across multiple areas. And a lot of us are looking to generated code because it's a lot easier to build that part, early in the chain rather than like way down the chain, just basically when you're at the last part and consuming it. So I'm curious, if I want to build a generator myself, what's 1 or 2 points that you would give me for any API?
So, I mean, again, I want to strongly encourage for you to look at OpenAPI generator, because it probably has the client that you're interested in about. So there's generally something that you can start from. And in terms of general guideline, I think do it early, right? Don't wait until your APIs has 150 endpoints to start generating them, because you're going to have some issues and it's going to be tough. So, right,
Okay.
like think about it from the get-go, and then see how you can give a SDK to your user early and see how it works, and have like quick feedback loop again. I think that's the key here.
I think quick feedback loops are definitely good. And starting early with generated code is always going to be a lot better. Thank you for sharing this. Very beautiful. If you're a Terraform user, and this one is for our audience, and you do monitoring and observability and you use Datadog, definitely check out the Terraform provider. It is by far the easiest way. And I'm not saying this because you're here, but because I've used it. It is beautiful, it works, and it works well. And that's how I want my Terraform to be. I'm a huge fan of codifying my infrastructure. And that's not just my virtual machines and my storage, but literally everything. So thank you for working on the Datadog provider. And yeah, for our audience, give it a try. It is worth it.
Thank you very much.
Thank you. And with that, we're going to switch to our next speaker, Tom Harvey, who's joining us from Germany today, I believe. And actually, no, sorry, my bad. I completely missed my schedule here. We're going to switch to Kyle first, Kyle Ruddy, who's going to share a couple of fun things with specifically Terraform and about sensitives in Terraform. So if we're ready, let's go.
Hello, I'm Kyle Ruddy, and welcome to this HashiTalks session. Excuse me, there's some sensitives in my Terraform. And while the title might be a little tongue-in-cheek, hopefully you've noticed over the last couple of Terraform releases that there's been a tremendous focus on sensitivity and handling sensitive values. So when I came up and pitched this session, I was like, look, Kareem, sensitives, they are everywhere. And really, that's never been more true. So if you think about it, variables and outputs can now be marked as sensitive. Providers and modules have built-in sensitivity support. Functions can even be used directly inline in your Terraform configurations to mark values either as sensitive or to remove sensitivity. And then, of course, there's a state file, but I'm excluding that from this session because I particularly feel that state files should always be treated as sensitive. So let's jump into our demo and take a look at the top couple bullet points and see how those react to handling as sensitive. So here's our demo environment. We're going to be making use of the random provider to have a little bit of fun. So we'll start off by creating our control resource here, in which case we've been given the trusty BAS. So now we're going to update our configuration here to include a sensitive variable. So now if we see here, we have a new resource block there. And if we jump to our variables file, we have our sensitive variable with the sensitivity attribute marked as true. So if we go ahead and do a Terraform plan, we will see that our prefix there has been marked as sensitive and been redacted from the output. So now we're going to update our outputs so that we can now see what how that interacts with our Terraform usage. So we'll jump over to our outputs file. Here we have our sensitive pet, and our sensitive attribute there is also marked as true. So we can go ahead and rerun our Terraform apply, in which case we have one new resource that has been added, and we see that our sensitive pet has been marked as sensitive and redacted from our output. So now let's jump into the provider support, because we can actually continue using the random provider to go ahead and make use of the random password object, in which case we can see here, and thanks to some IntelliSense, we see that the result is treated as sensitive by default. So it's not going to be displayed on our console output. And of course, we have to update our output here to include the sensitive attribute for that password. So now we can go ahead and rerun our apply. So now we have our trusty BAS as our control. We have our password that's being marked as sensitive, even though we have seen that it's been added. And then we have our sensitive pet. So let's move on to our next area, which is going to be sensitivity support for modules. So in this case, we're going to be creating a couple additional randomized pets. And in this case, we've created a module that's called random zoo. So we're going to be using the count function to create 5 different animals with the prefix of Tampa, because that's where I live. And let's check out our module here. The main configuration file is fairly basic, just one simple single pet that's there. Then we have our variables file where we call out the sensitive attribute, then set it to false. Even though that's by default, I did want to spell that out. Then we have our outputs, and this is where we define our output being sensitive. So when that gets returned back to our configuration, it will be marked as sensitive. So now we can go ahead and run this. Oh, need to do a Terraform init real quick. And now we can run our Terraform apply, and we have 5 additional animals and resources that have been added to our configuration output. And we can see that our zoo output has also been marked as sensitive. So now that we've done all these things that involve sensitives, let's start, maybe removing some of the sensitives. So let's switch our branch here. And we'll be using a function. So here we're taking advantage of the random shuffle, staying within the random provider here, and we're going to be using the non-sensitive function and applying that to our zoo pets response from our module in the previous step. So we can actually see what those random animals that were created. So we're going to hit apply on that. And we can see that now, thanks to our shuffle output, you can see that the primary lemur, close termite, maximum wasp, upright buck, and good fly have been created as part of our configuration here. But now we're going to go back to our control, and now we're going to make that sensitive. So if we go ahead and switch our branch here over to that, and then switch into our outputs. Oh, we need our outputs from our main configuration file, not our module. We can see that we have our sensitive normal pet, which is going to just take that random pet that we created in the beginning and mark it as sensitive. We can now run the apply and see that we still have our trusty BAS that's set as our normal pet, but now we also have our sensitive normal pet that is using the sensitive function to now mark that as sensitive for our output. So that was a really quick run through some of the usage of sensitives within Terraform configuration files, even if they're provider-based, module-based, and so forth. So to learn some more, check out the Terraform docs, the really great resource for the different areas. My demo code has been available on GitHub through our link right there. And then, of course, check out the HashiCorp Learn Guides. There are even a couple walkthroughs that focus on sensitives. So with that, thank you.
So as we look at these sessions, you see pretty good content, you see really great content, actually, most of the time. You just don't expect somebody to put in a Toy Story picture like that. Thank you, Kyle. Thank you very much. That was actually a beautiful explanation. And I'm excited about having zoos around. So I think now we're going to switch to Tom Harvey, who's in Berlin. If you ever make it to Berlin when travel is a thing again, or if you just happen to live there, definitely check out Berlin Zoo and get the history of that. With that, I'm excited to introduce Tom Harvey for our next session. He's the engineering lead for the Microsoft Azure provider for Terraform. And I actually don't want to take away from your session, so let's just switch over.
And I'm here to talk to you today about the typed SDK that we have in the Azure provider that we're making use of to build resources. So the Terraform provider for Azure makes use of the Terraform plugin SDK, as does every other Terraform provider. And what we've done, whilst it works very well for us over the years, one of the things we've been doing recently, because we have a lot of Azure specifics, is to wrap that to be able to give us a more strongly typed experience, which means we have access to things like autocomplete and just generally reduces the amount of code that we need to use when developing resources. So before I get started, I want to call out a couple of things. The first is that the typed SDK lives within the Azure RM provider repo. So if you go to the Terraform Azure repository, Azure RM repository, and go to Azure RM internal SDK and README, there's this README which tells you basically how this works at a high level. We have this concept called service packages in Azure. These basically map to different resource providers in Azure. So compute, networking, notification hubs or event hubs or whatever else. And we add these, as we need to. The benefit of this, it means we can split our code up quite considerably. And so if I jump over to the code base, what it means is that we can have, for example, front door is just the front door resources, which is helpful when you get to some of the larger resources like networking or compute, where there are considerably more. And this is something we're breaking up over time. It just makes it easier to move forward with those essentially. So yeah, as I mentioned, the typed SDK is something that we have available. What we're going to be doing today is building a resource with that. So I've created a service package here called HashiTalks. Service packages for us are located inside the repo Azure RM internal services, and then there's a list of packages. In the interest of time, I've pre-created like an empty package called HashiTalks. What we're actually going to build here is a Terraform resource to create a resource group, which we already have in the provider. But this is, a fairly simple example. But this works for any kind of resource, which is really neat. So the first thing we have when you talk about resources in Terraform is the actual resource itself. Now, if we take a look first at the actual resource group resource, if we go to resource, which is where the resource group resource is, today this is it's a generic Terraform plugin SDK resource, right? It has create, has read, update, delete, importers, timeouts, etc., the schema, and then functions for those. And this works great. We use this all over the place in the majority of the provider. What we come to realize is that there are certain bits that are specific to Azure. For example, in Azure, we validate the ID at import time. So we know, for example, in this case, it's always going to be a resource group ID. And we know that because of the way, every resource in the Azure provider supports timeouts, so we always have timeouts. And whilst these are available in the Terraform plugin SDK, they're optional properties today, so you have to remember to go and add whatever it is you need to add. So this works great. What we've done is extend this slightly. So we have this typed SDK, this strongly typed SDK, which basically allows us to use native Go types and the Terraform plugin SDK together. So what do I mean by that? Well, this is the README as I mentioned earlier. Basically what this means is we can use the actual Go type here for a struct, and then there's methods that fall off of that. So for arguments, attributes, the resource type, how to create, read, update, delete that, etc. And there are actual typed methods, which is nice because it means, again, you can get autocomplete for these things. So if we switch over to the code, and if we go to this empty package that I have available, what that means is we have, and this is a very basic example, I have an empty struct here called resource group, and it complies with this interface called resource. Now we have 3 available in here of data source, resource, and resource with update. So data source is a Terraform data source, which is just read-only, essentially, getting me information about an existing resource. There is a Terraform resource, which will create, read, and delete a resource. And there is resource with update, which is just a resource, but with the additional update property. But yeah, so what's nice is because this is just a generic Go type, they automatically, start that again. Because this is just a generic Go type, we get autocomplete on these because the type, the struct here, resource group, resource doesn't comply with this interface right now. And so we can do methods and it'll give us the template, the scaffold of methods. But the nice thing about Go is like you don't necessarily have to do that. If you were to comment that line out, because the resource group, resource struct implements all the methods, it's automatically implementing that. So the benefit of this line for us means essentially you get autocomplete. So if we decide later on that, hey, we want to add or remove this new method signature, we can do that. Or if we decide this needs to update, for example, we can do that, go, hey, we need to add this update function, go do that. It's a minor enhancement, but it's kind of really helpful. So let me take you through these methods in turn. So essentially, arguments is the Terraform schema that is mutable. So that's all top-level objects and any items nested under them that are mutable in any fashion. So for example, the top-level name, location tags, there may be objects within that, like a virtual network would have a subnet block, for example. That would all be housed within here. Attributes is then read-only values, so computed values for us. There's not much point splitting these apart. These are split apart primarily for technical reasons. It just makes it easier when we generate the documentation later to know that, hey, we have these that are arguments and these that are attributes. It's minor, but they work great. It works for now. We then have a model object, which we'll come to in a moment, or a little later on. The Terraform resource type. So this is the actual resource label itself. So Azure resource group, for example, or something to that effect. And then 3 functions. So create, read, and delete. These are all the same. These actually return this type of SDK.resourceFind. And if you dig into that, these then return 2 fields for us. The first is a timeout. So I mentioned in the Azure provider, everything supports a timeout by default. And so for us, this is just a way of us guaranteeing it. All right, so we can say the create should finish within 30 minutes by default, but this allows users to override them as necessary. The other one is then the function itself. So this is the create function. And this is where it differs a little bit from the plain Terraform plugin SDK resources. So whilst we have this metadata object available, and what this basically does is wrap Terraform resource data with a couple of other things. So the first is the client that's available today in the Terraform plugin SDK as meta, and you can cast the client and do what you need to on it. The other one is then resource data, which is like the D property in the Terraform plugin SDK today. What this means is that you can use the Terraform plugin SDK as you do today, completely, for free. It's here. It's get and set and all the other bits. There's also a logger and a couple of other helper entries. We'll come to those in a bit. But yeah, this means you can have warnings, info, and it's pretty convenient in that regard. Finally, we have an ID validation function. Now, in the Azure provider, we are moving towards generating Terraform, or generating the resource IDs within Terraform. What do I mean by that? Well, we have this resource IDs function, or this resource IDs file, that uses Go generate to run a tool we have, which generates an ID parser and an ID validator for a specific resource group, or for a specific resource ID, sorry. So in this case, we're creating a resource ID parser and validator for a resource group. So we give it a name and we give it an ID. So in this case, this is just placeholder data. But these are just generated. So if we run, if we generate that line, or if you run go generate on the command line, it'll then output an ID parser for us, which will then take where are we? So parse resource group ID. If you pass in a resource group ID, it will parse it and validate it has all the sections, right? It has a subscription, it has a resource group element. And if it was like a hypothetically a virtual machine, we check that the virtual machine segment was present, that type of thing. But there's a couple of other nice things in this. The first is that there's an ID on this. So this means that we can basically template the values out of this. So whilst we can parse it, we can also build this up at the same time. So taking the subscription ID we know and the resource group ID we know. It also means for things like errors, we can then use this descriptively there. So we can say output, we know this is a resource group. So if we fail provision, we can go, retrieving with a format string, and then that then gets translated to, resource group with all the segments inside of it. So it's much cleaner for people to read, and it also means there's much less code for us to manage within the provider, which is nice. The other thing that gives us is an ID validator. And again, both of these are generated with test and all the rest of it. But this means that inside of Terraform schema, when we reference these resources, or when we reference this inside the Terraform schema, we can validate that we're passing in a resource group ID, for example, if we're requiring a resource group. And other things to that effect, which is kind of nice. So yeah, there's that. So ultimately what that means is that we can use ultimately what that means is that import time when we're requiring the resource ID, or when we're checking the resource ID, rather than defining it on each resource itself. So to go back to the resource group, resource, you have an importer, and for us, that means that, we validate the import, the resource ID matches what we expect as a resource group ID in this case. And then, then do a Terraform import. What that means is that we can do that automatically. So if we go out to the typed resource, what we do here instead is to return the validation function. So validation.resource group ID. Make sure I pick the right package. Oh, validate, sorry. And if we import that from HashiTalks package, what that means is when this resource gets generated, or when this resource gets built up, we can validate at import time that the ID that's being passed in at Terraform import is actually a resource group ID. Which, yeah, it's kind of nice. So what it means is we cut down the boilerplate there. So that's a typed resource. The next question is, what does this look like in practice? So what I'm going to do is to go to one I made earlier. And this is just a Terraform resource right here. And this is all the methods that you've just seen, just completed because it was quicker to type. I'm just going to add the imports because that is useful to make it compile. Yeah, and so what we have here is, again, pretty much the same resource you saw as a general Terraform plugin SDK resource. So this is the attributes that I mentioned are mutable. In this case, this is force new for now. This isn't in the actual resource group resource, but we'll come to that in a moment. There's no computed any attributes on a resource group. It's just name, location, and tags. So there's nothing to return there. There's no model object, which again we'll come to in a moment. Resource type, we already have a resource called as URM resource group. So in this case, let's call it as URM HashiTalks demo. And then a create function, which in this case, this gets the resource group client from the Azure SDK, gets a subscription ID from the provider block, and then obtains the information the user specified in their config, so name, location, tags. We then build up the resource ID, which uses the generated parser that I mentioned earlier. So in this case, this takes the subscription ID and the name. This means that we have a consistent resource ID within Terraform, which is nice. There's some Azure specifics in here. In that when we're creating a resource, we check for the presence of an existing resource. And if an existing resource exists in Azure but doesn't exist in the Terraform config, or doesn't exist in the Terraform state rather, we'll require you to import it just because of the way the Azure APIs behave differently in some cases. So yeah, we do that. And then otherwise we create it, right? We normalize the location. So that is like West Europe gets translated to West Europe, just for consistency there. Do the tags, and then the creator update. As I mentioned earlier, we're reusing the string value of the resource ID type that we created, or that we generated, which means that we can cut down on the error messages here too, to just say creating this thing. And ID here is, again, the resource group type, which has all the stuff inside of it. Cool. So yeah, all we do in the create is to create it, set the ID, and then return nil. Inside of the thing that calls these type resources, we automatically call the read for you. So the only concern here is actually just doing the create, which is another, like it's a way of avoiding bugs when you may accidentally call the read function of one resource from another. It's kind of nice. So you can avoid all that. So read is much the same, and delete is much the same. They're kind of standard Terraform plugin SDK things at this point, and the ID function is the same. So as I mentioned earlier, if we have an update function here, again, we'll get autocomplete for that. I am going to add one I created earlier, which again, exactly the same as before. So that will work. That's usable in Terraform right now, and there are tests which are basically the same as the resource group to this effect, which is governed nodes. So what this does again is just its standard Terraform configuration is here's a provider block, here's the actual resource to create, go create that thing. So this is great, but the main benefit here we get is that we can reduce these d.get and these d.set calls. So this model object that I've been kind of alluding to, we can actually return an object here. So we can do, if we create a new struct called resource group model, and we add some options in this. So if you look at the schema, we have, again, name, location, and tags. And we can add a special struct tag here called tf schema for name, for location, schema, and these map one-to-one. So what this means is that we can say, these map one-to-one. So that the name inside of this struct tag here refers to the Terraform schema object. And these can also be other objects. For example, if we have a list of, subnets as an example, you can reference other objects here as well. So subnet struct as a hypothetical example with a name, tf schema, name. This then just becomes like, this is a generic Go object. So we can say there are a list of, subnets, which is then subnet, which is then tf schema, subnet as an example. And presuming that exists in the config, what that means is that we can access lists, sets, tags, and dictionaries and all the other stuff that we're able to in the Terraform plugin SDK today as an actual Go object. So how do we do that? So if you go to the resource group model, or we take the resource group model that we've just created, and if we go to the create, and if I just expand all the things, that'll make it a little bit easier. So the first thing we're going to do is to define a variable for that model, right, from the Terraform config. And then using one of the properties available on metadata, there are two methods on here of interest. There is decode and encode. In the create, what we want to do is decode the Terraform configuration. So in this case, you need to pass a pointer. And what we're going to do is decoding config. If there's an error, we'll just say there was an error decoding the config. So what that means is that we don't need to write these d.get and sets directly inside of the Terraform config, what we can do is deserialize the Terraform config into this type. And then rather than passing in, or rather than doing d.get, as I mentioned, we can then do config.name in here. And config.location and config.tags. And that will work as before. And if I do the same in the read, or actually let's do the other functions then first, then we'll come to the read. The delete has no changes because it doesn't call get or set. The update does. So we'll do the same thing here. We'll do model config, sorry, resource group model. If errors not null, metadata code. Okay, so yeah, at that point we have that. Rather than then accessing tags directly, we can then call config.tags. And then finally the read. So that handles the decode, but the read is creating a new object, right? So again, there's not much that changes here, but what it means is that rather than calling d.set or metadata.resource.set, what we can do here is to do metadata.encode and then pass in the actual resource group model. And this has the three fields, right? This has the resource group name, which we pull out of the resource ID. This has the location, so location.normalize nullable, which comes from the response, which again transforms it all to lowercase and without spaces and stuff. And then finally the tags, which is then tags.flatten, and that then takes resp.tags from the response. And so what that means is that we no longer call .set with these Terraform schema names, or these Terraform schema fields all over the place. What this means is we have this actual object here, which is pretty neat. So we haven't actually seen this in action yet, so I guess that's the thing to do next. So in each service package, we have a folder, we have a file called registration.go. What this defines is either a regular plugin SDK registration, for example, this one for HSM, which either defines a list of plugin SDK data sources and resources. We call these typed and untyped just to keep them simple. In the typed case, again, I'm ensuring that this struct for the resource registration complies with what we expect. So it's, they have a name, HashiTalks, any data sources and resources. But the major difference here compared to HSM is we're not defining the actual name of the resource, the label of the resource within the registration. What we're doing is we're keeping everything encapsulated in that resource, which is kind of convenient because it means that everything, it just makes it easier. And we just define an instance of that resource here. Now, I realize there's one thing I've just missed, which is that whilst we've defined the model, the one thing we haven't done yet is the method that I've been jumping over for a while, which is this model object. So if I return an instance of that, basically a type of resource is essentially just a generic Terraform plugin SDK resource that we wrap and add some validation to and just generally try and reduce the amount of code that we need to write. But one of the things we do is by returning this object or returning nil, in which case we skip this check, what we do is we validate that all of the fields that are defined in this model actually exist in here. So what this means is if I put a typo in here accidentally, it'll compile correctly and everything, but when you launch the Terraform provider, it'll come up with an error and say, hey, we know you've defined name, and it's location, and it's actually, you've got a typo here. So we know there's a field missing, which is a small thing, but it's very convenient because it means at runtime with the provider, not during provisioning of a resource, you can know that the Terraform schema doesn't match. And so you get much faster feedback that way. And ultimately less code and autocomplete and all the other things I mentioned. Yeah, and I guess the final thing, because this has an update, the final thing I miss is that tags needs to become mutable. Anyway, so we're going to do two things now. So this resource is successfully built. The first thing that we're going to do is clean up the test that I did earlier. The first thing we're going to do is run the test that I mentioned earlier. So what this actually does is to, wrong file. What this actually does is to create a Terraform, or create a resource group using Terraform. So let's kick that test off. That's the first thing. The second thing is that if we then go to this Terraform config, and I'm going to create this called 99 because why not? So this is just a regular Terraform config that creates a resource group. And if we come here and we do Terraform apply, because I'm using a local development binary, actually, I guess I want to compile that. That would make sense. Don't do that. So if we compile the provider, make build or go install works. So we have the test kicking off, we have the providers compiled, and if I then go and run and try and create a resource group with that, hopefully it works. It should work. Okay. So Terraform is going to say I need to create it, is that okay? Put that yes. Cool, it's going to go create it. And if I run Terraform plan, there should be no changes. Yeah. Final thing we'll do is just add a tag just to prove the update works. Normally we would have more tests for this. At the moment, all the test is doing is just creating one of these. It's not doing any updates or anything, but that's fine for test purposes. You know, yeah, pools well. Apply. Yeah. Every time. Cool. If I go through and run Terraform apply for that, double insert once I have the tags, which should then work. Cool, and that works. And our test should be complete in a moment. Tearing down a resource group can take a little while because it deletes everything inside of it. In this case, there's nothing, but it can take a minute or two to replicate on the Azure side. But yeah, so that's a typed resource. All the documentation for this is inside of the provider, or it's inside the provider repo. At this point in time, we have a few resources using it, and we're using it for some larger stuff going forward. But yeah, the nice thing is, as I mentioned, this reduces the amount of code that we need to use, reduces typos and little errors like that. And yeah, and means that we can use strongly typed things, which is kind of nice. So we're hoping to use this more going forward. And it gives us a couple of guarantees as well, specific to Azure. So for example, the context that gets passed in always has a deadline. The resource, you will always have an importer, you will always have a validate function. It's pretty nice. It's working out pretty well for us. I think we're gonna have to take my word for these tests passing, but yeah, so that's a type of resource in Terraform. In the Azure provider. If you've got any questions, feel free to join. There's a Terraform Azure Slack in the README. Where are we? So feel free to join. But yeah, we're using that for resources going forward, which is kind of nice. So thanks a lot for your time. See you.
That was a very nice session. Thank you so much, Tom, for joining us. You should also be on our Zoom at this point, which is awesome. So let me make sure you can actually join us for a quick round of Q&A before we head into the first break. And there we go. Hello, Tom. Sweet. So I'm curious, how many resources are using this way or are being built this way at this point for the Azure provider?
So we're at about 10 right now, but rolling out for all new resources or for the major resources going forward. So one of the things we're doing at the moment is taking a look at the web packages or the web resources within Azure. That is things like app service, service environment, app service plans, static web apps. They're the kind of the hosted site offering essentially. And we're redoing those as type resources. So we are planning to adopt this going forward, but we're doing it in kind of a major way, particularly with app service. So it's working out really well so far.
It definitely looks impressive. Is this something we, as in HashiCorp, is planning to roll out across more providers? Is this just for this one?
Yeah, so at this time, this is primarily for the Azure provider. We are using this in Azure AD as well, and we'll see what the future holds there. But the nice thing is this allows us, because these are actual Go functions, and we could autocomplete, it means we can do things like, if there's code that could be reused, we can do that more easily. We can have inheritance for classes. So it kind of dramatically reduces the amount of code necessary, which sounds like a kind of minor benefit, but actually when you're talking about the size of the providers we have in terms of, AWS, Azure, and Google, it starts to become a problem. So the less code you have, the better in that regard, which is really handy.
I think Tomas from Datadog was just making a really good point. Start early when you're doing auto-generated code and don't wait till you're 150 resources in. I know the Azure provider, not Azure AD, has more than 150 resources already. So yeah, I'm glad this is going this way. Definitely exciting. With that, thank you so much, Tom. We're going to be heading straight into our first break. And, normally I know you would totally check out, but if you're into woodworking, definitely hang around and check out some of the cool stuff our folks are building. And we'll see you back here in about 10 minutes. Welcome back. If you had a chance to check out those woodworking videos with Paul Banks, what do you think of them? Let us know in the chat. When we did an internal call out for them, I was hoping, somebody would do something cool. I wasn't expecting somebody to actually use tools that were made 110 years ago to do something, because, the geek in me appreciates that. But hey, we have a new face here. Mary, welcome to the MC crew. Glad to have you. You've been on our community office hours, but for those that don't follow those, what do you do at HashiCorp?
I am a product manager for the Terraform AWS provider. And prior to that, I did support for all of the Terraform products. So some of you may have met me in either of those two capacities. And
you've been at HashiCorp for more than 5 years, so congrats to that.
Thank you.
It's cool having the same faces around for a long, long time. It's nice. And it's also nice to see the company grow and see, where Terraform, which I think started off with the AWS instance as a first resource, now is... We actually, when we talked with Tom, we talked about how many resources there are in the Azure provider. I'm curious, how's the AWS provider? What are you currently at?
I think we just surpassed a total of 1,000 resources and data sources. So we have about 715 resources and 300 something data sources.
That is a mind-blowing number. I see what you're doing there. I'm guessing you're racing the registry for amount of providers, right?
We definitely are, and we are definitely pushing the limits of registry documentation pagination.
I love it. I love it. This is amazing. So one question that we'll definitely get is, how do I get my favorite resource into the AWS provider? How does that work?
Great. So best way, file a GitHub issue. We will take a look at it. One of our engineers is on a weekly rotating triage. After we see a GitHub issue, we give it a little bit of time to pick up steam in the community. If you are a HashiCorp Enterprise customer, you can also reach out to your customer success manager or the solutions engineer working on your account, and then they can reach out to me internally. But all of us on the team spend our time in GitHub, so the best way for us to see it is to file a GitHub issue, and we'll take a look at it and hopefully leave a comment.
That is definitely a good call out. And in general, if you're following along with our stream, I'm sure you're somebody who likes to work on Terraform providers because, it's cool and it enables a lot of new opportunities. So definitely check out the GitHub repositories, check out the contributing guides. I know a couple of teams put a lot of thought into writing really, really nice documentation that makes it very easy to understand how you can add things. Hans did a call out earlier. I know Mary's team definitely has some great documentation in there. I'm sorry for putting you on the spot here, but I link to it often because people find it very helpful. And I think that's definitely important. With that, let's continue with our day. Next up is Philipp Strube, who's going to be talking about integrating Kustomize and the journey from essentially provisioners to providers.
Hello and welcome to my talk. Today I'm going to talk about my journey from provisioner to Terraform provider, integrating Kustomize into Terraform and the KubeStack framework. I'm maintaining an open source Terraform framework called KubeStack. And when I say framework, I mean that in the exact same sense as Spring Boot is a Java framework. Right? Just like this, KubeStack is a Terraform framework. And similarly, just like Spring Boot aims to provide the best developer experience for building microservices in Java, KubeStack aims to provide the best developer experience for building Kubernetes-based platforms using Terraform. As many of you will know, a Kubernetes-based platform will always consist of both cluster infrastructure resources as well as what I call cluster services. So services that need to be running on the cluster before you can deploy application workloads. Examples of this are monitoring daemons, log forwarders, service mesh, ingress controllers, policy enforcement, all these kind of things. And I believe in order to have a robust workflow, it's important that you can promote both cluster infrastructure and cluster services through these environments simultaneously. And so with the KubeStack framework, any change starts in the review process. Review means you send a pull request and ask for a peer review. And for the peer review, you have the code changes to review as a team. And additionally, you get a Terraform plan. What changes Terraform would do to the ops environment if you were to merge this into main. If you actually merge this into main eventually, Terraform will run an apply against the ops environment to validate that the changes do apply correctly against real cloud infrastructure and Kubernetes resources. From there, depending on how you configured the framework and how many environments you chose, you can promote that exact same change into the next environment and possibly the next environment. So on the slide here, I have two environments that run application workloads. One called apps, which you could use to run only dev and staging application workloads, for example. And then one called apps prod, where you would run production application workloads. And just like you can configure one Kubernetes cluster and its cluster services in each environment, you can also have multiple clusters, either for multi-cloud or multi-region setup, or because you want to have different clusters per team in the organization, or something like this. So the first implementation, in order to be able to have cluster infrastructure and cluster services moving through the environments together, was a provisioner-based approach. If we go back 2 years to February 2019, this is how the integration looked back then. We would have two data sources, one customized build data source, which basically was given a path to a customization and then would run customized build and write the output to a file in a specific location, and a data source template file that would be used to generate a kube config that we can later use when we kubectl apply the resources that the customized build has written to that file. After the two data sources, we would have a null resource with a local exec provisioner that runs kubectl apply with the file that we generated in the external data source and would be using the kube config that the data template created for us to apply that to the correct cluster. Additionally, the customized build external data source also returned a checksum, and we would store that checksum as a trigger in order to only run kubectl apply if Kubernetes resources changed. So taking a look at the provisioner approach, what was good about it is that we did get a unified lifecycle for both cluster infrastructure and cluster services, so we could move them through the environments together. And the Kubernetes resources would only also be applied and only show up as a change if there was a difference. However, if we ran Terraform plan, diff that was shown wasn't actually any useful because we would just see that some hash changed from one string to another string, and it wouldn't show us what the changes to the Kubernetes resources would be. And similarly, the apply wasn't fully integrated into Terraform, but instead Terraform would shell out to kubectl, and kubectl would run the apply. So the individual resources are unknown to Terraform, and from Terraform's perspective, either the kubectl apply succeeded or failed as a whole. That some resources would maybe be applied correctly and others would not, was basically outside of the state of Terraform. Working with this for a while, I realized that I wanted better integration. I would have to write a provider for this. So providers are written in Golang. Never written Golang. I had a lot of questions. Let's just say I had a lot of questions. The only thing I ever, let's not say written, let's say copy pasted in Go was the Hello World example from the Golang website. Coming from Python, types and structs and interfaces, and most of the Golang syntax were like entirely alien to me. And at the same time, while trying to learn this new programming language, I also had to understand how the Terraform SDK works. And so I was at a point where there was just too many unknowns, right? I didn't know the language properly. I didn't understand the SDK I had to use properly. And I didn't also necessarily really know yet what kind of provider I wanted to build, right? Does it need data source? Does it need resources? What schema is it going to have? Thankfully, Alex was so kind to answer a lot of my questions in the beginning, and I want to take this as an opportunity to just say thank you for that. All right, and so it put me into a position where I knew roughly where I wanted to go, so I could start experimenting, moving into that direction. So what I ended up with back in the day was that I would have one data source that would run the customized build. This replaces the data external data source we had earlier. I would give it a path to a customization that's defined somewhere on disk. And the second thing I would have is a resource called customization resource here, which using for each, I would be looping through the first attribute the data source returns, which is a set of IDs. And then the customization resource expects manifest in form of a JSON string. So this is the second attribute that the data source returns. Is manifest is a hash map where the keys are the IDs from the ID set, and the value is a Kubernetes manifest as a JSON string as it got generated by the customization build data source. So this way you could point the data source at any customization you would have. It would run a customized build, and then you could loop over the resources using for each in the customization resource and have them applied against the Kubernetes cluster to also be tracked in Terraform state. So if we compare this provider approach now, we still have the unified lifecycle, and also the Kubernetes resources only apply if there is a change. But the improvement over the provisioner approach here is that the diffs now show the actual changes to the Kubernetes resources. They show a diff of the JSON, and applies are fully integrated into Terraform. Each resource is individually tracked in Terraform state, and Terraform would know individually about each resource if the apply failed or if it succeeded. Now, of course, it was not as easy as the previous slides may make it sound, because there were a number of challenges I had to overcome to get the provider to the point where it is now. And I want to talk a little bit about them. So the first one I want to talk about is what I call the create namespace race condition here. So as you are probably familiar, Kubernetes resources may depend on other Kubernetes resources. So for example, namespace resources like config maps or deployments need the namespace to exist before you can create the config map. And similarly, if you create any custom resources, the custom resource definition has to be sent to the Kubernetes API server first. Otherwise, the API endpoints don't even exist. Unfortunately, though, Terraform providers have no access to the dependency graph. So while I had a list of Kubernetes resources, I had no way of telling Terraform that there are dependencies between these resources. What I did as a first measure is I probably abused wait for state. So usually, if you've ever run Terraform apply, you've seen these, there will be log message that says still creating, and then an amount of time and still creating, and a slightly higher amount of time. As Terraform has sent a create request and is waiting for the resource to provision. And that's what wait for state is usually used for. So you call it after the create, and you configure it to do a get request of some sorts against the upstream API to figure out if the resource has successfully been created before Terraform continues. So because I can only create a Kubernetes resource that's namespaced if the namespace exists. What I basically do is before I even try to create a resource, I use wait for state to have that create loop until the namespace is created, and only resource. I use wait for state to have that create loop until the namespace is created, and only then I do send the actual create request. I also do the same thing for custom resource definitions. I just don't have it on the slide here. If you want to see the entire code, the resource customization.go down there is a link so you can see the code on GitHub. And so I have this slide where I try to explain the race condition that can happen now. So first thing, by default, Terraform will do 10 resource operations in parallel. There's the parallelism command line argument where you can change that number, but by default it's 10. Assuming on the very left here, we have 11 resources, 10 of which are namespaced. And the first one is the namespace. If the namespace gets created first, all the other resources are applied correctly without problem. As long as the namespace is somewhere within those first 10 resources, like for example in the middle here, waiting for the namespace to be created by having those other resources loop using wait for state does do the trick. However, and that's the race condition, it can happen that for some reason Terraform selects 10 namespaced resources as the first 10 resources. So all of them will start looping until the default timeout for that loop, or the default number of retries for that loop. And then depending on how far apart they started looping, as soon as the first one fails, the namespace will get created. Namespace creations usually are very quick, so it may still happen that some of the later resources will still apply correctly, but at least one, usually between 1 and 3 or 4 of those resources, would actually fail to apply, and you have to run Terraform apply again to also apply them. So that's the race condition that could happen because of this looping hack that I implemented. And so I wanted to fix this, but I think I unfortunately went down the wrong rabbit hole for quite a while. So on this slide, I have few code snippets that I copied from the SDK to talk them through. First one here is the list function of the set, which has the comment that the order of the returned elements is deterministic given the same set. The order of this will always be the same. The way this is implemented is that sets seem to be a hash map. The value is hashed and the hash is used as the key of the hash map. This makes sure that there is no duplicates. And then when the list is returned, entries are sorted by their key. Additionally, the SDK gives the ability to provide my own schema set function that determines what the key used in the hash map is going to be. And this is also the key it will be sorted by. So based on this, I came up with the theory that if I generate hashes in a way that namespaces and CRDs would always be at the beginning of the entries in the set, and all other resources would be further down the list, then the customization resource using for each would loop over the resources in the order that they are returned by the set. And then hopefully I would not face the race condition. So I already said that I probably went down this rabbit hole for way too long. And unfortunately, it wasn't the right thing to do, or it wouldn't entirely solve the problem. So the first implementation I did in August 2020 for the function that generates these IDs. It did improve the situation in my testing. The race condition seemed to show up less frequent, but it would still show up. Looking into this further, I realized there was a bug in the function that I wrote to generate the hashes, where a hash could become larger than the max uint32 value. And the way I had implemented my hashing function was that I would try to generate my special hash here. And if it failed for any reason, I would simply continue using the default hash function came with the SDK. So my provider wouldn't crash in these cases, but the order of the resources in the set would not be what I actually aimed for. And so after I found the bug and I fixed the bug, it further decreased the frequency of the race condition, but again, it didn't fully prevent the race condition. And so again, a few months later, in 2021, February, I finally settled on a different solution. And so what I did is, instead of just returning a set of IDs, I now return IDs prio, which is a list of 3 sets. And then the Kubernetes resources are grouped into one of the 3 sets. The namespaces and custom resource definitions go into IDs prio 0. Validating webhooks and mutating webhooks go into IDs prio 2. And everything else goes into IDs prio 1. This is how you would use this. Previously, you would have a single customization resource. We now have 3, P0, P1, and P2. P0 would loop through all the IDs in IDs prio 0. And then P1 would loop through all the IDs in IDs prio 1. And this is the trick here. Set and explicit depends on customization resource P0. And P2, the same thing, would loop through IDs prio 2 and set and explicit depends on customization resource P1. So this way, if you apply this now, I have an example output from an Nginx ingress controller here. Because of the explicit depends, first it would create all the P0 resources, which in this case is a namespace. And once the namespace is created, we continue with all the P1 resources. I shortened this here because there's a lot of them. They all get created after each other. And then finally, all the P2 resources get created. And the same, if you destroy this, it also does the correct order, just in reverse order. So P2 first, then P1, and finally P0. Okay, so the next thing I spent quite a while figuring out is how to handle immutable attributes correctly. Some attributes of Kubernetes resources are immutable. Example would be label selectors. This is something that Terraform already supports because it's common also for cloud resources. There are certain cloud resources that you cannot update in place, but you have to destroy them first and recreate a new one. And for this, Terraform schemata have attribute force new. And if you set this, whenever a particular attribute of your provider changes, Terraform will generate a destroy and recreate plan for that resource. I couldn't use it like this for my provider because, as you may remember, my provider has manifest, which is a JSON string, and I cannot recreate the resource every time anything in that JSON string changes. But instead, I have to decide based on attributes inside the JSON string. Doing this client-side would be extremely complicated. And so what I ended up doing is I'm using server-side dry runs. So the SDK has a function to determine the diff of a resource, and I call a server-side dry run inside that function and use the response I get to determine if I can update this resource in place, the default, or if I have to force new and have Terraform create a destroy and recreate plan. The benefit of the dry run is that it's much better validation if it's done server-side, because it can include more than just the static schema of a Kubernetes resource. One example would be that it would also run past admission controllers if they are supporting this correctly and if they're configured correctly. And in my case, what I was looking for is that if there is an immutable field that my patch is trying to change, I would be returned an error that would tell me that the field is immutable. So I have to determine between errors that are because of immutable fields and errors that are simply because something about the resource is invalid. This is the force new flag. You can set it on the schema, but you can also set it in as part of the resource diff function. And that's basically what I'm using. And it looks something like this. So in the first example here, I was under the assumption that host type field value invalid with this string message field is immutable would be what the Kubernetes resource returns. If there's any changes to immutable fields, and then I would call force new on manifest, and Terraform would therefore create a destroy and recreate plan. Shortly after, it turned out that stateful sets return a slightly different error if you try to of their fields that are immutable, which is most of them. And recently there was a contribution on the repository that apparently storage classes also need a special case here. So if anybody knows a better way than writing special case if clauses into the provider like I'm currently doing, I'd very much appreciate an issue or a pull request to let me know how to do this better. The link again is at the bottom of this slide, but nevertheless, this is how it's currently implemented. So let's take a look how this looks from a user's perspective. So I have here is a module that installs Nginx Ingress, and these modules, they allow in the configuration to use any customized attribute that you can use in a customization.yaml file. In this case, I'm using common labels. Common labels does is just like the name suggests, it adds a label to every single resource that's in the customization. If the resource has a label selector, the label is also added to the label selector. So let's assume I have applied this before and I'm now making a change. It's highlighted in green here. If I now run a Terraform plan for this, it would look something like this. So I'm using -- target here to only show the changes for the deployment, because otherwise it would simply be too many resources to show them on the slide here. I'm also excluding the diff of each resource. But what you see here is that the namespace will be updated in place, because that only adds the label. That's a change you can do in place. But the deployment, it would set the labels, but it would also set the label selector, and that's immutable. It's an immutable field, and therefore here you see plan that says the deployment must be replaced. Another topic that I spent quite a while on, not necessarily because it's complicated compared to the other ones, more because it requires me to support all the attributes that are supported in a customization YAML and translate it into a Terraform schema, are these dynamic overlays. You remember, initially the provider had one data source, customization build, and you gave it a path to a customization on disk that was defined as static YAML. The question is, how can you patch Kubernetes resources using values from Terraform? And because, for example, templates aren't yet written to disk in the plan phase, but data sources are executed in the plan phase, you couldn't simply use a Terraform template to add another file of some sorts to your customization on disk, because again, it wouldn't exist during plan, only during apply, but that's too late for this to work. And so to solve this, because it's a very valid use case that a lot of users very early on actually identified, I think after the first release of the provider already, I created a second data source called customization overlay. And here, instead of providing a path to an existing overlay or base or like any sort of customization on disk, you can specify any attribute that you can specify in the customization YAML as attributes of the data source. By defining the overlay or the customization in Terraform syntax, you automatically can use Terraform variables, attributes from other resources, all other kinds of references and Terraform functions, etc. So the example here, very easy example, I'm basically reserving an IP address, a Google Compute address here, and then I have my customization overlay data source that I point at the base for Nginx Ingress, and the base includes a service type load balancer. And what I'm doing here with patches is I'm patching the service type load balancer YAML that I get from the customized base so that it uses the IP address that the Google Compute address resource returns as the value for the load balancer IP. This way you can leave the upstream YAML untouched. You don't have to make any changes to the YAML files, which makes it easier to update them whenever upstream makes a new release. But you can still customize the values of your Kubernetes resources using values coming from other Terraform resources or anywhere else that you can, for example, query them from in Terraform using a data source. Recently, based on the provider and especially provider's new dynamic overlays feature, I created cluster service modules, which I really think show all the benefits of this integration in a very nice way. The first benefit, and that comes directly from Customize, is the fact the upstream YAML is left untouched. This means the modules can be automatically updated by a CI/CD pipeline based on upstream releases, because the logic of updating the upstream YAML in the modules is basically delete what's there and overwrite it with the new YAML from upstream. We consume that untouched in the customized sense. But at the same time, the modules allow, or basically that's a benefit of the provider mainly. Customized provider allows to integrate the resources coming from YAML entirely into the Terraform plan apply lifecycle, while still allowing to customize them. And finally, with the modules, it gives a very nice, unified and convenient module-based developer experience, also to maintain the resources on Kubernetes. So here is another example of one of these cluster modules. We briefly saw the Nginx module earlier already. The module basically has a very straightforward default module usage. You inject providers. You'll mostly do this to be able to control which cluster the resources get applied on. So you would create a aliased customization provider that you, in KubeStack's case, can configure from a kubeconfig output that comes out of the cluster module. And then you set a source, which the modules are available from a registry, and a version. And the version schema here is that the first part shows the upstream version, reflects the upstream version of the package. So in this case, it would install Prometheus operator 0.48.1. And then there's the packaging prefix --kubestack.0 in case an upstream version has to be repackaged for whatever reason. And then all these modules allow passing in the configuration. And again, the configuration can be any customized attribute, meaning you have a lot of flexibility to customize the upstream YAML any way that you require for your platform setup. Currently, there are modules for a number of services already on the catalog, and now that the provider has reached good maturity and the modules have proven themselves on a small scale, I'm looking into adding more really soon and basically expand the number of services that are available from the catalog. Last but not least, there's also a module that basically has the exact same usage as the catalog modules, but doesn't bundle any upstream YAML. And the idea behind this module is that you have a convenient way to use the same module kind of workflow, but with any kind of bespoke YAML that you may be maintaining yourself for whatever reason. You could, of course, instead of using this module, also use the provider's data sources and the customization resource manually, but the module has the benefit that it does the explicit depends on kind of setup for you out of the box, and it's less verbose using the module than doing it yourself by hand. But of course, both is possible, and the idea here is really that I maintain these as part of the KubeStack framework, but they're just Terraform modules, just like the provider is just a Terraform provider. There's no reason why these cannot be used standalone as well. My perspective, which is largely focused on the integration between Terraform and Kubernetes, I think there's really two major points. If I had to make a wish, it would be those two. Number one is that dependencies between provider resources, where the provider is configured from another resource or module, aren't currently tracked very well. Especially, for example, if you have a Kubernetes resource, an EKS resource, for example, that gets destroyed and recreated. The Kubernetes resources that are configured on top of that cluster are not planned to be destroyed and recreated properly, especially after the destroy. They stay in the state, and then the next time when Terraform tries to refresh them, you can't find the provider credentials, and then the entire thing errors out on you. And you have to work with -- target. That's kind of annoying because it kind of prevents Terraform from fully automating this. And the other aspect on my wish list is if any resource that uses for each has a dependency on any other resource or one of its attributes that is in this known after apply state, then for each Terraform will simply refuse to execute this, and you have to again run an apply with -- target, focusing the dependency first to make sure that the attributes isn't in state known after apply anymore, and only then can use for each. So in my case with the data source, it would be nice if I could define, especially for the customization overlay, which of those customized attributes do have the risk of changing the number of resources, because most of them don't actually, especially patches don't, which means if I'm using a attribute from another resource that's known after apply as an input to any of the patches, I run into this error. If I had to make a wish, these two things would be great to improve Terraform towards better Kubernetes integration, in my opinion. Well, so that's my presentation for today. I hope you got a nice overview of the journey from provisioner to provider, kind of interesting challenges I had to solve along the way, and what the current state of the provider is. If anyone wants to chat, there's a #CubeStack channel on the Kubernetes Slack where you can find me and a couple of hundred other people who are interested in the framework. Everything is open source, of course. You can find all the repositories on GitHub or the provider, the modules, and also the framework itself that we discussed today. And if you want to support the effort, consider leaving us a GitHub star or two. Thank you very much.
Welcome back. That was beautiful. We have a couple of technical questions for you, Philip, but I first have to start. What's the story with the gorilla?
Yeah, I get that a lot. And I put it there on purpose, also in my video conferences that we all have way too many of nowadays.
Right.
Because I think it's much more interesting to look at a golden gorilla than look at me all the time. And so we were at a client project in my previous consulting job, and we had a little bit of a celebration because we had a demo and it went well. And we went into like a restaurant. When I came out, I noticed that the shop next to it had this golden gorilla. I was slightly drunk and I decided I needed that golden gorilla in my life. And yeah, there it is. Her name is Becky. So.
I love that. It's definitely a conversation starter. Yeah. On the topic of starters, I'm curious. You had a little bit of a chat on YouTube. Thanks for that. Very cool to see those interactions happening. For people that are new to coding providers, what's something you would advise them to do or not do? What's something that you found really helpful and thought, hey, this is something that HashiCorp doesn't talk about, that the documentation doesn't talk about, but should, and I really want everyone to know?
I'm not sure if I'm the best person to talk about this because I'm still very much at the beginning of my learning phase here in writing providers because I'm so new to the entire programming language. But what I can say is that when I got started, the tutorial on writing providers was much simpler still. It was the old version of it. And the new one is worlds better, I would say. I don't want to bash the old one, but the new one is definitely better. So whoever improved this did a great job, because I did actually go back to the new tutorial a couple of times already to figure something out that I needed to do in my provider, even though I've been working on it for, I don't know, a year or something like this now.
I think it's good to improve documentation. It's definitely helpful to see from folks, like, hey, this was good feedback. Maybe we'll improve it, make it more clear, more direct. It's actually interesting that you call out the quality of the provider in that sense. We had a workshop on technical writing yesterday. I'm hoping a few of you got a chance to join that. It was mind-blowing because, for us technical people, we like to have formulas, right? Like we like to do, when we build APIs, we build them in a RESTful way. We know, like how to get things in. And Caitlin, our instructor, actually shared a couple of really good formulas that you can use for your writing, no matter if it's documentation or a guide, or I guess a blog post even, to just make sure it's engaging. Mary. Do you have any questions for Philip?
I do. And it is very okay if you don't have an answer for this question. I'm interested in your experience writing this custom provider, this customizable provider. If you have any stories about interesting use cases that you've seen from folks using it, or even an interesting use case that you yourself have thought of in your development of the provider.
Yeah, so I mainly created it because I needed better integration between the cluster resources and cluster service resource for my framework, right? But what immediately showed up is that people wanted to do more with it instead of just using it with the framework. They also wanted it to integrate more with any other kind of providers out there and the attributes that they might return, right? And these dynamic overlays that took me quite a while to wrap my head around. Quite honestly, I didn't understand well enough in the very beginning, the first time somebody asked about it, how to even dynamically define them, because Customize, the library I use, expects them to be on disk. And I had to first find a way how I can define them in Terraform and then fake them into a disk, which I do with, I basically write them somewhere to disk now and then point it at it. It's maybe not the most beautiful solution. I first had something that was entirely in memory and I was quite proud of it. But then it broke under Windows and I had to redo the whole thing. And yeah, and so now it's written on disk somewhere. But I think that's really the main point here, that Terraform, of course, is a huge ecosystem. And there's a lot of different use cases that people do with it. So my use case is really focused on only Terraform and Kubernetes, right? But as soon as you put a provider like this out there, there will be people that want to use it in slightly different ways that you envisioned. And I thought that was kind of interesting when I got that feedback and got to work on that part.
That's super interesting. And I'm excited to see all of the different ways folks continue to find ways to use the provider that you've written.
I think it's definitely one of those situations. You build something that scratches your own itch, which I think is the best reason to build, right? And then somebody else is like, hey, but can you scratch mine too? And then, yeah. So for folks wanting to see new features, what would be a good way if they want to contribute?
Yeah, so there is, all of the code is on GitHub. At the end of the presentation, there's a slide that has all the 3 links to the different repositories. There's one for the provider, one for these catalog modules, and then also one for the framework. I'm happy for any issues and pull requests that people send, and I'm happy to work with them on any ideas that they have.
I think we'll also get those links up in the chat. I'm pretty sure you can because you're not a moderator of this channel, but we'll make sure they're shared out. Give those a look. If you're in the audience, I think code is just such a beautiful way. Open source code is just such a beautiful way to learn from one another. Because, the things Philip ran into, you might be running into too. And if you don't have to figure it out yourself and reinvent the wheel, then maybe you can build on top of that. With that, thank you so much, Philip. That was beautiful. Please hang around and chat. And if you have questions, folks, then please join us there. Mary, over to you. Thanks.
Great. Yeah, thank you, Philip, for joining us. It's been lovely having you, and I think we'll continue next with a lightning talk from Kyle Penfound.
And distribution at HashiCorp. Since this is HashiTalks build, I'll be talking about the original project to create the Linux repositories, challenges faced, lessons learned, and what we're working on next. Since it's focused on the original project, it's not exactly a guide on how to build a repository, but really what we went through the first time we were learning this. So first of all, if you didn't know, about this time last year, we released the official Linux repositories as an official way to install HashiCorp products on Linux systems. And the idea was to create an easier install experience for Linux users. Instructions to use those repos are available on each product's Getting Started guide on learn.hashicorp.com, as well as each product's download page. So before we dive into this, let's talk about what's in a Linux package. So I'm sure a lot of Linux users out there have installed these, but you don't necessarily know what they're composed of. So obviously they include the binary of the product itself. They might include some configuration files, some other system setup scripts that run when you install the product or after you uninstall the product. And they contain a bunch of metadata for your package manager that says what the name of the package is, the version, what architecture is built for, maybe a signature, license, and then some dependencies so your package manager knows what else it needs to install. And then on the repo side, your package manager interacts with these repos. It's configured to talk to a certain number of them, and it looks out at this expected directory structure where it expects to find some metadata files that list what packages are available. So when you run apt-get update, apt will look at all the repos it's configured to communicate with. They'll give it some metadata that says, here's all the packages I have, the versions of those, etc. So that next when you run apt-get install Terraform, it knows which repos have Terraform, what versions are out there, and how to install it. So as we started putting this project together, the main things we wanted to solve were timely updates. So we wanted these Linux packages to be available as soon as product updates came out. And we wanted these packages to have the same binaries that we already build and distribute on the releases site. So we're not reproducing any work here. We wanted the repos and packages to be signed by HashiCorp so that as an end user, you can trust that it's coming from us. We wanted to provide an easy installation upgrade path so that when you install the package, you don't have to worry about the old way of doing things, of downloading a zip, extracting it, creating some configuration files, setting permissions, all these things. The package should do all that for you. And similarly with upgrading, you don't have to worry about going and download a package. Your package manager will say, hey, there's this other version out there. Do you want to install it? And then we want to support popular operating systems so that out of the gate, we can support as many users as possible. So from that, what we actually want to build is deb and RPM packages from the binaries we're already releasing. We want to host these on our own official repo, so that way we have full control over when and how they're released, how they're assigned, distributed, bandwidth, uptime, all those things are fully within our control. The packages should contain a default systemd init file so that when you install the package, your system has the service ready to go. You don't have to create any files, and it's built with our best practices in mind. And then it should also come with a default configuration file so that when you install, you have something to run immediately. So the initial design, this was the hard part because it may surprise you to learn that there's not a lot of material out there for creating an official third-party repository for Linux packages. There's not like a guide that says this is how people do it these days, because there's really not a lot out there. There's not a lot of people that have to worry about this. So what we end up coming up with here was we've already got this existing pipeline that builds and releases the products. So we're going to hook into that and figure out, like, once something releases, we want to notify this new pipeline that there's something to build. And so we've got a notification component to it. Then we've got this process that it creates the packages themselves. And once we have packages, we need to put them in a repository where they can be put in the proper directory structure. All that metadata that needs to get created for the package managers, that has to happen in this stage. And then from that generated repository, we want to then host this on something that can handle super high bandwidth and high availability. So we want to host this on a mirrored S3 bucket with a CDN in front of it. So going into that first step, that notification, we've got existing tooling within HashiCorp that releases the products to the releases site. So what we did is we modified that to emit a signal when we release something so that we can hook into that and perform some steps. So here in this example, we've received this notification that there was a console release. So we've got this Lambda function that receives that notification, and it looks at the releases site and it looks at our repository and it figures out what versions are on the releases site that we have not packaged yet. And it'll kick off a packaging process for each of those versions. So in this example, we can see we picked up version 1.10.1, and we've told Circle CI, our CI system, to create the Linux packages for console for this version. And so within the CI process, we actually want to create the packages. And there's a few different ways you can create Linux packages. We ended up going with FPM. It's great because you can create lots of different package formats with one tool. And so we've got all these bash scripts that wrap FPM that pull in the product configurations, the product specific arguments, to be able to build those packages with the proper args. And so we have this whole project that has all these bash scripts, all these different resources in the structure, so that from this CI entry point, we can say, hey, build this project. And if it has this project configured, it has all the things needed to build those packages. So let's look at that real quick. So here's our project. It's called Linux Packaging. It's a private repository within HashiCorp. And we've got this products directory with all of the products that we do packaging for. Within this, we can see that we've got that default configuration that's packaged with the console product. And so it's got all these documented configuration options, and some of them enabled so that when you install the package, it has a config to work with. We've got the service file. So this is the systemd unit file, so that when you install the package, you've got a service ready to use to run console. And this just really looks at your config, and all of that is based on how you set it up. So ideally, you wouldn't really ever have to modify this file after install. We've also got these install hooks. So before you install a console, it's going to create that console user. After the installation is complete, it'll create that data directory, set the proper permissions, reload systemd to detect that new service. And then after you uninstall, it'll do that cleanup for you as well. So for each product, we've got the same structure. We expect these same things to exist. And that way from the entry point, we can just tell it a product and it'll build the packages for it. So now that we've got the packages, we want to put them into a repository so we can create that file system structure, create those metadata files. And so to do that, we're using Artifactory. Artifactory is great because there's a ton of different types of repos that it can build. And in particular, we're using Debian repos and Yum repos. And it'll accept those packages, build those metadata files. And so we've built this internal CLI tool to interact with Artifactory for this use case. So we've got a bunch of different commands that this CLI tool has. So the one we're concerned about for this stage is called Artifact, where we pass these packages to Artifactory, paired with a configuration that tells us what the package is and what distros, like Linux distros and versions of those distros we want to support for this package. And you can see a few other commands here too, like add distro support for when we add support for new Linux distro versions, publish, which we'll get to a bit later, for actually releasing that repo to the public repo. So you can see here a snippet of what that config looks like for console that CLI consumes. So you see for like console RPM, we support all these different versions of Fedora, Red Hat, Amazon Linux. For console debs, we support Ubuntu and Debian, a bunch of versions of those. So the CLI consumes that and then uses that to send this package to Artifactory, which you can see now it's creating all the metadata for all of these different release versions, so that as a user on any of these systems, I can interact with the repo. Now that we've got this repo with our package in it, we want to put it in a place that we can distribute it to users. So we take that whole structure and we actually mirror it on an S3 bucket with Fastly as a CDN. So we've got another subcommand for that CLI tool that looks at anything created in the Artifactory repo that does not exist on our public repo, and it syncs it up. And then Fastly will pick up the changes in the cache. And now as an end user, you can install the new versions. Other things that we need to be concerned with throughout this process is testing and validation. So after we create packages, each product has its own series of tests that runs to make sure that all the things we've packaged with that binary, so like the configuration, the service, all the install scripts, we want to make sure that that all actually works. So you can see for console, we actually run some inspect tests that verify that the package can be installed and the service can be enabled and running. That running step is actually pretty crucial, because a lot of times if there is an invalid config or maybe something changes and that config is no longer valid with this version, then it won't get to that running step. We can see that there's something that needs to be updated. And then on the validation side, we also want to validate that once we put those packages in Artifactory and the things get generated, we want to make sure that all the things that were generated are valid. So we do a whole validation step between the Artifactory step and the public release step to make sure that everything generated is valid. So pulling it all together, we've got that notification from our release, and we can say, hey, create some Linux packages for this product. And then we create the dev and RPM with that binary, with all the different configs that we've set up here and all the metadata required. We test those packages to make sure that all the things we put together work together. We then put those packages in Artifactory so that we can generate that structure, all that metadata, so that our package managers can use it. We then validate all those things we just generated, and then we sync that repository up to the live repo. So how did we do? All the things I just said, I think we met all the requirements that we talked about at the beginning. So we've got product releases for the Linux packages as soon as the releases come out. We've got an easier installation path, because now I don't have to worry about creating that service file, the configuration, the users, all those things. It all gets created for me when I install. And then versions, when a new version comes out, my package manager can just do the upgrade in place. I don't have to worry about going somewhere and downloading anything. Things that didn't go so well, those packaging resources that we looked at are not publicly available. So this Linux packaging repository that we went through, like I said, is a private repo. And that means that as a community user, I can't go in and look at the things that are being packaged. I can't contribute to them or open an issue on them. And something else that didn't go so well is also high overhead to add new packaging for more products. So that whole structure of all the things that are expected to exist to create the packages. If I want to add add packaging for a new product that's coming out next week, I have to create all those things. And if I'm not super familiar with this process, then that's going to be really difficult, because you don't know what you don't know. Some other things that we learned is that from the repository perspective, branching on every single distro and version that we support may be overkill. So that means that looking at that repo structure, we've got Fedora, and then every version of Fedora and so on, and then the packages under that. The thought behind going down that route is that you may want to support different variations in the packages for different distro versions. So maybe there's different dependencies on the next version of Fedora that you need to be concerned about, or a different init system that maybe Debian switches to, or even a different version of systemd where some options aren't compatible. It would be great to be able to have different package versions so that you can handle each of those cases. But realistically, that's a lot for a small team to worry about anyway. And in the end, it creates a lot of duplication of packages on the repo and a lot more room for error, because you're creating that many more metadata files. And similarly, changing the repository files and structure is hard retroactively. So as a user, once I've added that repo to my system, from then on, my system will expect that repo to exist in a certain structure. It'll expect that Fedora /33/ x86-64. And so if we wanted to change that on our repo, it's a really difficult thing to do after everyone's got the repos on their system. And then finally, the repository generation is nothing to be afraid of. So we use Artifactory for all the heavy lifting there, to put those files in the right places and to generate those files. But really the native tools that do that as well are pretty good and pretty easy to use. So if I were to do this again, maybe I would use the native tools. And then coming up next for the Linux repos, we want to be able to support more architectures. So out of the gate, we supported AMD 64, and that let us support the most amount of users with the least amount of complexity for the project. But now we build for all kinds of other Linux architectures for our products already. We want to be able to support all of that within the repo as well. So adding support for architectures, making those packaging resources public and associated with their respective product, so that from the community you can open issues and contribute to those files and see them. So that's coming up as well. And then supporting more products. So really anything on the releases site that makes sense to provide as a Linux package, we want to be able to do that. So there's different variations of products too, like Vault HSM. We want to be able to have packages for that. And then once again, to use the repos, if you're not familiar with them, under each product's getting started guide on learn.hashicorp.com, there's this little section that says, here's how to add the repo, and also a ton of other great guides if you want to get to know the products better. And then these same instructions also exist on the product download pages themselves. And that's it. Thank you so much.
Welcome back. Thank you so much, Carl. Love the shirt. Very, very nice one. So we had a question in chat that I'm directly going to throw at you about the packaging. Are you writing full spec-based packaging or something as simple as FPM? This was asked by Shantanu.
Yeah, good question. So based on our current needs for packaging, FPM definitely solves everything that we're looking for. So we're using FPM. It's got its limitations, but we haven't really bumped into those yet. But I know that at some point we'll probably get there.
It is a beautiful tool that deserves way more attention and way more love than it's getting. I feel like every time you end up doing something where you need packaging, it's like, okay, cool. I'm just gonna roll it because the formats are simple, right? And then it's like rabbit hole, and then eventually it's FPM. It's definitely beautiful. You had a great couple of callouts of lessons learned. Normally I'd ask you, hey, what's the number one don't for packaging? Probably don't not use FPM at this point. But I'm curious, what's one of the things that you really appreciate about getting to work on this?
As like a longtime Linux desktop user, and then eventually going into like DevOps and other things where I use Linux for work and like server-side stuff, I never really appreciated all the things that go on behind the scenes when I do like apt-get install something, and like what the package is doing, what the repo is doing. And so learning more than I ever thought I'd know about like how repos are structured. For one of our team's hackathon projects way back, actually to kind of explore the limits of this, I built an RPM-based package manager for Mac just to figure out like what's it take to actually like extract an RPM and install it from scratch. So it's really cool to like learn how all those things interact on behind the scenes, right?
I think it's also like the best way of learning a technology, right? Like if you're using a tool on the front end, like, hey, this is how it works, great. But actually understanding what's happening in the back end and then trying something fun like that, bringing RPM to Mac. I like that. We should get a link of that up in the chat because I think that could be a ton of fun.
Yeah, definitely might be a little bit stale now.
It's still worth giving it a shot.
Yeah.
So one thing I'm really curious about, and then we'll hand it over to Mary. What is the one thing you do wrong every time you start a new packaging project? Like something that, just doesn't work out. I know we all have those.
I think one of the tougher lessons learned that I kind of touched on within that project or within the talk was the discoverability of all those resources. So I think the number one thing that doesn't feel good for me about the current state is that as a user outside of HashiCorp, I can't go in and see, like, I can't contribute to these files or open an issue on them. And we're working on some big things right now that are going to change that. They're going to make it so that you can do that. But that's the biggest thing is, like, we get a lot of people that are in awkward spots because they're like, okay, I think this file should be different. Do I open an issue on the product repo? This file's not even there. What's going on? So that's like the number one thing for me.
The reason I asked that is, sorry, Mary, just quickly coming back. The reason I asked that is not to be unkind, but because when we see other people make mistakes, that's a learning opportunity for everyone. So this is a great call out. Mary, over to you.
Yeah, I'm interested, as someone who is not as deep in the world of packaging and file systems, where would you recommend someone who's interested get started in learning about how we might package software or how we might start learning?
That's a great question. That was definitely a really tough spot for me getting into it as well. It's like I said, I didn't know a lot about what happens behind the scenes getting into it. There's really not a ton out there, especially on how repos work. So I spent a lot of time like reading specs and going through things that weren't the best way of doing things. And like I said, the talk was really about how we did it, not like a guide. So for me, I would like to at some point put out a guide on, like, this is how things work and kind of get the ball rolling on that. But I think right now, for what's out there, the best place to start learning is just like try using FPM. It's super easy, and there's a lot of good like help text, and the defaults are easy, so you can package something with almost no options and then install it and see what happens.
It sounds like we'll be looking forward to hearing you speak about your guide at the next one of these.
I'm glad I committed to that here.
I think that'd actually be fun. We have one more question from the audience before we head on to the next session. Are changes being made to how HashiCorp is packaging enterprise versions of products now that licenses need to exist on disk before something like Console, Nomad, Vault will actually start? Do you have any insights that we can share at this point?
Yeah, so specific to the packaging, one change that was made was that the system to unit files now have, by default, they point to an M file. So if you create that environment file with your license string in it, that's a great way to have the license there when the product's actually loaded. Beyond that, if you don't want to set the license as a string, then you can override the default configuration to point to that in the HCL.
Easy enough. Beautiful. Hopefully that answers Mark's question. With that, thank you so much, Kyle. That was beautiful. Hearing about packaging to me is always exciting because it's, the original container, the better container, the more fun container. It's definitely a lot of usefulness in there. Thank you so much. For us, it's time to switch to our next two speakers, Vladimir Lazarenko and Aris van Ommeren, who are both contributors for the Azure provider. I try to have one talk on the Azure provider every block, as you can tell, just to have a little bit of a counterbalance to Mary's work on the AWS provider. And that's, if you stick around for the live chat, then you'll realize that we do bad puns for the rest of the day. I hope my colleagues will also keep that tradition going. But with that being said, good afternoon, Vladimir and Aris. Nice to have you here, joining us both from the Netherlands. If you two are ready, then I would say switch on your screen share and let's hit it.
Yeah, let's try and do that. works?
It does. Looks good. Stage is yours.
Cool. Thank you very much for having us. So there have been quite a few very technical talks targeted on provider development, and we kind of thought we're gonna give you a little bit of a story of how we both got into Terraform provider development, and some of us got massively carried away with that, and touch a little bit on the less technical topic of where to start, how to go. Two of us, me, Vladimir Lazarenko. I am currently a freelance technology enthusiast, basically helping large enterprises migrate into the cloud, adopt clouds, innovate on clouds, save costs on the cloud, and so on and so forth. Aris?
Yes, I'm Aris. I'm a DevOps consultant or engineer, and also working on getting customers to the cloud. And I try to optimize for the system, not for the individual component. You can find me with the @Aristos handle on Twitter and on GitHub and everywhere.
Cool. So this is going to be a 10-minute slide for the people who do not know what Terraform is. Terraform is an awesome tool to automate your infrastructure deployment and lifecycle management with all the benefits of it, version control, faster speed, compliance, traceability, you name it. But I assume if you're all on this conference, which is HashiTalk Build, you probably know what we're talking about. So we'll move on.
Yes. Well, we're today talking about contributing to a Terraform provider, and probably most of you know it already where it's positioned, but for the ones who don't know that, you know probably the tool Terraform, or at least have heard about it. But between all the resources you can use within Terraform, there are plugins called providers, for instance, for Azure Cloud. And we are both contributors to the Azure Terraform provider, so we're going to talk about the experience with that. This talk is mostly about the experience with the Azure provider, but the generics of our talk are also applicable to other providers probably, and if not, probably people are happy to help you out with the specifics on their provider.
Cool. A little bit of self-bragging. Currently contracted by an international Fortune 500 company. Unfortunately, they do not allow me to name them. But we are basically an Azure shop. We work on data-driven innovation solutions, and with all the usage of data in the world, it kind of became a hype recently, and a lot of new products are being brought out, also by Microsoft. Unfortunately, everything that's new, it's either in a preview mode, private preview mode, which basically does not allow us to use Terraform to provision those resources. So we just had to get into the development to be able to continue to be 100% Terraform shop. My first unsuccessful contribution to Azure provider was about on June 17th, first successful one on June 30th. Since then, got carried away a bit, authored a bunch of PRs, not only to Azure, the Azure provider, wrote my own mini provider, contributed to HCL tools, new mini providers, and so on and so forth. Annoyed HashiCorp people so much that they recognized me as a HashiCorp core contributor of 2021 in Terraform space. Thank you for that. Very humble.
Yes, as for myself, I'm currently working for a company in the Netherlands. I'm part of a small team there, and that's also one of the reasons I started contributing. We are working on application development projects, mainly on Azure, at least our part of the company is. And my first contribution was on the 20th of January last year. And it was approximately 2 months after I joined the team, because we started using Terraform and we needed some extra features. My contributions in general are focused on application technologies, so to say, so app servers or AKS or the databases underneath it or some security things. And it's not to brag about it, but I think it's good to say that I introduced at least one bug per 10 PRs. It's not always a big bug, but there have been. I've blocked the AKS resource for a few releases, I think, in the past. But I think that's good to mention that it's also possible to make failures there as a contributor. And yeah, we overcome them and we fixed it as well. Last but not least, I wanted to mention a small tool. Because we work with Terraform and Azure a lot, we also have to move sometimes resources between subscriptions, and I built a small tool which can move the resources at the same time in your Terraform configuration and your Azure environment. I would advise using the dry run function first, so at least then you have a slight idea what it's going to do. And well, that's mainly my profile as a contributor.
Awesome. You. So as I mentioned, basically in my endeavors helping various different enterprises adopt the cloud, move to it, innovate in it, and so on and so forth, people very often want that shiny new thing that, you know, your cloud provider is just released and the Terraform provider doesn't yet support. Although Terraform does allow for majority of the resources, if some people want to live on the bleeding edge, they need to be able to deal with that bleeding edge as well. So there are a couple of ways one can deal with some shiny new thing that doesn't exist, which we've tried to illustrate here. You can basically log a new issue and just sit there and wait, as that nicely looking guy on the left is doing. Or you can raise a new issue, you know, do some coding, create a pull request, and do two things: be able to use it yourself and contribute back to the community.
Yeah, of course, it's not always necessary to contribute a whole new resource. Small improvements are always welcome, I think. But yeah, it's nice to contribute.
Definitely. So we've tried to list a few reasons to contribute here. I think, well, first of all, it's fun, and again, automate all the things, because if you are contributing by adding functionality, you are adding to the automation capabilities of the provider.
Yeah, and besides contributing to the community, it's always nice to learn a new programming language. I knew a bit of Go, but to really practice it, well, contributing helped me a lot there. And also, I must say, knowing a bit about the internals of the Terraform provider for Azure makes it a lot more easy to reason about the resources in Azure and all these things. That's definitely a pro to have.
Yeah, and then it's a very nice feeling when you're actually not an active open source contributor to get some of the stuff that you actually built, that it actually works, and, you know, work with the community, give back to the community, and, you know, improve the lives of people using the product.
Yeah, I think besides the list which we have written down here, I think I should also emphasize the well, so to say, soft skills. I think I learned a lot about communicating async on PRs, communicating humble, communicating direct, state what you want, but be humble and be nice. Yeah, these kind of things. It's hard to comprehend in a few sentences, but I think it's life experience also what you're getting out of contribution.
Yeah, I think I'll speak to the both of us when I say that in my collaborations with not only the Azure community and Azure part of HashiCorp, but also folks who are maintaining Kubernetes provider, the folks who are doing some internal tooling and stuff like that. HashiCorp has a very warm community around everything Terraform. They're super welcoming to the contributors, so it's always a good idea to just try and do it. So where do I start? If you're thinking about contributing but you do not know where to go or where to start, we try to kind of list a few things which you could consider beginning with. So one of them being contributing to the open issues or open PRs. So basically thumbs up. No Me Too comments, they are normally not really welcome, but those thumbs up, at least in Azure Teams experience, they are being used in somewhat prioritization of what needs to get worked on first.
Yeah, and that really helps. Also for me, when I want to pick up an issue, then I always look at the thumbs up. But besides that, it's good to read the contributing or development section of the README. Well, if you've seen the talk Tom did, a lot of these kind of things are there already explained, or other details how to generate certain stuff. You should definitely read it before you start with a real PR.
Yeah. So if you're planning to start with a real PR, it's usually a good idea to look through open PRs. One, to figure out whether somebody is already working on it or not. And otherwise, it can be a great way to start for the pointers of, I don't know, if you need to add a new parameter to a particular resource, there's probably plenty of pull requests that already have been merged or open in a review. And if you're going through them, it can give you a solid background information of what to pay attention to while writing a first contribution.
Yeah. Easy to pick up issues are always available. I think on the Azure provider, there are approximately 80 at the moment. Or to improve docs or examples, it's a good starting point to go through the process and learn how other people do it, or get used to the flow.
Yeah, on Azure provider, you can find them by just filtering by label good first issue, literally like that.
Yeah.
Join any real-time collaboration spaces. As Tom has mentioned, in case of Azure provider, we have a Slack. A link to that is available in the README of the provider. Most of the contributors are hanging out there. All of the maintainers are hanging out there. It's if you don't know where to start, if you want to attract attention to your PR or whatnot, it's a good place to be. Or just some technical cozy banter, rubber ducking, all that kind of stuff we all love to do.
Yeah, or just hang out, be nice to other contributors and maintainers, just like their comments or whatsoever. It's good to be there.
So once you figured out what to do, here are a few things you could do. So in case of Azure provider, and as we said, we mostly contribute to that, so it's a little bit Azure specific, you could upgrade service package versions. Azure SDK for Go has a date format versions. So basically they release a new version of a particular service package every so often. And upgrading the service package version doesn't mean that you need to implement everything that service package brings with it, everything new, but it allows other people to actually work on that. So the actual process of upgrading a service package means you upgrade the version of a package you're importing, and then you basically need to make sure that all of the code-wise, like syntax changes, are corrected and so on and so forth. Ideally, you would also run acceptance tests, but we'll touch on that a little bit later. And that basically allows some other people to then later on pick up other stuff and implement new functionality to be able to automate it.
Yeah, besides upgrading, add some new functionality to an existing resource. I think it's easier than to start a complete new resource there. So yeah, that's a good starting point.
Yeah, $6. Everybody's gonna love you for that.
Or if you are really up to the task, implement some new resources. Maybe not the best starting point, but if you really want to, we are always welcoming you to have a chat or do it in pairs, these kind of things. Yeah.
And then regardless of the point that we are mostly Azure focused, you could naturally contribute to any other HashiCorp open source ecosystem products, other providers, linters, I don't know, build pipelines. That's why it's open source. Anything goes, and from my experience, HashiCorp welcomes contributors anywhere.
Yeah, and have some fun. That if you don't enjoy it, maybe you shouldn't do it, but or you need that resource, of course. But yeah.
Cool. So to make it a little bit more technical, but just a tiny little bit, here's a very high level kind of checklist on how to implement a new Azure resource. So again, look through open PRs and issues. If anyone else is already working on it, you could potentially do the work in vain. And I'm honestly very bad at it. When I need something, I just open IDE, start coding it, and then I submit a PR, and then Tom or Katie are like, yeah, there is already one open and a review. And I'm like, okay, thanks.
Yeah. Well, if you want to contribute a resource, you should check if there's support in the SDK in the SDK for Go, if there's support for it. Otherwise, it's quite hard to implement the resource, and then you are basically ready to go to start.
Yeah, and then you basically fork the repo, and one of the easiest way to start code-wise is actually steal some code that's already working and adjust it up to the point that it actually works the way you want it to. So to give an example, if you have a resource which looks fairly similar in the parameters and arguments and something like that, instead of typing it all from scratch, just copy some other resource and modify it up to the point that it actually does what you want to do.
Yeah, don't forget the documentation for the new resources. And I think that it really depends on what you're implementing. But if I'm implementing a small resource, I start with writing acceptance test, and then check if it doesn't work, and then upgrade the resource and run the acceptance test again until it works. But that depends really on your workflow. And we must say, if you want to run acceptance tests, make sure you know approximately what you're doing, because it can cost a lot of money. Yeah, that's definitely something you should know beforehand. If it's just a small resource, if it's the resource group, for instance, what Tom demoed today, then it's almost for free. But if it's a huge cluster of some kind, it will cost you some money.
Yeah, the acceptance test, they literally create resources in Azure, so you really need to keep that in mind before, I don't know, your credit cards runs out or your manager is going to be asking questions.
Yeah.
What we've learned during our journey of becoming contributors, well, for one, just give it a go. I'm 99% positive you're going to like it, but if you're not going to like it, nobody's going to force you.
Yeah, and ask questions. I mean, if you don't ask it, you will never get an answer probably. And I already said it, we are really happy to help as well, and available on Slack as well. If we are not available, you'll not get an answer, but probably within a day or two, we'll at least let you know if you're available for something.
Yeah, so when, as we already said, joining Slack is more or less a must. And the community around providers is really, really nice. Really, really nice place to be.
Yes, a few gotchas, what we wish we would have known prior to starting. Vlad, you want to take off?
Yeah, sure. So one thing I experienced by myself, and that was my first unsuccessful contribution. Don't try to bite off more than you can chew. Start with smaller tasks. When I decided to make my first contribution, it was implementing a new resource. It was a dedicated event hub cluster. It was a massive preview feature. One of the things which actually costed us a ton of money for running acceptance tests, because you can destroy that beast 4 hours after its inception, which incurs around $4,000 of cost for every test you run. That I kind of didn't know. And the complexity, the sheer complexity of that resource kind of made it for a very difficult review. I think Steve and I went about, I don't know, 30 iterations, and then we decided to ditch the whole thing and start again.
Yeah, so maybe the message is that if you want to implement something really complex, it's good to pair in an early stage with someone who wants to help, or ask around if someone is available. For instance, I exchanged email addresses with someone, and the next day I was on a Zoom call implementing a machine learning cluster resource. It's that easy. Yeah.
Yeah, I'd say expect your first review to have a significant number of comments. I mean, if you're new to Terraform provider development, but not new to Go, it's probably going to be a little bit easier. If you're both new to the Golang as well as Terraform providers, it's probably going to be harder. Do not get discouraged. I mean, quality of code is important. We are working on an open source product with hundreds of contributors. Quality of code is important, period.
Yeah, and it might take a few iterations before it's really as great as we want our code to be, and use it as a learning moment. I mean, I also look sometimes at reviews on other ones, PRs, because yeah, I don't know a lot of stuff as well, even if I've contributed already a lot. Yeah, there's always something new to learn.
Yeah, and I think this is the fourth time I see Slack on our own slides, for which I apologize, but we cannot stress enough. Interact with the community, and you will be set up for quite a lot of fun and successful, productive contributions. That's basically all we had, and thanks everyone who was listening to us. Well, my contact details are here. Aris's as well. If you want to get in touch, please do.
Yeah, feel free, and thank you.
Thanks everyone.
Thank you both for sharing that. This is the exact kind of session that I think we all need, because it's scary to start an open source, right? Like you see this repository, there's 1,000 issues in there, and you're like, which one should I grab? And even if you filter by good first issue, it's still like, but what? You know? So thank you for sharing this experience. It's been very helpful. You made a call out to say, you know, I was a bit of a nuisance, and eventually people started recognizing me. definitely not the case. Steve pointed out that you are definitely not a nuisance and that it is very appreciated that you contribute. And that's not just for you two, it's for all of our contributors. No matter if you're adding a new resource or data source, or just changing something as simple as a missing period or fixing the type of an item in the documentation, it's a useful contribution. Because if you ran into it, probably somebody else ran into it as well. So definitely keep doing that. And Vlad and Aris, thank you for offering your time so willingly to our community and making a call out to the Azure Slack to get people together. Definitely great. Mary, do you have any questions for our speakers?
Yeah, I would love to know. So this is directly relevant to the product that I work on, since we essentially have the same problem. So my question is sort of, how did you, I know you talked about how you started, but what led you to wanting to contribute instead of just, you know, opening issues and waiting to see what the rest of the community was doing?
For me, I think it's curiosity. I want to know how it works. I'm an engineer, kind of. And well, I don't want to wait too long. I want to get fixed. And if it's easy, and the start was really easy. I think it was like a 4-line contribution or so. Yeah, then why not? I mean, I think it's also a mindset, kind of.
Yeah, for me, it was mainly, yeah, I'm impatient. I am pushing the company I'm working for 100% infrastructure as code. And when you're hitting the wall of something not being supported, yeah, you just go out there and do it.
Wonderful. I have one last question, which is, how did you go about getting your pull requests flagged for review so that they were noticed by the Azure team?
Go tag Tom in Slack. No, don't do that. But no, seriously, the Azure Slack has a contributors channel. Basically, it might help if you just paste the link in there without tagging people. Other than that, I know that a lot of maintainers and people who are able to review PRs are looking at them on nearly daily basis. But if you feel that your particular contribution feels completely abandoned, again, Slack's the place to be.
I think these are great tips. Sorry for interrupting you, Mary.
Oh, no, I was interrupting you. I was just saying thank you because I thought these were great answers and really helpful tips as well.
Absolutely. Thank you both. That's all we have for you two. Now we're going to switch to our next speaker. If you've been following along with the schedule, you might expect a different session, but let's be honest, nobody has time to check a schedule once the event kicks off. I mean, there's been so much good stuff. Learning how to be a contributor, not just on a code level, but also on a, the social level. It's super amazing. But we're going to take a little departure. We're going to bring in a good friend of mine and somebody I've learned so much from. I almost want to say Kristen is a Terraform Emperox, but I'm not supposed to say that on the stream, so let's all pretend I didn't do that. And yeah, let's hand it over to Kristen to learn about the Terraform protocol v6.
Thank you, Karim. Thank you, Mary.
Hey, I'm Kristen Lambert. I'm a Terraform core developer, and I've been working on Terraform for a little bit over 3 years. Now I'm going to forego my usual about me slide, but I do need to pay the cat tax, so here you go. Now this picture is also a representation of the face I made when I first waded into this topic about a year ago. I've given a handful of talks about various Terraform releases, but this time I get to do something different, a deep dive into Terraform's internals. Specifically, I'm talking about the provider protocol. Terraformally speaking, this topic is about version 6 of Terraform's plugin protocol, which I added in Terraform 0.15. This new protocol added enhanced modeling of complex attributes. Now, if you're wondering what the heck that even means, it's quite all right. It took me several weeks to fully understand it myself. Really, what I first needed to understand is, what is a block even? So I've got a lot of caveats about this talk. First of all, this is a deeply technical topic. I'm going fairly far into the weeds. This talk assumes that you have basic familiarity with Terraform concepts. You don't need to be an expert, but it's really going to help if you're familiar with Terraform. While I don't assume you're familiar with provider development or the plugin protocol or the SDKs, it is going to help because there's a lot of details I'm covering in this talk. Also, I'm badly oversimplifying everything I talk about today. I've tried really hard to tell no lies, but I'm leaving out details. So if you're looking at code snippets in here, they're probably not going to work. There's pseudocode. So sorry about that. There's just a lot of information. And again, this is just a word-heavy slide. I have text slides and code snippets and configuration snippets. If you're used to my previous talks with all the memes and pictures of my cats, I had trouble fitting them in here. So I'm going to give an outline of what I'm talking about today. There's going to be a bit of a history lesson where I kind of talk about the backstory of the plugin protocol and how we got to the particular issue that I worked on. I'm going to cover some key concepts since there's a lot of details I'm covering. Then I'm going to get into actually what the problem I was trying to solve with Block was and share my solution. Okay, now I've said this is a word-heavy slide, but I did insert some cute images to give us a break between the main topics. So Lauren, this is the piglet you asked for. It's here just for you. Okay, let's get into the history lesson. Before Terraform 0.12, the plugin protocol was a direct extension of Terraform's internals. So changes to Terraform frequently required changes to the protocol. They were tightly coupled. Terraform and the SDK were both very flexible. The SDK would enforce some assumptions, but overall, we'd kind of take whatever providers gave us. The downside of that is that similar results could be obtained in multiple ways, and it wasn't always clear why that was true or which ways were the best ways to get the results you wanted. Some differing assumptions in the upstream APIs began to surface as differences in style between providers. Various SDK features that we'd added over time kind of got combined in new and interesting ways, which led to some complex emergent behaviors. Now, emergent behaviors is my nice way of saying, I didn't even know that was going to work until somebody did it. And we didn't know people were doing it until they depended on it in production. And so these emergent behaviors led to some inconsistencies and to some bugs, although, again, also did a lot of the very cool things that provider developers have done. So it's not all bad. Now, one of the specific examples of one of those weird Terraform conventions that led to issues is that Terraform tended to flatten everything in a resource block into this map string interface. So no matter what interesting data structure you may have in your resource in the provider schema, it all kind of got smooshed down to this one form. Terraform was big on strings before 0.12. If I'm going to oversimplify, I'd like to say everything was basically a string eventually to Terraform. And Terraform handled these things somewhat inconsistently. So sometimes, because of that, things would work or fail depending on how the configuration was written, what the provider expected or assumed. And honestly, some days it just felt like solar flares, like gremlins. We didn't always know what was going on or why. And then Terraform 0.12 came out. Terraform 0.12's major theme, I would call, was directly addressing those issues of flexibility and inconsistency. So that whole problem is what led Martin, and this is back before he was even a HashiCorp employee, to write an entirely new type system, C-type. This is a consistent representation of dynamic values, so it enforces its own invariance. It has strict types for everything. It also understands the concept of nulls and unknowns. So these are very Terraform-specific concepts. A new type system led to version 2 of HCL. So HCL is the Terraform or the HashiCorp configuration language, which is what the Terraform configuration language is written on top of. HCL2 is able to now retain more specific information about blocks and attributes and all that information into CTI. So this was now a consistent way to track this information, no matter how you wrote the configuration. Now in Terraform 0.12, we also added a new provider's interface. So the protocol was no longer a direct implementation of Terraform's internals. This made it easier for us to decouple changes in Terraform to changes to the protocol plugin. For Terraform 0.12, finally, not finally, there was a lot more to it, but for this topic, finally, we added shims so that providers written with this new protocol that we introduced in 0.12 could also work in Terraform 0.11. So we wanted to make sure this was backwards compatible so provider developers weren't, again, tightly coupled to providers that would only work with Terraform 0.12 and newer. Now, unfortunately, with all of the shims and the pre-bullet point 0.12 issues I kind of talked about, the flexibility, well, all of these things combined to create a situation where there was no possible shim implementation that could work with both 0.11 and 0.12 and preserve the emergent behavior across all resources and all providers. What I'm saying is that there were consequences of 0.12. All right, now I'm going to get into the key concepts and give an overview of all the technical topics that you need to be at least basically familiar with to understand the talk. Everything builds on each other, but it is deeply technical, so I hope this makes sense. In the Terraform configuration language, our base structure is a block. A block is the container for all other content. So an entire resources configuration is a block. The provider configuration is a block. Your backend configuration is a block. Arguments assign values to names. They appear within blocks. Fairly simple. These are the key Terraform concepts. So to take a look at this in a configuration file, I have a Happy Cloud server resource. So this entire thing is a block, the whole resource definition. Inside that block, I have arguments. Here I have image, which is an argument. This is image as a string. We also have the tags argument. We also have disks. And I'd like you to notice that image and disks have different definitions. So images and tags, you've got the name, image or tags, equals, and then the value. But in disks, we don't have an equal sign. This is because disks are a nested block inside a resource. It is a way for us to declare a collection of information that is interconnected. So we're going to get into deeper detail on the difference between these two things. What's important to keep in mind is from a user perspective, if you're writing Terraform configuration, all I really need you to know is blocks and arguments. That's kind of the main thing you need to know. Everything else is details for provider developers, Terraform internals. Now I've mentioned the plugin protocol. This is the wire protocol that Terraform Core uses to communicate with provider plugins. This communication is done over gRPC, and that protocol is defined in these .proto files that we have in the Terraform Core codebase. Now those files are copied into the SDKs, which are friendlier implementations of the protocol. The SDKs have some nice helper functions, lovely features, great help with testing. There's a couple of SDKs available right now. We've got the Terraform Plugin SDK. That's the main one, the one that most folks would have used. Terraform Plugin Go is a bit newer. It's a little closer to Terraform's internals. So the goal there is to give you much more power and flexibility. And then I would just like you all to be very impressed with my amazing design skills. This is an illustration of Terraform and plugins speaking over a wire, because I am not a designer, but I had fun making this. All right, so there's the basic Terraform talking to providers. Now, if we're talking about providers, everything in a provider is defined in terms of its schema. So again, a provider configuration has a schema, a resource is defined with a schema, etc. The top-level schema container is a block. That's the same thing I said when referring to the Terraform configuration language. They both have blocks. We really like to overload words. So a block in Terraform configuration language isn't necessarily exactly a block in the schema, but it basically is. So just, yes, it's complicated. It's what we do. A block contains attributes and more blocks. So that's the nested block concept I mentioned briefly. Now I'm going to show you what the definition of the block looks like in the actual protocol. So this is a snippet of the entire schema. This is showing just what a block is in the schema. Now there's a lot of information here. The interesting details I'm looking at, a block has attributes and it has nested blocks. Those nested blocks are more blocks. Now let's talk a bit about attributes. An attribute in the schema has some basic information. So attributes are those arguments. It's got a name. I've got the type, the expected type of the attribute. Now in the SDK, an attribute can be a string, number, or Boolean. It can be a map, list, or set. I'm probably leaving something out, so let me just apologize now. Now in Terraform, a type can also be an object, although that is not currently supported in the Terraform plugin SDK, the main one. An attribute can be required or optional. An attribute can be defined as sensitive, and it can be defined as computed. So if an attribute is computed, that means that we don't expect users to set it in the resource. It is something directly out of the provider that we store. Now, if I'm looking at an attribute in the schema, again, the interesting information I would like you to notice, we've got the type, as I've said, and then we have all those flags, required, optional, computed, sensitive. Depending on what of those flags are turned on and off will determine a lot of the behavior of the provider and how it's configured. Sorry, behavior of the resource being defined here. Now I want to take a look at some resources as they are defined using the Terraform plugin Go SDK. Now this is from a personal implementation, so I can't guarantee that this is the best way to do things. But what I've done here is re-implement our random provider, specifically the random pet resource, which if you've seen my talks is clearly the only resource I actually use regularly. But I've got that defined in the schema, so you can take a look at what it looks like. So as I've said, my entire random pet description is a block in the schema. And then inside that block, I have attributes. For the sake of this example, my random pet attributes have a length and a prefix. So if I'm a user now and I want to create a random pet resource, this is what the configuration would look like. I've got my length and my prefix set to values. Blah. Now I'm going to go into a more complicated example. In this case, I have a made-up resource called a Happy Cloud instance. This resource is a block and it uses more blocks. So this resource, I'm showing a nested block of disks. And inside the disk blocks, I then have a list of attributes. So here I'm showing size and mount point as some kind of arbitrary examples. So now this resource, if I was going to write it in my configuration, might look like this. I've got multiple disks. A detail I'm not going to get deep into is that your blocks have a nesting mode, and that, among other things, will determine whether or not you're expected to have one, more than one, a specific number, unlimited number. So here I've got 2 disks I've created using nested blocks inside my Happy Cloud instance resource. Whew, okay, so that's all the key concepts I wanted to cover. So here's our next palette cleansing. Again, Pug, Lauren, this is for you. So here's where I come in a couple of releases later. As I said before, that combination of the pre-0.12 flexibility, the new type system in 0.12, the complicated shims, and the new protocol all led to this fairly random assortment of problems and feature requests, along with all the good things that brought about. What I did was start with a curated list of some of our top issues and requests from the SDK team, and they'd work with the providers working at HashiCorp to come up with this list. And then with a lot of help and some creative squinting, I teased out one common component of some of the items on that list. Blocks are weird, yo. They do weird stuff. So one of my personal joys is taking on these projects that are both technically and emotionally challenging and building trust in my professional relationships. I claimed time on Terraform's core roadmap to address this, not just because there were important issues that we needed to look into, but because at the time I got to it, there was some kind of pent-up frustration and hurt feelings. 0.12 took a long time. Not everything got addressed as quickly we would have liked. People were concerned that we weren't following up on these issues, and I wanted to do what I can to help with that. I'm going to admit that when I carved out some time on Terraform Core's 1.0 roadmap, I was hoping I'd get to address more, but really this one problem took up all my time. I'm going to give a refresher on what we've already seen today. I've got a resource in terms of Terraform configuration language and the schema, the whole thing is a block. Images and tags are both attributes in the schema, although they're also arguments in the configuration language. And disks, while being an argument in the configuration language, is a nested block inside the schema. And again, you can see the difference is that images and tags are defined with equal signs and the disks is not, because it is a nested block. So there's some limitations to using those nested blocks inside of a resource schema. The native limitations of blocks and that kind of shim-splosion meant that blocks worked really well for most cases, but there were edge cases that led to issues. For one of them was simply that there's a different configuration syntax for end users. So it wasn't always clear to a user when they were supposed to use that block style syntax versus the attribute style syntax. It's not also always clear to provider developers. Users don't know how to index inside of a collection of nested blocks because it's not just a list that you can refer to like you might other things in Terraform. You can create multiple blocks with the dynamic construct. That's the only thing dynamic is used for, whereas other things in Terraform use for each and count. And then there's this thing called config mode adder that exists in the schema that's even more complicated, and I'm not even going to get into it, but it's yet another wrinkle that makes half of what I said not true if that flag is on. So let's just gloss over that one. There are also no block flags. When I talked about attributes, we could say that an attribute is sensitive or computed, but in a block, you can't do that. All of the items inside of a block are just there. They always have to be set by the user. There's also no zero values for blocks. So when I have an attribute like image here, I can set it to an empty string. This works. Empty disks does not actually work. You don't have a way to explicitly say, I want none of these things. All right, so with the work I did, I came up with what I would like to call the USB-C solution. And of course, what I mean by this is instead of fixing the problems with block themselves, I added yet another way to define a collection of attributes. So, hey, instead of 2 ways to do things, now we have 3. It's not as bad as all this, but it makes a good joke. So what I did is add a new field to attributes in the schema. This field is called nested type. It is an alternative to the type. So instead of saying the type of this attribute is a string, you would say this attribute has a nested type. And inside that nested type, then you have another collection of attributes. And of course, all of those attributes can then have the sensitive, computed, optional, whatever flags you want on them. And that's really it. It's kind of simple. I'll show you what it looks like in the protocol. So here I have an attribute in the schema. This is almost exactly like what we've seen before, except now I have this new nested type field, and it's using a struct called an object. I can take a look at that object, which is rather simply a list of attributes. So, right, super easy. Like this is just nothing. That barely did anything. So not quite. I have here just a snippet of the internal proposal I wrote for the feature. It really did take me weeks first to understand the problem. And keep in mind, this is after months of our SDK team talking to the provider developers, dealing with the issues themselves, writing up the list of feature requests. So they did all of that work. I read the list and pulled out the theme. And then a few more weeks to write even just the description of the problem. I used and am insanely proud of the phrase, a constellation of interconnected issues. Yes, I'm so pleased with myself. I'm going to make you listen to it too. So then after all that, when I finally thought I knew what the problem was, I workshopped 3 different versions of the protocol v6 so we could kind of figure out which was the best solution. To do this, I needed a branch of Terraform, I needed to write my own provider, and I had a fork of both Terraform Plug and Go for the protocol and the Terraform Plugin SDK because it had some really great test writing features. So all of that work and then workshopping the 3 solutions before we settled on the one that we thought was best. Now, finally, we're going to take a look at the Happy Cloud instance that I showed a schema for previously. So this is the schema we've seen before, and I'll show you what it looks like when I rewrite these disk blocks that we've, again, seen before as nested type attributes. So again, Happy Cloud instance in the schema, Happy Cloud instance written in Terraform configuration language with a couple of disks. Here's the new schema. So now instead of blocks, we have an attribute disks that has a nested type. And then inside that, there are attributes. What I did is add a new attribute for this example called secret key, and I've set it to sensitive. So now if I'm rewriting my configuration with this new schema definition of a Happy Cloud instance, you can see that my disks is visibly a list of objects. So the syntax, slightly more verbose, but now I have a list. I can create it in a local using for each if I want to build up values or even assign an entire variable to that list, things you can't do with blocks. And now because secret key here was set as sensitive, if I'm doing a Terraform plan and apply, that secret key won't show up in the output, it'll be redacted. So previously, you'd have to hide the whole block or nothing. So there's some pros and cons to this new tactic. The upsides is there's a more consistent user experience. If we stop using blocks and only use nested type, there's a single syntax for every argument where you have the name equals a value. And then that value might be a string, it might be an object, it might be a list, but it's always going to have the same syntax. You're always going to index into that item the same way as you do with other collections. And we're just not going to need dynamic expressions anymore. So no more of that like bespoke single purpose tool. Downsides, of course, is that blocks still exist. So if a provider developer wants to refactor all of their resource to use nested types instead of blocks, well, they're going to have to refactor the provider, and the users are going to have to refactor their code because the syntax has changed. So that's a pain, and it's entirely possible that we're not going to see people wanting to change existing resources, only write new resources using this going forward. Now, this change, the nested type, while it did seem fairly simple, is not backwards compatible. So I did have to introduce an entirely new protocol version, which means if you write a provider using protocol version 6, it's not going to work with Terraform 0.14 or earlier. And honestly, due to some bugs, it's not going to work before Terraform 1.0. Okay? And because that older protocol and the nested block syntax is going to be supported, we've guaranteed it for at least all of the 1.x Terraform releases, they're going to be around for a while. Basically, I really couldn't create a situation where users weren't going to be required to check the documentation if syntax changes, and you still need to know if you're defining a resource basically with that equal sign or not. That's kind of what it boils down to. So there's some pros and cons. I'm hoping that over the next several months and years, we're going to see nested blocks kind of falling out of favor for this more consistent syntax. And then I'm sure more features and bug fixes will come along in the time, but I don't know what's actually going to happen in the future. So I can only hope how things are going to go. Writing this talk was more like writing a term paper, and in the end, I would have felt better giving you a 50-page essay than kind of trying to babble my way through all of these technical details. So I'm going to at least share some of the references I use, the public ones. This is nothing compared to the list of internal documents I read from, but I've got some links with information on if you're interested in writing a provider or if you want to know more about the plugin protocol internals. There's a wonderful talk that Patty and Katie, who are both people on the SDK team at HashiCorp, gave last year that I highly recommend. That goes over the history of the SDKs from their experience. And then I also have a couple of links to some descriptions of the attributes/blocks problem that we had publicly facing. That's all I have for today. I hope you found something interesting and helpful there, and I really appreciate you watching me. Have a good one.
Welcome back. That was beautiful, Kristen. This was very, very exciting. Thank you for sharing that with us. Writing protocols, I feel like every engineer aspires to that at one point, and then it hits you and it's like, wow, that was, not what I had hoped for. So I'm glad you showed us how it can be done. Also, we got some nice shout outs for your t-shirt. I'm personally enjoying that. I think the combination between pineapple and pizza is it's perfect. It's a different kind of flavor, but it's definitely a good one to have. Mary, do you have any questions for our speaker while I grab some from our community?
Yeah, Kristen, you've worked on Terraform for quite a long time, and I think you've worked through, as you said in your talk, a variety of protocol changes. Which has been your favorite set to work on, or a favorite challenge that you've kind of overcome in going from protocol to protocol?
So this is actually my first project on the provider protocol. One of the fun things about Terraform is that there's so many facets of it that, there was my first year where I really only dealt with the configuration language, and it was only in the last year that I started getting deep into the internal. So this was my first time with specifically the provider protocol and the provider's interface. So just getting into that was so much fun. And then the fact that working on it also gave me an opportunity to work with the SDK and the new Terraform plugin Go was just super fun. I love learning new things. And so just every day was something new to get into.
Cool. I'm trying to think of other questions that I have. I'd love to know, in this last round, what was the biggest challenge that your team came up against from? Whether that was a development challenge or like a scoping challenge, what was the biggest challenge in sort of rolling this work out?
One of the challenges, I guess for me specifically with the protocol work, is that I could get the code into place and do all my local testing, but until I got it into the hands of the provider developers, there were some things I wasn't super confident about. And so, as awkward as this is to admit, but even as recently as yesterday, I was frantically fixing bugs that Patty discovered while working on his HashiTalks build. Like everything in every coding project, but I lately think especially in Terraform, like there's just no amount of testing that's going to cover everything that actually happens when it gets out in the wild. And then on top of that, I don't know if you've known, but if the last couple of months we had a little release that was, a couple of things going out, Terraform 1.0. So really everything in the last 6 months has been like a big project and a lot going on. So it's hard to pick one thing.
1.0 was definitely a huge release, and it's just beautiful that essentially stability is what we promise, what we deliver. It's great. It's also fun to hear that you get to work with Patty on the things, both of which ended up being featured today or will be featured later. Patty's talk is coming up later, but just once again from our community, some great feedback, fantastic talk, great talk, lot of info. I think your talks are always the ones that I enjoyed listening to the most because there's so much good stuff in there. So thank you for sharing your knowledge so freely with us. And I think for us, it's time for our first panel of the day. So we have a demo from Herr Julian, who's going to show Nomad dashboards in your terminal. So let's roll that, and we'll be right back in about 10 minutes.
All right, hello everyone, and welcome to a demo for a terminal dashboard for Nomad. My name is Julian. I'm based in Germany. I work for HashiCorp, particularly the HashiCorp cloud platform, and yeah, I will show you like my terminal UI for Nomad that you can use to basically operate your Nomad cluster, display your jobs, watching your deployments, and so on. And yeah, so how did I get the idea to write such a tool? Like in my previous job, I worked a lot with Kubernetes, and in the Kubernetes community, there is like a similar tool called K9S, which is actually a pretty nice tool, but it's for the wrong scheduler, right? So yeah, when I started at HashiCorp, I fall in love with the Nomad scheduler, and I was searching for such a tool, but I wasn't able to find one. So I said like, okay, let's build one. So I started to implementing this tool, and today I think it's in a shape where people can start using it. And I'm really happy to be able to demo it today to you. So the tool is called Daemon. I hope you get the relationship. It's basically Nomad backwards. So that's the name. I personally like it. I hope you too. And I hope you like the tool as well. So let's just start because we just have 10 minutes and we need to get through the tool. So you basically start Daemon by just typing the tool name. You don't need to provide any further commands or parameters, anything. You just start it and you get this view, right? So the layout is simple. You have like a header and you have a body. And people who know K9S will see the similarities. It's clearly inspired by K9S, but like this is like a common layout. It's also used by HTOP, other such tools, right? So yeah, so there's a header, there's a body. The body is where all the information is going on that you need to operate your cluster, like jobs, deployments, and all the other things. Then we have the header, which is divided into 3 sections. It will give you the informations on the left. Here you have the address, which you can simply click, and then we'll open the UI of Nomad, which is pretty handy because at this point in time, Daemon doesn't have like all the features that the web UI has. So you can go from here to the web UI and do things if you cannot do it with Daemon. You have the version of Daemon. There's namespaces. We'll talk about that soonish. And then in the middle, we have like the commands. This is like the top level commands that you can use. Now, because I scrolled in, you cannot see the view commands, but if you scroll down, you will see it. Like by default, you will always see the jobs when you open Daemon. So this is why here it says job commands. This is for this particular view and what you can see for this particular view. So you could hit enter to display allocations for a job, or you can hit T to hit the to see the task groups for a job, right? And then on the right, we have the lovely Daemon logo, and yeah, of course, the body. And this is now where we will focus on and we will spend our time. So first of all, like navigation, like how do you navigate through Daemon? How do you use it? Like basically, people who are familiar with Vim, you can use J and K to navigate through the tables, but you can also use the arrows up and down to navigate through the tables. And I want to speak a little bit about coloring because this is another important thing. So depending on the status of your resource, basically the color will change. So running jobs are white, batch jobs also when they're running white, but if they run to completion, if they are dead, they will be grayed out. This is different for a service. If they're dead, they will display red. And I want to quickly show that. So if we go to jobs, we choose one and we stop it, you will immediately see that the color basically changes, right? Yeah, so this is similar for deployments, everything else. If they're pending, they will be displayed yellow and so on. So let's go quickly back to the web UI and start the job again, because this is also not implemented yet, so that you can do it from Daemon. But this will be a feature that is also coming soon. All right. So you can immediately see that it's running again. And this is similar to deployments. And now we'll just change the view to deployments by hitting Control D, like as displayed in the commands above in the header, right? So if we hit Control D, we see the deployments. And if we go quickly back to the UI and we stop the job again, and we start it, it will start a new deployment. And you see that running deployments are highlighted, right? They have this bluish, greenish color, bright bluish color. And so that you can always see like there's something running, there's a deployment running, and you can basically have like an overview of what's going on. Nice. So let's take a quick look at the time. Yeah, we're short on time. Next thing is Control N for namespaces. It's boring, but it's still like super important to me, at least, to know what namespaces are there and like to see a description, what this namespace is about, but what can I find there, for example. So this is also pretty handy, but you cannot do at this point in time anything else here, basically. So let's go back to jobs. Now I want to show like how can you switch namespaces. Like hitting S, you can switch the namespaces. So for example, if we go to the test namespace, you can see that there is one job running, right? Hitting S again, we have an empty namespace because I want to show that again as well, just to, show like how does it look like if there are no jobs available. You will just get this little information that there are no jobs available. Same as for deployments, we'll say there's no deployments available, or there's no namespaces available, or no logs available, and so on. We will get to logs soonish. Yeah, so if we go back to the defaults namespace, we can continue with the allocation view. So if we go into, for example, the example job, we can see the allocations. And what you didn't see here right now is that also like the subcommands will change depending on which view you are showing. In this case, we are in the allocation view, so you can see the allocation commands. And here you can only hit enter to display logs. So let's do that. And this will bring you to the log view. Yeah, so here you can scroll through the views using the mouse, but you can also use J and K or arrows up and down to scroll through the view. There's not enough logs right now to do that, but yeah, it's still possible. Like, also use capital G to get to the top. You can use G to get to the bottom and so on, like similar to Vim again. What you can also do, and this is like the pretty handy thing, is that you can hit / to search it, right? It's like you can search the logs by hitting /. For example, if I hit config, it will show me the lines that have config. Another example would be if we hit Redis, there are 2 log lines that show Redis. And the search string that you enter will be highlighted in yellow, and everything else will get a little bit grayed out. So if I go back here, you can see again like all the logs, and they are not grayed out anymore. You don't see any highlighting anymore. And hitting enter will bring you back from there. If you hit enter, Control O or escape, it will bring you back to the allocations view. And now if you want to go back again from the allocations view to a previous view, Daemon has a history that you can go through with Control O. And Control O brings us back to the jobs view. And yeah, I think here we are on time. I think I was able to show the most parts and the most important parts of Daemon here. There's a little bit more that you can do, like, for example, you can hit Control P to jump to a specific job, like space to job, and then you get to the allocation directly. And there's features missing, and they will come. Watch out. Where can you find the tool? You can find the tool on GitHub under the HashiCorp organization. So yeah, thank you for attending. Bye, everyone.
That was a super cool demo. I like seeing that. Also, nice ASCII art. In the terminal. That's if you have to stare at it the whole day, it's nice to be able to look at something fun. Next up, we've got something special. Mary.
Yeah. Next up, we're welcoming Rosemary, Jeremy, and Scott, who are going to be having some tea and talking to us about maintaining a Terraform provider, among other things.
Hello.
Thanks, Mary. Thanks, Kareem. Appreciate the two of you introducing us. Well, hello, everyone. We're having a little tea time, I guess, with two of the maintainers, for lack of a better word. They'll probably correct me if I'm wrong, because they might be the person that you message on GitHub. But the Terraform provider maintainers, we have 2 of them today from the community. We have Jeremy Udit and Scott McAllister. Hello. If you could please introduce yourselves, what you do, and which Terraform provider you maintain.
I can start off. Hey everyone, my name is Jeremy Udit. I'm working at GitHub right now. Over the past 4 years, I've mainly focused on the infrastructure side of things. And in the last year or so, I moved over to maintaining the Pages product. And through that whole adventure, I was able to pick up maintainership of the Terraform provider for GitHub. And I think about 2 years now, been shepherding that community through new features and bug fixes.
And I'm Scott McAllister. I'm a developer advocate at PagerDuty. And I discovered the Terraform provider for PagerDuty shortly after I joined the company, and basically got involved with the project pretty early on in the time that I've been here. And just like Jeremy, I've basically been shepherding it for the past 2 years. So it's been a fun experience.
Yeah, it's really interesting. Both of you are sort of stewards by accident, well, I guess by accident of sorts. And I think that's what happens with a lot of Terraform providers. Someone sees the use or sees the value in them, but they need a maintainer. Do you think, I guess the one question I do want to start with is, did either of you have Golang experience before you started maintaining the provider? Oh, wow.
I did not. No, this was my first introduction to Go. I essentially came into the company and someone approached me, probably not even a month in. They're like, "Hey, there's this thing called Terraform," and which I'd heard of, but I mean, they talked about how we have this provider. It's run by the community. It's supported by the community. It's been built by the community, but we need this one feature added. It'd be great if we could like get you to do that. And I said, "Sure, why not?" And that's how I got involved.
Yeah, my involvement was a bit more structured, but coming into the project, I did have some experience with Golang. So maybe a couple of jobs ago, I had a break between jobs and figured Go was a fun language to learn. So very studious about it, just picked up a book, did the exercises, and played around with the fun parts of the language. And then over time, ran into small projects, and Terraform, the Terraform provider was one of them.
Awesome. Now, for those who are hanging out in YouTube and Twitch, if you have questions, please post them in the chat. I am monitoring both. I don't know if you want to see how many screens I have up right now, but if you do have questions about Terraform provider development, maintenance, either the PagerDuty or the GitHub one, please post them in the chat. I will ask them live. In the meantime, we have a bunch of questions because as someone who has worked on some of the providers, I also have many questions. And I'm always curious to learn more about how different folks develop it. So with that in mind, I'm going to proceed to a couple of other questions that I have. The first is, this is tea time. What tea are you drinking? Or if you're not drinking tea, what beverage are you consuming?
For myself, I skipped on the tea. I had my tea earlier this morning. It's around noon for me, so I'm having a black coffee, which is a strange choice for middle of the day, but I had this to deal with, so more energy.
For sure. I'm on the west coast of the United States, so it's 9 a.m. for me, but not much of a coffee tea drinker, so I'm just on my water right now. But normally, I got a Dr. Pepper close by, so
Nice.
that usually comes in around noon. Not that I
Hey,
have my
that's
life
not
down
too
to a
early.
schedule, right? Some days it happens. Some days it happens at 9.
It's awesome. Yeah, so as 9 a.m. crew reporting in. Yeah, that's definitely how I feel. I am drinking an iced tea. It is a Lady Empress Grey, which I'm not really sure how that's different than any Earl Grey tea, but anyway, it's pretty good. It's iced. All right, so we got that out of the way at least. And I asked a question about Golang experience before because a lot of people think that you need to have a lot of Golang experience in order to do provider development. I just wanted to set the stage that you don't necessarily need to have Golang. You can pick it up and you can learn it along the way. So other than maybe not having vast Golang experience with Terraform to develop a Terraform provider, what's the most difficult part that you found when you were trying to learn the Terraform plugin SDK for your provider?
I could jump in on that one.
Yeah.
I think this was definitely my bad early on. And it does speak to my intermediate and beginner-ish levels of working with Go projects. So I found that discovering the feature set of the provider SDK was a bit difficult. And it was all about just how I was going about it. throughout my time at GitHub, I eventually switched IDEs and got better link outs from when I was coding. And that eventually got me to the pkg.go.dev site, which is really great for just explaining what projects are about and what's available. So as I grew as a Golang developer and the tooling in the space, I was able to kind of get rid of all the difficult parts of learning about the SDK.
Jeremy, which IDE did you pick up?
So I moved from, I would say Vim originally, but then when I got to GitHub, I jumped onto the Atom train, and I loved Atom. It just worked. But then the plugin I was using for it, it just started to fall apart, and then everybody was jumping onto VS Code, and that's where I'm at right now. So it's still not perfect, but it's better in certain areas.
That's the one I'm using as well. I was just curious if there was a better one, right? Because VS Code seems to be getting me there. Yeah, for me, I think that it's a similar thing. It's just trying to discover what is possible with the provider SDK. So the thing that I loved about using the provider as a way of learning Go is that you already have this project set up and you already can see how things are done. And so you can kind of ease yourself into adding things and to seeing how, to architect things and to put things in certain spots and run data in a certain way. And so I enjoyed that. That really helped me out as far as getting to know Go. And honestly, the provider, like picking a provider that's already in production, already being used by a community, really allows you to have a kind of a launching point to get going. And as far as like learning things, I mean, yeah, learning Go is kind of a tricky thing. Just, getting back into, a language with pointers and things like that was a little, I had to remind myself how that worked because I had a lot of JavaScript experience before. And so, but it's been great as far as that goes. And what I have loved about the development of a provider is it's something that the original creator of the PagerDuty provider mentioned to me, is that he said the reason why he kept developing it and kept maintaining it is because of the community of people around provider development. They were so encouraging and so helpful that it just really kept him going. I mean, he honestly maintained the PagerDuty provider for 3, 4 years, 5 years until we got involved. So, I mean, that was pretty awesome.
Yeah, I will say I'm a VS Code person too. And even I learn a lot of tricks. I think I was on a live stream helping someone write a provider, and Patty, shout out to Patty, who's one of the plugin SDK team, hopped on and actually in the chat gave me tips to debug using VS Code, which I was like, I didn't even know you could do this. I feel like that was as a provider developer, right? That was the tooling that I wasn't even aware of I could use, right? There's a lot of feature functionality in VS Code specifically. I do know a lot of people who use Vim still. So, if you do, that's great. More power to you. I like the debugging tools in VS Code. All right. So there is a particular challenge or an interesting challenge with providers that have very little to do with the plugin SDK itself and everything to do with the API that you're working with. So did either of you have issues trying to design the resources and data sources because maybe your API endpoints for your target API weren't 100% great? Or did you have any trouble with some of the API's behaviors? Like they're not exactly create, read, update, delete, or there's pagination involved. Can you talk a little bit about if you've come across any of those challenges?
Yeah, for sure. I think on the GitHub side of things, we've got an API that's grown over time, and adapting the provider to that has been a difficult challenge. Outside of just our API itself, when we've implemented resources in the past, we've not been very future forward with it. It's more of like we'd release an experiment, maybe it works. It's just something that the community could play with, and then shave off all the rough edges over time. So working in that fashion, things about the API come up. So where pagination is needed because we're trying to create too many resources in a certain manner, and performance and timeouts, things like that. But getting back to examples with GitHub, so repository visibility is a really tricky one where you'll have your code repository, you can make it internal, you can make it public, you can make it private, but there's side effects that come with it. And we found this out the hard way where people started to notice that when they were changing visibility, all of a sudden some other setting over here got changed, which was unnecessary. I think at the time it was vulnerability alerts, and we were just rolling that out. The defaults are different. So if you have a public repository, it'll be, I think, on by default. If it's private, it'll be off by default. And then it just didn't play well with what we were trying to do, and super confusing to debug as well. So little gotchas like that, they'll pop up every month where we're trying to implement against something that's eventually consistent in terms of feature set across all the different types of deployments. And we just have a lot of very excited people trying to jump on features before they may be ready for general consumption. So it's definitely something to look out for when working with your provider.
It's so good to hear that other people at other companies have these conversations with their engineering teams about their APIs. Yeah, at PagerDuty, it's the same thing. When you start really supporting Terraform and having Terraform being available for your whole API, it's starting to pull back the covers on all of the API, and people want the whole thing there. They want all the UI features in the API. They want it to be the same. And then you realize that using Terraform, maybe there's some corners in there that aren't quite thought through, or, you know, thinking through ideas of like some problems I've had is some folks have proposed API endpoints that had objects that didn't have IDs. And so it's like, well, I need to be able to have an ID, right? Like Terraform needs to be able to identify something. And we'd go back and forth, and then they'd see why we needed it. And then it actually helped make our API better. And then another one is how Terraform is, you know, it uses the schema, right? The strictly typed fields and things. Folks building on our API like to have freedom to be able to have, you know, dynamically typed objects. And so talking people through like, well, that's great, but then, you know, it's a little more tricky to use with a Terraform provider or to develop with a Terraform provider. And so one of the ways, and this, I'm sorry if this kind of diverts a little bit, but one of the ways to kind of help with those conversations that I noticed is that one of the first things I did when I got involved with the provider was to add a user agent header to the project so that we could see what traffic is coming in on the provider, who's using it, like, and how often, and is this thing actually being used by our users? And we discovered it really was being used by our users quite often. And so that really helps in those conversations, because then you say, well, this many, you know, users or customers are using the Terraform provider and they're using it this often. We need to make sure that, you know, XYZ feature is absolutely supported because these features or these customers are relying on it. So that's something that helped with ours.
It's really interesting. First of all, I've never heard the user agent recommendation. That's at least the first time I've heard about it. And that's actually something we should put it somewhere. We should put, first of all, we should write
That's a
somewhere.
great suggestion.
I know. I was like, wait a second. And the other thing is that I guess the question to this is that if you were to design an API from scratch and it was for Terraform, right? What are some of the things that you would suggest right off the bat? I know, Scott, you mentioned have an ID for objects. Is there anything that you can think of that you would tell that API designer, please have this because it would really help us for our Terraform provider?
The one thing that just popped in my mind is that responses, right? You want responses to come back, and you want the responses to have that ID and the object, because again, Terraform's expecting that. Terraform wants to put all that response in a state, and there's some API endpoints at PagerDuty that do not send back a response. So I mean, it's that would definitely be something I would suggest.
I think from the GitHub side of things, we've definitely been bitten by inaccurate documentation. So just you know, if it's out there and we're telling the world that it works a certain way, let's try to make it functional. We've been bitten a couple of times on that, so just really good documentations really helps with the debugging efforts.
Both good things. We had a question come in from chat. Did either PagerDuty or GitHub run into any problems with eventual consistency on the API side while maintaining the provider?
Eventual consistency with data or with features, like in the API? Because like with,
let's say both.
I was gonna say
either
with
one.
data, yes, that is one of the struggles I've been having, is figuring out, there's a lot of dependent objects inside of PagerDuty that, certain things are dependent on other things. You need a user before you can create a team, because you need to add the users to that team, but the users need to be in the database before it happens, or something. That's a simple example. And so on a lot of operations over the last year or so, we've been trying to add a little bit of, once you're on camera, you can't remember the words of things, but retry, basically retry logic, basically just like, wait, hold on, wait a couple seconds, now try that. Okay, see, now that object's there. And so we've had to do that. To be perfectly transparent with that, the solution we came up with probably wasn't the best, because I was putting retry logic on each different call inside the provider. I probably should have put the retry logic into the client library first and just done it all there. But hindsight's 2020. So it kind of already passed the point of no return on that one. So.
As for GitHub, we've been pretty rock solid on data eventual consistency. Like, I think a while back, there was a feature that we put in place because we wanted to ensure that our users would always read their own writes, and that's pretty much solved it for us. And definitely on the feature availability side of things, that's hurting us, because we've had features land in our V3 REST API and not in the V4 API, and the converse where it's just in the V4 API, and just not just those cases, but also the GitHub.com deployment, as well as on-premises enterprise deployments. They have a feature disparity as well. So that's a pain point for sure.
That would be tricky, having to deal with on-prem and not on-prem. That would be hard.
Yeah, it's where a lot of our discussion goes into in our issue tracker. And we were talking about this morning, we just have to have more defensive coding about it. Now the provider is being used in various different ways. I think at the beginning, it was mainly the GitHub.com deployment that it was written out for. But yeah, we'll have to get smarter in the code to abstract this from users so that they could just use it, it works, and all the ugly bits are hidden away.
Yeah, I think that's a challenging thing. And I don't think there's unfortunately no good way to solve the problem, which is when you have a lot of API versions and a lot of schemas across a lot of different tools and products. But it seems like it's good to hear from the two of you, right? And understanding maybe some of the different approaches that you've been taking to solve the problem, and some things to consider. For example, putting retry logic into clients. I actually did that the other day with a Vault plugin. So that was my mistake. It follows the same. It doesn't matter if it's a Terraform provider or a Vault plugin. You should just put any retry logic into your API client library, please. All right, we have a couple minutes left, and I don't see any other questions coming in from chat, but I did want to ask the two of you, what's the best way for someone to contribute to your provider?
I mean, for us, I think it's, submitting a pull request, just kind of going through the GitHub project and doing it that way. I should say I'm a one-person team as far as reviewing those. And so it might take me a minute to get to it, but always welcome any changes and updates to our provider for sure.
A very similar answer over here. We use GitHub as well. Just the issue tracker. It's at one point I was overwhelmed by the amount of issues and bug fixes and feature requests that were coming in. So I had switched more towards a triaging mode instead of a let's fix everything mode. So everything is labeled. We have good first issues for people that want to come on board. And I like this discussion so far that highlighted that these types of projects, these providers are really great onboarding projects for people that want to learn Go. And I think after this, I'll try to augment our issues a bit more to be more towards that angle, because there's a good amount of work that's just small, and it's not necessarily in depth in terms of the amount of context that you need to know around the Terraform ecosystem. So yeah, just looking out for the typical good first issue would be a good way to jump in and help out.
Awesome. Well, thank you both. I'll drop the links to the GitHub provider for Terraform and the PagerDuty provider for Terraform into the chat. You can find them on the Terraform registry. Jeremy, I think you're going to be giving a talk later, correct, about maintaining the GitHub provider. Awesome. So if anybody who's on the stream is around, please tune in later. That will go in depth into the GitHub provider. Thank you both very much for joining us for this panel. I have way too many questions and I didn't get to all of them. I feel like we need like a separate panel just about Terraform provider testing, because I think that's the next big part of developing a provider. But in the meantime, thank you both for joining us today. And I'm going to pass it to Kareem and Mary.
Hello, welcome back. Kareem, I can't hear you. I think it'll be me for right now, which is very okay. So I think right now we're heading into a little bit of a break. So we have about 10, 15 minutes, and then we'll come back. I think we'll say goodbye to Kareem and we'll come back with me and Taylor after the break. Great. Kareem, I don't know what happened.
Recording in progress. Awesome. Welcome back, everyone. Really happy to be here. I know that we saw Kareem exit our stream, and quite sad to lose him, but definitely hoping that he can get some rest and relaxation. Mary, it's a pleasure to be here this morning. Greetings from the West Coast. I would say it's the best coast, but some might disagree with me. Definitely happy to have gotten some tea, some coffee, and now just have some nice carbonated beverages to keep me company. But so far, we've had an action-packed morning.
We have, Taylor. Let me catch you up on what you missed and what I missed as well. So first thing in the morning, Kareem and Thomas talked about how OpenAPI saved the day. And then we had a double back-to-back session from Kyle Ruddy and Tom Harvey talking about sensitive values in Terraform and then building resources in the Azure provider using native Go types. Then we spent some time with Philip Struve talking about integrating Kustomize, which is a custom Terraform provider, which takes us from provisioner to provider. Kyle Penfound talked to us about FPM and Linux packaging. Then we had a live talk getting into Terraform provider development with Vladimir and Aris, who are both contributors to the Terraform Azure provider. And then we rounded out the morning with Kristen Lammert talking about the Terraform plugin protocol v6, Julian giving us a demo of Nomad terminal dashboards called Daemon, and then a fun panel session called Tea Time with Rosemary, Jeremy, and Scott talking about maintaining Terraform providers, which leads us to where we are now.
My goodness, like certainly an action-packed morning. I can't believe that I just missed all of that. That's absolutely crazy. Well, I know we have quite a long way to go as well. It's right now, it's only about 9:30 Pacific AM, and I think this goes all the way to like 11 tonight Pacific time. So really, really excited for all the sessions that we have yet to explore and yet to see. Awesome. I think with that, we can we should go into our first session, which is building a Vault plugin for Redis with Francis Hitchens. Whenever you're ready, Francis, feel free to give it a go, and looking forward to your talk.
Hello, my name is Francis Hitchens, and I'm a principal software engineer at Amdocs. My presentation is going to be about the Vault database plugin that I've been working on for Redis. The plugin allows a Vault secret server to create and manage the entire lifecycle of all or any user passwords and their desired access control lists associated with it in a Redis directory or database. Authentication has existed in Redis since version 1.0, but without TLS. So anyone who could sniff network packets would have been very easily able to look at the credentials and steal them. It was also really easy to perform brute force attacks on Redis. Redis was or is very fast at serving queries, so many different password attacks per second can be done by an external client. This was a well-known weakness, and it was recommended to set the administrator password to be very long to get around that. So of course, anyone using Redis in a production environment had to lock it down using compensating controls like layer 3 networking security. Prior to Redis version 6, there was no support for TLS or ACL-based authorization. Redis 6.0 was released in June 2020, so this hasn't been around for quite a while. It's quite difficult to set up and manage, especially in a cluster, so I think adding this facility to Vault will be useful for quite a few corporate users managing large Redis clusters and things like that. So I'm going to do an overview of Redis for those of you not familiar with it, because it's quite different to a lot of standard databases. We'll have a look at Redis clustering as well, as that's fairly unique. a brief glance at the custom plugin library, but I expect most HashiCorp developers are very familiar with it. Have a look at my to-do list, and I'll try and do a hands-on session using the plugin to show you how it works. Okay, so for those of you not familiar with Redis, I'll try and briefly explain what it is. It's a very fast open source in-memory directory or database or cache that's typically used to store objects by key that you want to access quickly, like session data, and get rid of quickly, and those don't need persisting to disk. It can be deployed in a number of different ways, as a standalone server, as a cluster with automatic partitioning of the keys, or as a highly available Sentinel installation. Sentinel installation I haven't looked at, and I don't know when I'll get round to that, but I don't see that it should fall outside the scope of what we can do with the plugin. Maybe it needs some tweaking, or some different APIs have to be used to talk to it. We'll have to see. Okay, Redis clients communicate using a very simple text-based protocol called RESP, Redis Serialization Protocol. And it's over TCP, and lately you can also add TLS to improve the security. Get and set are examples of REST calls. Get and the key gives you the data back associated with the key, and set sets the key to the value that you want it to be set to. Okay, for the purposes of managing authentication and authorization, the ACL group of commands and their subcommands are used. Here, the ones that are mostly used in the code: the delete user, the get user, the set user. I'm sure you can imagine what they're used for. Users and ACLs and their ACLs are stored in memory only unless you explicitly persist them using the ACL save command. I'm imagining that any real production setting, you'll want to persist users between restarts of the server. So Redis has to be actually started with an actual configuration file mentioned, which can be used to define a specific ACL file to save the provisioned users between restarts. You can use this command that is illustrated here, config get ACL file, to show you whether there is an ACL file configured or not. If there isn't an ACL file configured, but there is a config file, and you do ACL save, Redis server will save the users into the config file, which isn't ideal, I don't think. So, you know, you don't have any control over that, and it's not easy to figure out which way it's configured using the commands in Redis. So be aware of that. ACLs are grouped into high-level categories, which is very useful, as it allows us to write vault roles without needing to specify every single command that we want to control access to. There are an awful lot of them. Even when they're gathered into these categories, there are 21 different categories. So here, let's take a look at how we can use the categories to declare a vault role that can be used to grant access to a user that's not privileged to use some of the commands categorized as dangerous in Redis. The first line here, ACL set user Karen on, make it active, adds all of the particular ACL roles that are available, but then subtracts the ones that are in the dangerous category. And this can be simply used to write a vault role to do that. the command is illustrated here, where we create the role, set the database name that we're applying it to, TTL max, and we use the existing creation statement with a vector of strings just to put the particular ACL categories or ACLs themselves in that we want to use. Again, we can use the ACL cat command to see what commands are in the dangerous category, and there again you can see there's an awful lot of them. 31 different commands are categorized as dangerous, and user Karen is not meant to have access to them. So when I came to look at writing the client, I had to decide which of the many open source Redis Golang clients to pick. There are 15 of them on the official Redis clients Go page. They're all open source. They all come from different users or groups of users who like to work on Redis clients. 3 of them had gold star recommendations in the Redis page, so I just focused my attention on them. I didn't want to look through all of them. Out of the 3, I found that the one called Radix, which I mention here, looked the best one for the reasons that it had the most activity on GitHub. It natively supported clustering and TLS, and it had the best documentation that I could find with clear examples for me to follow in my code. And the lead developer, Brian Picciano, was very kind enough to answer questions I emailed him, and he actually reviewed my code for correctness in the end, so I was fairly happy that I'd done a good job using his API, or client API rather. So I started working on the standalone server first, and it was fairly simple to work out how to access it and how to set the user count and password and to provision roles and so on. And the Redis documentation, looking at it, it wasn't really clear how when you moved from standalone to cluster, things changed. I didn't know whether I could just provision to one of the cluster members and it would be automatically replicated to the others or anything like that. And I had to try it out and find out that actually no, it wasn't. I had to go and do the work of figuring out what the topography of the Redis cluster was and going to each of the worker nodes or nodes and repeating the provisioning commands on them. So, and another wrinkle was that if you added a new member to the cluster and didn't re-shard the partitioning of the keys, that cluster member was not considered as part of the cluster. So it would never get provision to a username password that you wanted to be cluster-wide, which kind of makes sense, but you have to be aware of these odd things. So when you configure a cluster in the plugin, as we have here in the middle, you give it a list of the hosts using the cluster equals parameter that you want the plugin to try and connect to, or actually the Radix API call inside the plugin. It does that, and it'll connect to the first available one that works with the configurable timeout, and then you move on from there. So this example shows me configuring a database called My Cluster. The cluster host has host 1 and host 2. We pass it the account that we're going to use to do the provisioning inside the Redis cluster, and we give it a persistence mode of use the ACL file, which we'll talk about more in later, and pass it the CA cert needed to connect securely to the cluster. Within the plugin code, we use this topo method to return the actual cluster topography, regardless of what's mentioned in the list here. In order for the plugin to provision the same user to each cluster member, it has to go get that topography and iterate through each one of the members in the list and apply the provisioning commands on each one in each host in that list. This is just showing you the Redis cluster nodes command brings you back this detail about the cluster. It's got some kind of internal serial number, and then you've got the IP address and port that each one of the members is listening on, and whether it's a master or a slave, or on which one is myself, the one I've actually connected to, which you can see third line down, I think. Okay, so calling the topo method in the Radix API hides all these details from you and just gives you a nice list of host and port for you to iterate through. We can possibly look at that code later. The custom plugin library, just for everyone's knowledge, it was written using the version 5 interface, which is the one supported now by the latest version of Vault. It's much more simple. It's been simplified compared to the previous plugin library interface. It's got many of the overlapping duplicate methods removed, and we only have to implement these particular methods now: initialize, new user, update user, delete user, type, and close. Much simpler. There's no rotate user, which is really just a call underneath to update user. So it's streamlined, easier to use, and much nicer. These are the things I still need to do. There's a sort of sister Spring Cloud Vault config project that supports accessing databases with credentials from Vault through the Spring Cloud framework. It's already got support for Cassandra, Couchbase, Elastic, Mongo, MySQL, Postgres. I need to do the same for Redis. It's not difficult. I don't really like working with Java and annotations all that much because they're very opaque, but I'll try and get round to that in the next steps. Okay, so I think that wraps up more or less what I wanted to do as a presentation, and we'll try and move on to a demo of the plugin now. So I wanted to start the demo by just briefly looking at the Redis client that I used, and in fact we used version 3 of it, version 4 still in beta, and I just wanted to show you that it's nicely documented with plenty of easy to use examples, very helpful. Made it easy to do. So now let's switch to looking at my own Vault plugin repository. Standard layout, like all of the other ones, has information on how to build the plugin, how to install it, how to initialize it against a standalone or cluster instance, and some examples of dynamic and static role creation. So let's go back up to the top and have a look in the main Redis Go program file. And in particular, I want to focus on the new user method, as it's very illustrative of all the other ones. So, of course, we start off as usual by getting or creating some credentials, getting a connection to the Redis database or cluster, and then using a helper function to do the actual provisioning. So let's go and have a look at that with more detail. And you'll notice when we're there, the first thing we do is format the commands that we want to fire off. It's a vector of strings that create the user, turn it on, and set a password. Here it's the generated password. And then the next thing we're going to do is take a look at the kind of connection we've got. If it happens to be a standalone connection pool, we're just going to go and fire off the command once to the Redis database. Otherwise, if it happens to be a cluster, then we've got a bit more work to do. We need to get the topography of the cluster and start iterating through the nodes, and again firing off the user creation command on each individual one, and then persisting the changes if it's successful. And in fact, we persist the change 2 on the standalone instance. So that's a very common pattern for all of the other functions. So now I'm going to move on to running the test suite for the plugin. This first run is going to be using the code that spins up a Redis Docker container and connects to it and runs all the tests against it, where of course it can't persist any of the settings as there's no configuration file. In fact, it tells you there if you see. Now I'm going to export the environment variable to start using TLS, and the next one to export the cluster hosts. I'm only going to connect to one local host, and from that the test suite will pick up all the rest of the clusters and start provisioning accounts to the various cluster members, which is handy because I can then use the administrator username password to spin up the Vault plugin in the next part of the demo. So as soon as this is finished, we'll move on to that. This time it's running and it is able to persist the changes that it's making. You'll see that it doesn't say otherwise, I hope, at the end. That done. Alright, so now let's have a look at the plugin integration with Vault. I have a script here that I'm going to use to shut down an existing Vault server, spin up a new clean one, and then we're going to copy the plugin into the plugin directory. We're going to then go and generate a checksum for it. We're going to enable the secrets, the database secrets engine, and we're going to register the plugin in that secrets engine. And the next step, I'm going to generate a environment variable with a CA cert in base 64 encoded, and I'm going to use that to feed into the Vault initialization of the plugin here, and it's going to create a connection to the database. We're going to use the cluster address. I think we've got 2 members in the address. It'll go to the first one available. Here's the administrator password that we created in the sanity testing that we did before. We're going to persist to the ACL file, use TLS, and there's the certificate being passed in. And in the next 2 steps, I'm going to create a write role for the foo key and a read role for the foo key as well. And then we'll do some other things with those. So let's come out of here and execute the script. And let's hope it goes flawlessly. Then we'll be in a position to start using Vault. and the Redis plugin. Okay, so before I do that, I'm just going to check and make sure that I've got the roles that I need, or the account set up correctly. Just a quick script to list the users on each of the Redis databases ACL file. Yes, I can see the administrators set up in each one of them, and if you'll notice, this is the default user that has privileges and no passwords, and of course as soon as we've got managed by Vault, we really want to think about getting rid of that one and letting Vault rotate the admin password and making things more secure. Okay, so now I'm going to go and sign into the Vault console with the root token, and let's go have a look in the leases and see that it make sure it's empty. Good, nothing there, so we'll go start creating some. All right, so let's do a PS command, and from the output we can see that we've got the Vault server running, and it has successfully started the plugin to connect and communicate with the database. So let's go grab ourselves some read credential, no, some read, yeah, let's get a read role now. And here's the username password. So I've got a script to simplify testing. Just pass in parameter number 1, the username, parameter number 2, the password, and the subsequent parameters are the Redis commands I want. So I'm going to try get on the bar key, and yes, I don't have any permissions to access it. So let's try get on the foo key. And that worked, even though nothing came back. No security violation. So let's check, use the ACL file and see whether the username's been provisioned everywhere. And yes, I see it in all 4 of the cluster members. Okay, so now let's pop into the Vault console, database, credentials, read role. Oh, there it is. Let's revoke it. Okay, gone. Back to the command line. Let's execute that check again. And oh yes, good. We've managed to remove all of those usernames using the Vault plugin. So now I'm going to get myself a write credential. From the write role. Again, username and password generated on the fly. I've got my set script to simplify the test. Pass in the first parameter, the username, the second parameter, the password, and now we'll try and set a key to a value. That's when my fingers start working. Set XXX 999. Okay, and no permissions, no surprise there. Let's try it on the one that we have access to. Okay, that worked fine. Let's set the other one, the bar key, and let's be original and set it to foo. Jolly good. Okay, so now let's go grab a read credential and try and read that, make sure it actually worked. Jolly good. So let's try and get the key that we're allowed to read. Username, let's pass it in. Password. Really good. And get foo, and 999, success. The Vault plugin has been able to do its job. Okay, so my final trick coming up now. Let's check the user password, the administrator password. It's the same on each machine. So let's go rotate it now so that we're nice and secure. Rotate the root password for my secure Redis. Done. Check the passwords again. And you will see they've changed and are known unto Vault itself. So here endeth my demo. I hope you weren't too bored. Thank you.
Yeah, I had heard that it was possible, but I had never seen it done, and so it was very cool to be able to watch Francis walk us through the process, and definitely
Hi, everybody.
sparked
This
my
is John.
curiosity.
Oh, wonderful. Oh, there we go. So sorry about that, everyone. We were both muted, so having a good conversation with ourselves. But awesome. Welcome, Francis. Welcome, Francis. Thank you so much for coming today. Apologies while I get just a couple things set on my side already. Welcome. So thank you so much for talking on that subject. I was just talking with Marion, remarking on how interesting and fascinating that it was that you have all this ability to work with Vault and create these custom plugins and things like that. Can you dig a little bit more into what ignited that want to create that plugin for Vault and kind of some of the first things that you looked at and the first steps that you took on that journey?
Can you hear me?
Yes.
You can. Awesome. Well, commercial really, because our biggest customers want to be able to manage these systems. I wrote one for Couchbase last year, and Redis is now one of the top selected databases or directories for another of our major customers. And I know, every year security requirements become more and more onerous and tedious, and as they've added the ability to, authenticate and authorize use to Redis, that I'm sure that will be coming along the line very soon.
Absolutely. Interesting. Thank you so much for that. It's interesting to see all of the different ways in which Redis has been used as well. There were some talks I've heard from people at Netflix, people at Amazon, and just as the years go by, hearing talks about memcached Redis and all of these other systems never ceases to fascinate me, as well as the ways that people go, the ends that people go to secure those, and really fascinating to hear about that in Vault. Is there any questions or anything like that that you had, Mary, for Francis on that front, or about Redis or Vault, or really anything in general?
I'm not sure about that. I did catch the very end of the talk, luckily, and I was really interested to see how sort of all of this came together, how your process came together for building this custom plugin for Vault. I didn't catch this, so if you did talk about this in the talk, I would love to hear it again, which is sort of how you decided to get into building a custom plugin and what your advice would be for someone who's also maybe looking to do that.
My advice, well, I got into it because it, for work purposes, really, not just not just for the hell of it. And what would my advice be for anyone who else wanted to get in? Would be pick something that is of importance to you, where you can see that Vault support will be of a benefit for not just you, but more than one person. It still needs a lot of work, and I've realized that I must be going through this microphone and not that one, so I can get rid of the headphones. I'm sorry, I'm using a very elderly Linux box to do this. That's why I'm a bit blurry.
No worries.
So what was I going to say? The worst thing about that particular plugin, though, is the testing of it, because it spans various different kind of installations, and I can't at the moment see a good way to automate that. You know, you can't get a Docker container that out of the box will have a Redis cluster in it or a standalone server, and even worse, if you want to go on to the Sentinel deployment, that's where I'm stuck at the moment, trying to think about how I could donate it to the community in a format that is, you know, testable in a pipeline.
Awesome.
Awesome. Thank you.
Oh,
Taylor, I'll hand
wonderful.
it back.
Awesome. Well, thank you so much, Francis. We've had a pleasure hearing your talk today. Thank you so much for stopping by for Q&A and just showing us that you know, you can always secure something, and that you can always take a look, write a provider, and make that thing work for you. So thank you again very much.
Thank you. You're welcome. Bye-bye.
Adios. All right. I'm going to go ahead and pull in. Looks like our next talk is going to be from Alex Samuelson, building Terraform providers with dynamic resource types. Now, Alex, I don't believe that we have met in person. Now we have, digitally, so that's awesome. Great to meet you. How are you doing today?
I'm doing great, Taylor. Thanks for the introduction. I'm super excited to actually share some fresh perspectives here. So, yeah.
Awesome. Well, I know that I've heard that you're a Kubernetes fan, as am I. Really enjoy that product and working with those people in different communities and problems in that space. So definitely keep the Kubernetes fire going. And had to give you a shout out on that front too. But as soon as you are ready, the stage is yours, and we'll be here watching and taking note.
Yeah, thank you very much. Let me just start sharing my screen. In the meantime, how is the sound coming through? Am I doing okay sound-wise?
Yeah, I think this sounds good.
Okay, thanks. Okay. So give me a second to start the slides. Is everybody able to see the slide view correctly?
Yeah, I think it's just booting up now. This is always the most fun parts of just about every meeting is is slide setting and audio checks and all the like.
So on my side, it actually isn't doing much. I've started sharing, but I'm not sure if it's actually showing.
I think, yeah, that's what I think the same thing's happening here too. It's it says you've started screen sharing, but isn't showing anything just yet.
Oh, should I be waiting or should I try again?
I would say it wouldn't hurt to cancel that and then try one more time.
Let's try again. How about now?
It looks like it is still. Oh, I think it might be starting up now.
I'm trying to use the speaker view in Google Slides, so that might be actually an issue. I'll just get rid of that and just do a normal share of the presentation view. Let me try that again.
Gotcha. Yeah, that might be it. I think I just had some issues with that recently, and was very lamentful about the lack of being able to do that.
Yeah, let's just try this one more time. How about now?
There we go. Perfect.
Oh, great. Okay, no speaker view for me. Hi, everyone. Yeah, thanks, Taylor and Mary, for leading the charge on this. I'm super excited to be with you here today. We're going to be talking today about a little bit of a niche thing, also pretty new perspective on provider development. I would venture to say even experimental at this point, as only one provider has actually made use of this technique. But it's a very interesting technique nevertheless, and it managed to unblock us from a very long-running user request, which is Kubernetes custom resource definitions. And so with that, let's dive in. So Terraform providers, right? By this time into the talk, you've likely heard a bunch of my brilliant colleagues talk about different mechanisms to employ in building your providers. You've seen some different perspectives on building providers for Terraform. What I'm here to talk to you today is a slightly lower level mechanism. But before we dive into that, let's set the stage for everyone so that everyone has kind of like a baseline understanding of what a Terraform provider is and how it functions, so that we can move into more things, into more interesting things otherwise. Slight peek under the hood of a Terraform provider. They are essentially a gRPC server. Terraform CLI is the client for that. It basically starts up the provider as a standalone process after it has parsed the resource configuration that you as a user provide to Terraform. It'll have determined which providers are required. It'll have started them up, set them up as a gRPC server, and then it communicates with each and every provider instance via a gRPC link. And so that'll become interesting a bit later on. But what's important to remember is that the protocol, the underlying protocol that flows over this gRPC connection is actually modeled on the user interaction pattern. So the plan and apply sequencing, we will recognize that in the protocol elements that we'll have a little later on. And so on top of that, you normally have the provider SDK abstractions, which are the first thing that handle the protocol requests that the Terraform core makes into the provider. That traditionally the provider SDK is modeled from a CRUD perspective. So create, read, update, and delete on a per resource level. The resource operations and schema, as they are defined by the provider SDK, have long-term stability guarantees. And so the provider SDK is this component that we've had almost since the beginning of Terraform. Initially, it was bundled together with Terraform, and then was extracted as a standalone package. But still, the same abstractions are kind of in place ever since the inception of Terraform. And so that makes it really easy to maintain compatibility with basically providers from the beginning onwards. As I mentioned, providers are standalone OS processes. They are, however, not launched by the user. They're launched by the Terraform core. But there is an opportunity to launch them as a normal terminal process when you're doing provider development. We won't be covering that, but I just wanted to mention it because it's an interesting debugging option that not a lot of people are aware of. Look for the --debug command line parameter to the providers. They have to have been specifically configured for this to work. Okay, so let's move on and have a look at the protocol that I keep talking about. So how does this actually look in real life? Let's take the example of a Terraform apply command. So when you go, you have some Terraform configuration, and then you go into the workspace, and then obviously you've had by this time initialized with Terraform init, and now you're about to apply the configuration. So you type Terraform apply and press enter. What happens actually at that stage between the provider and Terraform core? And so here I'm detailing a subset of the gRPC calls that are being passed around from Terraform into the provider and the responses that come back. So the very first thing that happens is that Terraform asks the provider for a schema. So you notice here, the very first call is the get schema call. The provider responds with a specific response for that call that gets the provider schema response type. In the gRPC definition, this includes attributes that convey the schema information for all of the resources that the provider can manage, but also the provider configuration block, the tiny set of attributes where you usually specify things like credentials or other options to the provider depending on the specificity of it. And so once the schema has been passed over to core, Terraform now knows how to interact with that provider and which resources it supports and which configuration options it takes for setting it up. And so there's a couple more calls being made here, and actually to validate configurations that are not specifically interesting for our use case. So that's why you see the dots. But then eventually you get this configure call. And this is really important. This is the very first call to the provider where actual information from the user is being passed to the provider. The arguments to the configure call carry over the values of the attributes that you've specified in the provider block. And so at this point, when the provider has responded from configure, Terraform has a strong guarantee that the provider is aware of its potential credentials to the target API, and it is able to talk to the target API. And so some more things happen here, other calls that are not interesting from today's point of view, but then we get to these two calls, the plan resource change and the apply resource change calls. So these happen in sequence, and the arguments to the plan resource change include the configuration for the resource that you've provided in a TF file, after which the provider responds with what it proposes to be the plan and eventually the actual resource action to be performed. And so the response from the plan resource change is then carried over into Terraform core and looped right back into the apply resource change. So the plan resource change prepares the field for the upcoming operation, and then apply resource change takes the output of plan resource change and among other things, establishes the connection to the target API and makes the actual API call that performs the resource operation that the user intended for that resource. And so this is all very low level stuff. This is not the perspective that you get from the SDK, from the provider SDK. It sits lower than that, but it becomes really important soon when we start talking about alternative to the SDK. And so let's first, again, discuss a little bit for everyone, what is the provider SDK and what is the alternative to that, which is the Terraform plugin Go package. So the Terraform plugin SDK is likely what most provider developers are most familiar with. It's the de facto standard for provider development. It's usually where everyone goes to start building a provider. It's the foundation onto which I would say 99.99% of the providers are built. It's a high-level abstraction. As I mentioned, it models resources in terms of schema plus CRUD operations, but that's not really how Terraform deals with them. Going back to the protocol for a second, Terraform deals with them in terms of the user actions, so plan and apply, but the provider SDK then translates those into CRUD operations from a provider developer perspective. So this is important because this CRUD mechanism is much simpler to use for provider developers, but it also is a little bit less flexible than what we're going to be discussing next. On top of that, you have a historical set of attribute types, which, as I mentioned, as the SDK aims to maintain very long-term compatibility and support all providers since the beginning of Terraform, and potentially all, or like at least as much as possible, earlier Terraform versions with working with new providers. It is very let's say, cautious to make breaking changes. And so the limited set of attributes that I'm talking about is actually the set of attributes that predates Terraform 0.12. By comparison, Terraform 0.12 introduced a new type system, and a very interesting one at that. So we'll be talking and focusing on that moving forward. But just know that the mature framework for building provider developments is still Terraform Provider SDK, whereas Terraform Plug Go is actually a newer mechanism, a newer component that's being released by HashiCorp to enable advanced use cases. It's also the foundation for Terraform Plugin SDK. So it's actually, it sits underneath Terraform Plugin SDK, but is also usable per se. It's a lower level abstraction, and it deals in terms of state and resource configuration plus plan and apply functions. So it actually very closely follows the protocol workflows as opposed to the CRUD mechanism in the SDK. It exposes the full Terraform 0.12 plus. So basically the type system that was introduced in 0.12 and has been available ever since in Terraform, it makes full use of that. And as I mentioned, underpins the plugin SDK. Okay, so now we know that we have a choice between Terraform Plugin SDK and Terraform Plugin Go. So which one to choose and what for, right? And our focus today is about dynamic resource types. And so what that means is a resource that can actually adapt at runtime, adapt its structure. And there's a very interesting use case for that, which I'm going to be going into shortly. But from the point of view of resource schemas, there's some really interesting differences, if you want, between Plugin SDK and Plugin Go that we need to look at, so we know which one to pick for our use case. And so, schema-wise, resource schemas are essentially the structural definitions that Terraform expects for every resource that it manages. Providers need to supply this to Terraform, as I mentioned earlier during the get schema call. And so they are defined with the SDK mechanisms. They have a smaller set of attributes in comparison to what the protocol supports. And they do not support, as I mentioned, the types introduced in Terraform 0.12 and onwards. There is also an ongoing project to basically refresh the SDK as a foundation for providers. This is called Terraform Plugin Framework. It's still a work in progress, but this will become the de facto standard sometime in the future. But now we have to shift focus to Plugin Go to actually see if it provides anything other that's missing from the SDK that we can make use of for a use case. And in Terraform Plugin Go, we still have to deal with schemas. Terraform requires schemas from all providers. This is not something you can get around but in comparison to the SDK, in Plug and Go, you have access to all of the types that Terraform Core is able to deal with. And most specifically and most interestingly for our use case, we have access to the dynamic pseudotype attributes. Dynamic pseudotype is essentially a placeholder. We'll be talking about it shortly and having a look at how to use it. But basically, let's first think, why do we need a dynamic schema? What is a static schema? And why not just use the SDK? And so static schema is essentially what we recognize as the de facto schema mechanism in Terraform. I'm calling it static because the provider has to have all the schema information right at the beginning before it has any chance to explore beyond the local system. So the provider doesn't have access at the time when it needs to report schema to Terraform, it doesn't have access to the target API or any remote systems for that matter, because it hasn't yet been configured. Going back to that protocol workflow, we remember that get schema comes before configure. So because it hasn't been yet configured, it doesn't know about the target system, and this makes schema effectively an offline mechanism. By comparison, today's topic, dynamic resource types, are not truly a schema mechanism. They are still subject to the schema requirements of Terraform, but they are an alternative way of defining resource structure, still abiding by the schema requirements, but finding an escape hatch around the static nature of Terraform's de facto schema. And so what we can do in this case is we can leverage the remote APIs, our target APIs. If they provide any structural information about the resources they support, we're able to make use of that. And also we can change the supported set of resources at runtime, which is really interesting. Okay, so why would you do that? I hear you asking. Our use case, and the one that I found the most interesting, is for implementing Kubernetes custom resource definitions in Terraform. So by nature, Kubernetes supports defining new resources in the API at runtime. So effectively, you're able to declare and then use or manipulate API objects that have never been implemented in Kubernetes per se. This is really a unique trait of Kubernetes that I'm not aware of in any other platform API that I've dealt with. So custom resources are essentially fully configurable in terms of structure, and they are user dependent 100%. There's nothing about them that comes pre-baked into the cluster. Therefore, we don't know anything about their schema or their structure before they've actually been installed on the cluster. But luckily, Kubernetes was smartly enough designed to actually publish all of the structural information once these resources have been deployed to the cluster. They are in their structure information, and in fact, the structure information of any resource that's available in the API is available from the API server as an open API spec. So this is really interesting, and we're going to make use of that going forward. Okay, so how do they actually match up to Terraform's requirements? So Terraform, because it tries to be a very dependable tool, it wants to ensure safety of all of the infrastructure operations that users rely on it for. It has devised some safety nets and some checks and balances that are in place in order to make sure that whatever the user intends is actually what is expressed and then performed. And so to that end, Terraform tracks state and makes sure the state is consistent throughout the life cycle of the resources. So it will check whenever it gets new state back from the provider, whether the changes to that state actually abide by a set of invariants, so that the resource structure doesn't change, so that illegal values are not returned, and so on and so on. But this is something that's, let's say, non-negotiable with Terraform. It makes sure that the state stays consistent. On top of that, it requires structural information ahead of time so that it knows exactly what checks to do on which resource attributes. And so all of that packed together are things that as a provider developer, you need to keep in the back of your head when you're dealing at this lower level. By contrast, if you're working with the normal provider SDK, a lot of this is actually taken care for you by the SDK itself. But in our case here, we're on our own a little bit, so we need to be aware of that. What do we do? Because Kubernetes CRDs fundamentally are unknown ahead of time, whereas Terraform requires schema for everything ahead of time. And so the escape hatch there is we take the schema in our hands, so to speak. So we return a placeholder for the resource, and in all actuality, we will populate that placeholder as soon as we get structural information about the resource itself. This is really a very, let's say, unexplored mechanism, or has been until recently. But it's also very powerful, and it made us able to support dynamic resources and custom resources in Kubernetes. With that power also comes great responsibility, in the sense that you're now taking responsibility for maintaining the structural consistency of the resource. What that means, we'll see in a bit. And so let's have a look at this placeholder mechanism that I was talking about. So as I mentioned, there's a type system now in Terraform, and one of the types that are exposed there is the dynamic pseudotype. This is essentially basically a like a schema wildcard, if you want to call it like that. It basically says this attribute of a resource can take any shape in the future, but only once. Once we've actually established its actual concrete type, we have to keep that consistent. But it's enough for us to be able to delay specifying structural information until we actually get access to it. And so it's essentially like a declare now, but define later kind of mechanism. And so we tell Terraform that we are expecting an unknown structure of this attribute, but we will have more information about it later. And by later, I mean we delay it from the get schema moment all the way to the plan moment. Okay, so I mentioned the word once. What is that about? As I talked earlier, the Terraform core tries really hard to keep things consistent. And one of those consistency checks is that the structure or set of attributes defined for a resource does not change. And that doesn't actually make an exception for the dynamic pseudotype attribute that I showed earlier. What it actually means is that once you've set something concrete in a dynamic pseudotype attribute, you're committed to that type. And so the way to look at it is that you have to figure out as early as possible which structure of the resource you need. You have to send that back to Terraform, and you have to keep with it for the life cycle of the resources of that specific resource, right? We'll see shortly what that actually means concretely when working with the provider protocol. But let's have a look how that actually translates into the Terraform user experience, and how would such a resource actually present itself to the user. So what I'm showing here is output from the plan operation of the new Kubernetes provider that we're working on that implements this mechanism. And what's immediately apparent here is that although we're talking about two distinct resource types, namely a Kubernetes service and a custom resource definition, what we're seeing from the point of view of Terraform is essentially the same resource being manipulated, namely the Kubernetes _manifest resource, right? It's the same resource type as far as Terraform schema is concerned. We are, however, talking about very different structures internally. Okay, so that's already really interesting. We're able to essentially shift shape of the resource. But once we do that, as I said, we need to stay committed. So the same type that we've set during the first plan needs to carry over all the way through the life cycle of the resource. The way we extract this type, however, is also interesting because during the planning operation, when we actually move from the dynamic resource into the actual concrete resource, we are able to make API calls to the Kubernetes API. And so what that means is that we extract the open API type information off of the API server in real time during the planning phase and translate that into Terraform structural information. Right, so this is all nice and interesting, but it's also way more complicated than dealing with the provider SDK. So why would you actually do this? Should you always do this? Should you opt for this option whenever you start a new provider? And the answer in most cases is no. The provider SDK is there for very good reasons. It's mature. It has a very polished user interface from a developer perspective. As I mentioned, there's like a resource model with CRUD operations. It's really easy to wrap your head around and get started with. Going low level is actually a rather underestimated commitment in terms of work volume. It requires you to, because you're missing a lot of the SDK amenities, it requires you to actually re-implement some of them in your low-level provider. But on the other hand, you harness all of the untapped potential in Terraform that is because of the SDK's historical evolution not available at this time in the SDK. Namely, you get a lot of flexibility at plan time, whereas with the SDK, you're really limited on what you can do during the planning phase. It's mostly up to the SDK to provide the plan results. And you can use a lot of, well, actually all of the Terraform types, among which you have the dynamic one that we've discussed, but also object, which is the new one introduced in Terraform 0.12. Right, so with that said, I encourage you to actually give it a try. It's really easy to get started. There's already some information available, and there's actually one ready to use provider. It's this Kubernetes provider Alpha. It will soon get merged into the main Kubernetes provider, but this repository will stay around. And this is actually a more focused perspective into what it takes to work with Terraform Plugin Go, which is the framework that we're looking at here today. There is a work in progress, as I mentioned, for Terraform Plugin Framework, which is the new generation of high-level SDK that's being worked on right now, but it's not yet ready for consumption for production use cases. The alpha in the Kubernetes provider mentioned here is also a warning. Don't use that for any production use cases. We're still just moving from the alpha into the beta phase with it. But before anything else, just go ahead and check this excellent getting started guide on the Terraform docs, which explains in a lot more detail the interactions between provider and Terraform as I try to today. All right. So with that, thank you. And I'm open for any questions.
Wonderful. Thank you so much, Alex. That was incredibly informative and far more detailed than I would have ever imagined about writing a provider and just really understanding what goes on behind the scenes. You know, everything behind a plan, an apply, and sometimes a destroy. Hopefully not too many of those, though. Like Alex said, if you do have any questions, please feel free to throw those into YouTube chat or Twitch, wherever you are viewing. If you're viewing this at some point in time in the future, I'm sorry, I don't think we can answer those questions, but you can always reach out to us and we'd be happy to do so. So please feel free to throw any questions you have into the chat. One that I had, Alex, was what was your, so obviously, you know, working at HashiCorp, I'm sure slightly biased, but what is your thought on people getting started writing providers? And are there any things that are good to take note of or good to focus on when you're just starting to get up and running and working and writing a provider yourself?
Yeah, that's an excellent question, Taylor. Thanks a lot. That's actually coming up quite often, more and more so as the Terraform ecosystem expands and new developers are actually tapping their toes into the Terraform underpinnings. And so, yeah, to get started, I would recommend you do mandatory reading on that guide I mentioned as the first resource in my previous slide. So that guide on the Terraform documentation website is actually walking you step by step through all of the concepts that you need to be aware of when working with providers. There are bits and bobs there where it may have been lagging a little bit behind with the latest Terraform development. It's just that Terraform is right now in a very dynamic place in its life cycle. We've just released 1.0. There were a couple of major changes before that with the 0.12 version and the ones in between. So some of the developer-focused features have maybe not yet made it into the documentation. One of those is actually that there's now a simpler mechanism to start providers locally when you're developing. So I mentioned the debug option where you can actually start the provider ahead of time and attach a debugger to it. That's actually documented, but it's not linked into the guide itself, as far as I know. So you have to be aware that that exists and look for it in the Terraform documentation. The second is developer overrides as a mechanism to inject Terraform binaries from the local system rather than having them retrieved from the registry. So just Google Terraform dev_overrides and you'll run into the documentation for that, which is one developer pointed out to me not available directly from the guide. So we have to fix that. But in the meantime, just be aware that this exists.
That's one of my favorite things with documentation is PRs are welcome. If you see something, please, or issues are open too. Feel free to raise those up. If you don't have the time to be able to fix it or want us to take a look, please make an issue. If you do want to fix it directly, we need help with that too. So please feel free to open up a PR on that front. Awesome. Thank you so much. I've seen one of my favorite providers that I like to call out, I think is kind of, I feel like everyone's heard of at this point in time. If you haven't, definitely worth checking out is the Domino's Pizza provider. Really interesting way and use case to take a look at things. A wonderful way to end your pipelines too, right? A slice of fresh hot pizza. There are within the guides and how to use the Terraform provider SDK, how to work with that. I know that we also have some other tutorials up there too that just came out around Spotify as well, using the Spotify provider. There's also a blog post talking with the author of that provider too. So again, let imagination be your best friend when it comes to thinking about providers and different ways that you can use it. Just because it doesn't work exactly the way that you're familiar with, whether it comes to AWS, Azure, GCP, whatever, you can always create your own. So thank you for that wonderful reminder, Alex. Mary, did you have any questions for Alex?
Yeah, so in our experience, testing and working with dynamic resources has always been kind of an adventure. So I'd love to hear any tips and tricks you have when it comes to testing or poking at dynamic resources when you're troubleshooting, because as we know, they behave very differently than other resources.
Yes, you're very right, Mary. They are definitely less charted territory, let's call it, than what the established providers actually offer. And so, as I mentioned, this mechanism was only available in Terraform starting with Terraform 0.12 and then became available for providers to be built on with the introduction of Terraform plugin Go, which is less than a year old, if I remember correctly. And so, yes, we're still sort of like ironing the nicks out of it. That being said, the Kubernetes Alpha provider is actually being tested automatically with acceptance tests. We've built those on a lower level shim that sits underneath the usual testing abstractions that the SDK provides. But you can just as well use the existing helper resource that you normally would for testing a provider, let's say a traditional provider. So you can use the same testing infrastructure and the same testing APIs in the SDK, or you can use the lower level ones. And I have to mention a new testing framework is also in the works alongside the Terraform plugin framework SDK that I mentioned. They are not a native or intended use case of Terraform. I'm talking about dynamic resources. So Terraform wasn't fundamentally designed for this. As I mentioned in the beginning, this is an escape hatch whenever you need to accommodate something like at runtime defined resources for which there really is no other way to do that in Terraform at the moment. But we hope to eventually evolve Terraform to the point where this can actually become a, let's say, a baked-in feature, an officially supported feature of Terraform. This is, I would say, with a star at the end, a little bit of a workaround rather than a recommended mechanism. But should you find yourself in that situation where, for example, we haven't been able to support custom resource definitions for several years, this has been a breath of fresh air, and we've actually, we were able to deliver that.
Thanks. My motivations for asking that question were a little bit selfish, as we've been sort of looking at how to address some of the behaviors and auto-scaling groups in the AWS provider. As they are dynamic, a lot of things are defined as runtime. And so we've been looking at the work that the Kubernetes team has been doing as one of the ways that we could approach that problem. So thank you for the answer, because it is also helpful to me.
You're welcome. I'm happy to consult.
Awesome. Well, thank you so much, Alex, for just gracing us with that knowledge today. I hope everyone can learn from that and think of a fun provider that might be the right one for them, or just different ways in which they can help out on providers that already exist. So thank you again for your time, and we look forward to talking with you more here in the future.
Thank you too. Have a great show.
Always. Wonderful. Well, for anyone just tuning in, welcome to HashiTalks Build, where we're focused on developer-centric workflows and deep technical talks and chats, demos. We have so much to talk about today. Coming up next, we have 8 best practices for writing secure Go code. So I'm very curious to see this one, because I feel like you can always make your code that much more secure. So really going to be exciting on that front. I'm going to be inviting Dan and Eric to the stage. Welcome, Dan and Eric. Thank you so much for showing up today.
Hey, thanks for having us.
Hello.
Happy to have you here. No reason to be sneaking around, I don't think. So happy to have you on the center stage.
No end to the sneak puns.
So I'm sure you've heard them all at least 30 times, but
that and the debates on how to pronounce it. So our entire UK office says snick. So, whatever.
Awesome. Thank you so much.
Are we ready to get going? Are we good to go?
Yeah. Whenever you're ready, the stage is yours. Thank you very much.
Well, thanks so much for having us. We're going to get right into this because we have limited time and a lot to cover. So as you said, we're going to do 8 best practices for writing secure Go code. And as a quick introduction, Eric Smalling, I'm a developer advocate here at Sneak. I specialize in container and cloud native, and I'll let Dan introduce himself.
Hi, everyone. I'm Dan Enman. I'm a senior software engineer here at Sneak, and I work on mainly our reporting system.
Awesome. Well, let's get right into it, Dan.
Cool. Yeah. So the first thing we want to talk about today is Go modules. If you've written Go code recently, you're probably familiar with Go modules. It's native Go tooling built into the Go tool, and it replaces a whole bunch of other dependency management tools that were used before. It has a lot of really nice features. You can do replacements on dependencies if you need to, and you can easily manage and upgrade your versions with the Go tooling. So I'm going to show a quick demo here. And we have a module called GoMod, and in it, there's a super simple main file that has an import for github.com/package errors. Let me check out the GoMod, and I can see that it's included there with the version number, but I know that there's a version update available for 0.9.1. So I'm going to run the update with go git, and it's going to go and get the package and update it. And now I can check in my go.mod file. And in my go.mod file, I see that it's been updated. The version has changed from 0.9.0 to 0.9.1, and everything's great. And if I check my go sum file, I can see that there's a checksum in there for that version as well. So that's really cool. Go modules are awesome. You know, they have wide support throughout the ecosystem, and a whole lot of the community supports it. So if you're not using them already, highly recommended. The next thing to talk about is use of reflections. Reflections they can be very powerful, but they can also be very dangerous. They can cause all kinds of subtle runtime errors that you can't check with the type checker, can't catch at compile time. They can make it really hard to reason about the code that you're writing and talking about, because they use internal types to reference certain types and values in Golang. You know, if you can avoid reflections, I would highly recommend you do it. You know, if you can generate types with Go generate, or if you can kind of work things in a different way. If you can't avoid reflections, it's a little unfortunate. Make sure your code is, you know, well written, well documented, understandable. Write some tests, and definitely cross a finger or two just in case. Let me give you some quick examples on what Go reflections look like. So here's a quick function that takes called reflect that takes an interface, and I'll just show you what the types that the reflection system is dealing with. So here we're passing it a string, and here we're passing it a pointer to a struct with a string slice inside. And when we run this, we can see that the types that we're getting back are a little bit confusing. So we see here, we have the value given back, and the value in the first case is, you know, hello world, the string we gave it. In the second case, it's the struct. The interesting part is the reflect type down below. So that's the type that we do when we do a type reflection on it. That's the type that we get back. You'll notice that it does not look friendly at all. It has all kinds of internal pointers and information to things that are going on in the Go runtime. And it's not really super fun to deal with. You can see that if we stringify it, though, we can get the value of what the name of the actual thing held is. Let's take a quick look at another example. So here's one where we're casting an integer. So we have a function called reflex int. It takes an interface and reflects the value to an integer. And we have two cases here, an integer case and a float case. And in both cases, we want to pass an int back. So let's see what happens when we run it. And when we run it, we can see here again, the first one, we passed it a 42, we got a 42 back. The second one, we passed it a 4.2, so that's a float. And Golang is panicking and saying, what you give me is not what I need. So I'm going to just stop trying now and give up. And that's what it does. And then finally, we have one last case. This is similar to the last case, but it's using an interface. So here we have an interface definition. The interface definition has two services that are defined for it, A service and B service. Up here, we're creating a B service and we're passing reflect service And in reflect service, we take an interface, the interface service. Here we want to return a pointer to a service, and there's some information so we can see when we run it what happens. So let's get out of here in a second and run this. And let's see what happens when we do. So as expected, probably, we have some information here. Again, this is the internal type that the reflection system is giving us with all kinds of scary looking values and pointers and things like that. And then here we can see that the interface conversion failed because if we look back here, what we're doing is we're reflecting it and we're expecting a pointer to an A service. This can happen, in this case, or in other cases, if you're doing dependency injection with reflections, if you have a pointer and you have a bunch of things that match, or a certain interface, you have a bunch of things that match that interface, you could cause problems because reflections will pick one and then you might be dealing with the wrong type. This tip is great for any language. The nice thing about Go is Go makes it really easy. And I think the real tip here is use the standard library, get to know the standard library. It has all kinds of really great things included in it, from HTML templating to plain text and SQL. And really, you shouldn't be trusting your user input. You can validate it. You can use the templating to clean it up. But get to know the standard library and always validate your input.
That's awesome. Let me talk real quick about vulnerability scanning. So as we all know, that what we ship isn't really made up of, the majority of it isn't made up of our code. It's a lot of libraries and modules like we were just talking about. And hackers know this as well. And unless a hacker is extremely intent on your exact situation, they're not targeting the code you've written. They're targeting vulnerabilities and exploits in code that are in these standard modules. And it's a moving target. So unless you're really watching all of the release notes and CVEs that are found in every module you're using and every transitive module that they depend on, you're not going to find everything. So tools really are essential in this area. Now, a lot of these tools that have come out over the years, depending on what kind of a platform you're on, end up usually being at the far right-hand side of a pipeline, after functional testing or something, because they're heavyweight. They take a long time to run. They might have heavy licensing schemes, things like that. So you want to look for a tool that you can push toward the left side of that pipeline, the whole shift left stuff you always hear about in the security realm. And in order to do that, the reason you want to do that is because you want fast feedback. Just like CI changed the world with getting your tests running every time you commit and making sure you found out about a failure right away. But you want to find out about security failures right away. Now I'm going to show our tool. I'm not here to pitch our tool at all. Just know that there are tools out there that do this, and make sure you're getting one that helps enable your developers to be proactive. So here we have an example of a command line version of the tool. So we're just running sneak tests against our Go modules. It's going to analyze them. It's going to query the backend database. And then it's going to spit out a bunch of vulnerabilities, as well as the versions, if there are any, where these vulnerabilities are remediated. So you can go in and say, oh, I need to upgrade this version of that. Let's go ahead and jump to the next slide. Another great way to get your developers to be proactive is to move it into the IDE. There we go. As we get the slide going. And here's like Goland. A lot of us use Goland as our IDE, and you can have a plugin that's doing scanning right there. You can get a nice pretty version of the same kind of vulnerability output with a little more information maybe that's available right at your fingertips. You can say, hey, like in this case, the font's terrible there, but if you upgrade to this version, you're going to remediate this problem and maybe others that are in the list. Let's go ahead and skip to the next. Yeah, so make sure you're getting scanning in and getting it as close to the developers as possible.
Cool. So the next thing I want to talk about and run through some demos of is unsafe in particular. CGO is mentioned on here. CGO is not terrible, but CGO is not Go. And it can add some complications, build and performance complications. And really, if you're writing Go and interacting with a lot of Go code, there should be a native Go library available. So that's the recommendation. Talking about unsafe, on the other hand, unsafe can be very dangerous. It helps defeat the type system. It helps kind of render it a bit null and void, because it lets you read and write arbitrary memory values. And you can do all kinds of weird things in here. And I'll show you some examples of some weird things that you can do, and also some ways that you can cause problems for yourself later on down the line. Cool. So the first one we have here is just showing what some constants that the unsafe library package will give you. And these are constants. So if you have a float 32 and you pass it in, you'll get these same values back. So let's run this, and we can see what we get for the alignment and size of values here. And we can see that this is a unsafe pointer to float 32, and these are the values that we've given it. So that's interesting. I mean, that's some information. It's not going to cause you any trouble when you go and run. And let's take a look at this one now. So we know we can take pointers, unsafe pointers, and we know we can do things with them, and they have a size and alignment. But what happens if we try to take an unsafe pointer from one type and kind of convert it into another type? Well, we have this example here that shows exactly that. We have three functions here: pointer to pointer conversion, which takes an int32 and returns an int16. The 64-bit, which takes an int64 and returns a unsigned integer 16. And finally, the last one, which is probably the most interesting case, takes a float 64 and returns an unsigned integer 16. So there's all kinds of things that can go wrong here. And let's see what happens when we run this. So when we run it, we get some values back for the conversion. So we have the conversion from int32 to int16, 42. The conversion from int64 to int16, 42. The conversion from float 64 to int16 gave us something else that's not the right number. So here's a way in which you can cause some trouble if you're reading and writing arbitrary memory, and the alignments don't line up and things are wrong. You're going to get data that's not the data that you're looking for. All right, so let's talk about something interesting again, quickly and unsafe. So we can do some pointer math here. So we have a slice of strings. It says hello and unsafe. We have down here a really ugly looking expression that casts some pointers and does some things. Essentially what it's doing is taking the pointer to the first element and then offsetting some memory to the pointer, well, in this case, the 0th element, which is the first element. And in the second case, taking the pointer to the first element and offsetting it for the size of the first element. So let's see what happens. It's probably pretty predictable what we're going to see in the end. And when we run it, we get what we expect. We get the two values back, hello and unsafe, from the slice. There is a way that you can cause some problems with the pointer math in this way. So here we have a string slice again. It has length 0 in this case. Went too fast. Has length 0 in this case. So what happens when we take the pointer to the first element and then try to get that first element? And let's run it. And when we run, we can see that, well, it panics, and it panics because we're trying to get a value out of the slice range. And lastly, this one is interesting because it combines some of the reflection stuff we talked about earlier with unsafe. Here we have a string, hello unsafe, and we want to create our own string header from it. So we have the data and we have the length. We know those things since we have the string here. So we're taking an unsafe pointer to that string, and we're setting it the length of the header to the length of the string. And then we're casting it back into a string. Let's see what happens when we do that. When we run it, we will see that we get kind of weird data back that does not look right at all. It's just kind of random garbage that Go gave us for that string. It's definitely not the string hello unsafe. And we definitely lost that value when we converted over. So there's definitely, it's definitely possible to lose data, corrupt data, convert data into formats that it just doesn't convert into safely. So be careful with unsafe because it's not safe. Cool, and this tip is very similar to the previous one, talking about dependency injections. And really, again, use the standard library. The standard library has all kinds of really great packages inside of it, including a crypto package. The crypto package has great support for all kinds of hashing and encryption algorithms, has great support for PKI, has support for net HTTP, which is great because that's what a lot of the popular libraries and frameworks for the web are built on top of these days. So again, check out the standard library, get to know it really well because it has all kinds of really neat things inside there.
And back to me. So our surveys are showing that about 60 to 75% of the production deployments now are going out in containers, depending if you include serverless or not. And that means a lot of you that are watching this are also shipping in containers as well. And one of the things that's new for development or for developers when you're dealing with containers that you haven't maybe had to deal with before is the operating system packages, the file permissions, user IDs, all that kind of stuff that might have been handled by your operations or your sysadmins, your security departments, your middleware tier people before. Now that's being added to your plate because now you're in charge of Docker files or Kubernetes manifests or whatever it is you're using for your infrastructure as code, your Terraform scripts, everything like that. And what you don't want to do when it comes to your containers is make an image for that container that contains a bunch of tools that are going to help a hacker out should they find an exploit and get access to, through a remote code execution vulnerability or something. In order to do this well, you really need to understand how image layers work, and especially with the base layers. So when you build your image, you've got all these layers that make up the file system, and you have a starting point, and that was what we call the base image. There are all sorts of different base images out there on the official ones out on Docker Hub. There's ones from your vendors. There's ones that your own business may be producing. They can start from places like Ubuntu or CentOS, or even if you might be looking at some of the Google distroless images. Those are good choices because the distroless choice, that's a very pared down and minimized image that doesn't contain much else than what it takes just to run your application. So there is a Go version of that. There's also Java and other ones. That might be a little too much because it's so stripped down. There might be some diagnostics you need to be able to do that aren't in there. You might also take a look at Debian has slim images, which are not quite as drastic as distroless, but they are slimmed down and much smaller. Alpine is another interesting one to look at. Alpine started before containers became popular as a small footprint OS that has a kind of a nod to security because of the small footprint. It does use it doesn't use glibc, it uses muscle C, so you can make sure that works for your application. When you're looking into this, though, the technology you really want to get your hands around if you're using Docker build to build your images is the multi-stage Docker file. Let's go ahead and jump to the next slide, Dan. So here we have get it going here. Here we have a Docker file that is showing us a simple Go application. It's got a whole bunch of lines here that are setting up all those layers. It's setting some environmental variables. It's building the app, setting a user up, and then running the app. And if you look at the bottom of this screen, you'll see that this image, if you were to build it, is over a gigabyte in size, which is huge. There's a ton of stuff in here that really doesn't need to be going out to production. You don't need a full Linux file system. This is a tool called Dive that allows you to dive into images. It's an open source free tool out there. And you can see on the left all the layers. You can see the sizes. We start with 114 meg, 16, 18, 146, and so on. That all adds up. And you've got all that Linux file system. You've got all of that, the Go. You've got your own source code actually in this image. That's not what you want shipping to production. So here's how multi-stage can help you clean that up. So I'm on video. There we go. And in a multi-stage build, you have multiple from lines. In this case, we have two stages, the top one at line 1 and the line 14 for the second one. That last stage is the only one that actually builds the final image that goes out. This stage you can see is using Scratch, which is kind of a Docker file keyword for nothing. There's nothing in this file system. There's no base image really. All that's happening in here is we're copying a couple things from the build stage, which you can see at the top, we see as build on that. So it's copying the my app and the password in this case, which contains the user we just created, and then setting it up to run. So if you were to build this and take a look at the sizes of it, I'm overextending my recording. There we go. 11 megabyte roughly. That's drastically different. And if you use that dive tool to jump in and see what's in here, you can obviously see. Let's jump out of here and go into that image. It's 2 layers: the app and the password file, and nothing else. So if a hacker was good enough to break through some vulnerability in your app, he has no toys to play with inside this container. There's nothing in the file system to help him or her set up a beachhead to start hacking around. Go ahead and jump to the next slide, Dan. So that brings me to scanning. So just like we talked about scanning for your modules and your code vulnerabilities, you also, if you're using any kind of base image that is more than just scratch, you want to scan for vulnerabilities in the operating system, the packages that are in it and things like that. And we have a tool that does that, but there are many tools for scanning that. Make sure your registry or your CI tool or even your command line, that you have a tool that you can monitor that, especially as vulnerabilities are found. You want to be able to find those vulnerabilities even if you haven't changed your Docker file. And lastly, outside of the containers themselves, when you get to runtime, there's other things you can be doing that can help you, provide security in depth, such as, can you run your container with a read-only file system? This is huge. Immutability is awesome, because then if a bad actor does get in, they can't modify the file system. They can't curl in their own scripts. They can't modify your executable. They can't clean up after themselves by deleting logs. Also, don't run as root in your container. UID 0 means things, and if they were able to break out of that container, or if there was anything volume mounted in, that UID 0 would be able to read and possibly write to files that were, if that was a bind mount on your host system. That's horrible. Privilege mode, don't use it. You probably don't need it. 99% of people don't need that. If you want to know more, search on why. Linux capabilities are awesome. The Docker team years ago figured out a pretty good minimal set of capabilities for most containers, but actually most applications don't even need what that gives. So then drop all your Linux capabilities and only add back the individual ones you need, like a capnet add or something like that, or capnet raw, sorry. Cgroup limits. So limit the CPU and RAM you give to a process in a container. That way, if there's something wrong with the process, or if a bad actor were to get in there and start to try to crypto mine in your container, it will be limited to a finite amount of RAM and CPU and not everything that the cluster node gives it. And finally, if you're on Kubernetes, network policies are your friend. They allow you to limit traffic, TCP or UDP, and to specific ports between the pods and in and out of namespaces and things. I am a fan of zero trust network policy, meaning no traffic is allowed at all, and only what I then additively allow gets allowed. So I say, this kind of pod that matches this selector can talk to this kind of pod on TCP port 8000 or something like that. And only that traffic is allowed between the pods. So that is that. And I think I don't know if we have time for Q&A, but we'll be happy to hang out for that. Dan, you can go to, I think that's our last slide, right? I think it is. So thanks for listening. I cannot hear you.
Yeah, Taylor, you muted.
Oh, there we go. Sorry.
There we go.
Yeah. Trick of the stream. Thank you both so much. That was really fascinating. I couldn't keep up with all of my notes, but tried to make some shorthand on things I definitely need to take a look at and learn a little bit more on. I think that we did have time for just one question, and that one question is, Snyk is a really wonderful and powerful tool to be able to keep up to date with a lot of things happening in the world and with your code stacks. Aside from using Snyk, are there any good sources that you can point people towards to keep up to date on things? I know, with security, it's ever changing. So same with just about everything in technology, but are there any good sources that y'all can point out or kind of to let us know about that might be something good to, keep note of?
from the container and Kubernetes side of the house, I can tell you, get involved in the SIG communities, get involved in the, in SIG on the Kubernetes side, TAG on the CNCF side. But if you're really into networking, there's a networking SIG. If you're really if you want to know security, SIG security, I'm in there, and we have a whole tooling sub group that we do things from. That's my number one thing. And then, you know, just follow the experts that you see in there on Twitter. That's the way I keep I get the freshest info around that kind of stuff.
Awesome. Awesome.
Dan, do you have any
thoughts?
recommendations for Go?
The Go community is pretty good. The Go issue tracker is great. There's lots of great stuff on there. If you're just getting into Go, the Go homepage has a playground. It has resources that will guide you through all kinds of things in the playground to learn it. If you know Go or if you're learning it, you know, Effective Go is always a great read again and again with all kinds of great insight in there. And keeping up, you know, Twitter, follow lots of Go developers on Twitter. I'm sure they'll keep you up to date as well.
Awesome. Well, thank you so much for all of the insight on writing secure Go code. I think next we'll be bringing Wilkin to the stream to talk about Packer.
All right, and we are channeling him right now. Thank you again, Eric and Dan.
Hello, hello.
All right, welcome, Wilkin. Happy to have you. Happy HashiTalks Build Day. Really stoked for what you have for us today.
Awesome. Well, hello, Taylor. Hello, Mary. Good seeing y'all on the stream. Hello, HashiTalks. Super excited to be here today. Thanks for tuning in. I'm going to be talking about Packer, the plugin ecosystem, and more specifically, publishing Packer plugins to the masses. I should share my screen now. So let me go ahead and share. Let's see. And you see a lovely desktop. Here we go. So hello again, everyone. I'm going to be talking about publishing Packer plugins to the masses. And for those tuning in for the first time and not knowing too much about Packer, Packer is a tool for automating the creation of machine images and application containers across various cloud providers and hypervisors. If you're interested in getting a little more information on Packer, I definitely recommend checking out the Getting Started guide on learn.hashicorp.com. So for those that are familiar with Packer already, you would know that in Packer 1.7.0, or should I say right before Packer 1.7.0, 1.7.0 was released in February, publishing plugins to the masses really meant bundling, right? We had this process where we would bundle all of our third-party plugins, including those maintained by HashiCorp, into the Packer binary and then deliver one binary so that when someone downloaded Packer, they could easily run Packer and access all these plugins. So most folks would open up a PR against the Packer repo and ask the Packer team to sort of maintain it and sort of be the gatekeeper for any new changes that were made to that plugin for any third-party cloud services. As you could imagine, that was quite a bit of work. So in Packer 1.7.0, sorry, I'm going to take off my glasses. In 1.7.0, the game changed, right? The Packer team worked on splitting up the Packer core from the Packer repository, from the Packer plugins in such a way that we can make it easier for ourselves and for plugin maintainers to not only develop and release their plugins, but also make them discoverable by the user. So in 1.7.0, we released Packer Init, which was an automated way of installing third-party plugins. So instead of manually installing these plugins, you could easily install them through a command. We released the Packer SDK and the Packer SDC command, which was all this great tooling that we had stuffed into the Packer repository. And we made it available to the community for all the plugin maintainers, right? It made our life easier, so we wanted to make it easier for people to develop plugins and get it out there. And then lastly, we introduced this concept of remote docs, right? So one of the things about building plugins is getting users to actually use it. So we found that a lot of our users would come to packer.io/docs to look for these plugins or potential new plugins. And it was sort of a disservice to say that there were a lot of great plugins out there that we weren't showing because they weren't part of that monolith repository that everything was bundled in. So we wanted to solve that problem and have a way for users to bring in their documentation and register their plugins alongside all the other plugins, right? So with that, this is probably a good time for me to say, I'm Wilkin Rivera. I'm a software engineer here on the Packer team. And you can reach me at Wilkin Rivera or NYWilkin on GitHub. And today I'm going to be demoing the process for publishing, for registering your plugin on Packer.io. So, or what I like to call the 3 steps to improve discoverability. So, step 1, documentation generation, right? Generating docs for your plugin could be a bit involved, especially if you have a lot of configuration options. But on Packer, we have a way of auto-generating a lot of this documentation for your plugins using this command called struct markdown as part of the SDC command. So the way it works is you throw a few go generate statements at the top of your plugin config files or builder files or provisioner files, whatever plugin you're building. And when you run the go generate command, it's going to parse all of these files. It's going to extract their comments, and it's going to generate what we call doc partials or shared, sort of shared documentation that you can then include into your sort of full featured docs for your plugin, right? So this was a tool that was made available as part of the Packer SDC command, and we thought it was helpful to us. So we wanted to make it helpful, put it out there to the community. The second thing is documentation releases, right? So documentation is all good, but if you can't find it, it doesn't really, how should I say, it doesn't really help the user. So we wanted to think about how do we get documentation, especially for those plugins that we don't maintain, sort of our remote plugins. How do we get the documentation as fast as possible to the user? So we thought, hey, we are already releasing binaries for Packer Mint. Why not throw the documentation in there? So when users get the binary, they can easily access the documentation. So as you can imagine, we wrote a tool for that too. So we have this Packer SCD renders doc command. So this command takes the generated documentation that we use that was generated using the struct markdown command, and it then injects it into any sort of static documentation that you have, sort of using, if you're familiar with include or partials in different website engines, this does the same thing where we generate some partials and then render docs takes the files that are referencing those partials and it injects it so that you get a full featured doc with all of the partials rendered. And I'll show a demo of this in a minute. Once those docs are rendered, we figured, hey, let's simplify the process for releasing those. We have some scripts in place, and I'll show in a second, that will package up those docs and then make them available as part of your release. So far, we've generated some documentation. That was step 1. Step 2, we are releasing this documentation, right, that is generated. Now, if you're paying close attention, you see there's this docs folder, which is not fully generated. In there, you'll have some static stuff, right, because it's not everything that we can generate. But these 2 tools alone allow you to take generated docs and static docs and merge them together to create the beautiful plugin documentation. And then lastly, step 3. Step 3 is registering this documentation, or just for sure, registering your plugin against Packer.io. So, we found that having plugins in a central location where our users can go and find them definitely makes it easier for them to find, for them to get up and running, with new plugins, or even, debunk some of the issues they might have with configuration options. So we didn't build this tool. The kit existed for quite some time, but we did build some cool processes around how we develop our websites so that we can kind of make this magic happen. So here I'm going to show a quick diff, right? So we have this one central file, which is called website data docs remote plugins. And in there, as a plugin maintainer, you can add this little snippet of code, which takes a title, a path, a repo, and then a version and an optional plugin tier, which again, I'll show in the demo. And once you open up this PR against a Packer repo to update our website, and once it's, and we essentially take it from there. We on the Packer team will take it from there, review the website, review your documentation, merge it, and lo and behold, your documentation is on, is now on Packer.io. So with that, it's time for a demo. Okay, so I'm gonna go ahead and switch over to my terminal now. No, not wrong way. Let's go this way. Perfect. Okay. So right now I'm in my terminal and I'm in this plugin, which we call HashiCorp. HashiCorp is a, HashiCorp is a plugin that we built internally for as a demo to show users how to create, or potential future plugin maintainers how to create a plugin on their own. So there is a builder, which we're looking at right now. There is a provisioner and some post processors. So in today's demo, what I'm going to do is I'm going to show you how we used auto-generated code, or sorry, auto-generated documentation using the struct markdown command. I'm going to show you how we include the docs as part of our release cycle. And then I'm going to show you a local version of the same website working with a new version of the plugin. All right. So first things first, quick git diff. So here, going back to the auto-generated docs. So the first thing is I want to add this go generate block at the very top of this file. So this is our common auth config file. And then I added some comments to the configuration fields. So with these two things in place, if I run go generate, it should generate some partials for me that I can then use in my documentation. So let's try that. So right now, I'm going to do that. Let's see what we have inside of our docs partials. So we have this docs partials directory, which has two files. So it's auth config not required and auth config required. So the files that get generated are named after the file, the Go file that the comments were found in. And then inside of the comments, you could, or sorry, inside the fields, you can add these tags. Required, true, makes it a required attribute, or if you leave it empty or required false, it would make it what we call an optional. So I'm going to go ahead and remove this. So yeah, no, okay, perfect. So then I'm going to go ahead and do a quick go generate. So we have other tooling in place. So the Packer SDC command does a lot of generation. So I highly recommend people check it out if you haven't already. So if I take a quick peek at those files, we have these new files that were just generated. Great. So I'm going to go take a quick peek at the documentation. So in our documentation, as I mentioned before, we have these include statements. Right? And in these include statements, they basically reference these partials that were created. So they follow the same sort of directory structure. So our config was inside of common/auth.go. So here it created a directory called common/auth-config-required. So you kind of follow that convention. So I'm going to go ahead and close that. And then I'm going to show the render. Right now, I want to start the process of releasing our documentation. So I'm going to go ahead and show the render command. So here I'm running this renders docs command. The source is pointing to my docs directory, which is the files that I have that reference these partials, these include partials. I have the location of my partials, which I just generated up here. You can see it's called docs partials, and then the destination. So where do I want the files to be written? So I'm going to overwrite the files that we currently have in the docs directory for this demo, and then I'll show you what we actually do when we release. So the command went ahead and executed, and we can clearly see, hey, replacing the include. So if I open up that file again, we're going to see very quickly that include no longer exists, and it has been replaced by the required attributes and the optional attributes. Right. So we're done there. So I'm going to go ahead and clear my screen here, and I have some changes. So I'm going to go ahead and just restore the docs because we don't need those anymore. Okay, so how do we actually do this thing on release? So on releases, we use, for releases on Packer plugins, we use Go Releaser. And in the Go Releaser config file, we have all the steps necessary for releasing the multiple versions of our plugins, but we also have a step for generating our docs. So here we have a make file, right? But this make file is simply installing the latest version of the Packer SDC, which gets released anytime there's a new version of the SDK. It runs that same command that I just executed, and then it packages that documentation directory into a docs.zip. Now, here we're safe to do this because on the Go Releaser, when we execute Go Releaser, we run them through GitHub Actions, and we don't commit anything back. So what we do is we temporarily overwrite the contents of the docs directory on that build, and then we package it up, right? In preparation for the release. So going back, oops, if I jump down to line 82, you see that as part of my release, we have this extra files glob, which includes the docs.zip file. So when we actually release a file, release a plugin, it will generate all the binaries and then push up the documentation alongside with it. So I'm going to switch over to my browser really quick so that I can show you what this looks like. Let's see. I am here. Perfect. So this is the Packer plugins HashiCorp repository. And you can kind of get a quick readme on what it does. But I'm going to click over to releases. And in the releases, we have 3 releases. We have the latest release, which is version 1. And then we have a dev release. So this dev release, really quick, you'll see that we have this docs.zip, which was included as part of this Go release, part of the release. And we use, like I said, we use Go Releaser for triggering these plugin releases. All of the information I'm talking about today, we do have a repository called the Packer plugin scaffolding, or should I say it's a template repository, which anyone who's maintaining plugins who may not be using it, or potential plugin maintainers, you can create a new repository using this as its template, and it will set you up with all the base configuration files that we're using locally. And we're strong believers of dog fooding our own tooling. So anything that you see here will get updated. Anything you see here, we use, and then we will update it anytime there's any changes that we need to make, to continue keeping the release process as easy as possible. All right. So going back to my terminal. So here we are. So we released the documentation. It's part of our release, and now we want to get it onto. We want to register our plugin on Docker on Packer.io, which is step 3. So I'm going to switch over to a different terminal here, and I'm going to open up this file really quick. So this is the remote data docs remote plugins file that I showed in the previous slide. Excuse me. And here we have this entry for HashiCorps, right? So we enter in this file. It's just raw. It's just JSON. For every remote plugin that we want to publish on Packer.io, we have a similar entry, right? Where we specify the title that we want to show up on the sidebar, the path, so it'll be packer.io/doc/HashiCorps, the repository where it resides, and then the version. So version could be, by default, it is set to latest. But since I'm going to show an unreleased version today, I've hard-coded that version. So this is a great way of pinning the documentation for your plugin. So if you're updating your plugin and making pre-releases or making releases and you don't quite want the documentation to go out yet, you can come in and pin your documentation to a specific version. And then there's this plugin tier, which it's a label. So I'm going to go back to, I'm going to go back over here. Apologize. This label here. By default, anything that is owned by HashiCorp or within a HashiCorp repository will get the official label. And anything that is coming from a remote location for example, like go to our builders, like Ali Cloud, will get a community, right? So, so what we do here, I'm switching again, my terminal, apologies. So what we're doing here is, since this is managed by a HashiCorp team, it would essentially get the official label, but I want to hard code it to community so that everyone can see the change. So I've made this change. And here you can see that the only differences are the community label and the version. And now I wanna test this thing. So as you can imagine, we have some tooling for that as well. Big shout out to the website, to the web development team for making this so effortless. We have two commands that we run. First, we call the make build image, which builds a local Docker container for the of the website that you can run locally, right? And then you have the make website local, which runs this image that that was just built locally, right? So I'm already running this, so I'm going to go ahead and flip over to that. But these two commands, make build image, will build a local container for you to use, and then you can run make website to actually run that container and spin up the website. If you happen to have npm installed on your system, you could actually do the same thing without Docker, running npm start and npm, to start the service, and npm stop within the website directory to shut down the web server. All right, so I'm just going to switch over. So this is the Docker container running here. So let me go over to my browser somewhere. Okay, perfect. So quickly going back to our HashiCups, we can see that this is HashiCups order builder. It's the official one, right? This is currently what is deployed to Packer.io, and it is version 1.0. We deployed version 1.1 or dev, should I say. So if I switch over to this tab here, I have localhost, so this is running locally, and you can quickly see the community tab, the community label has been applied, which was in my change, and then the version for that builder. So this is reading from that pre-release binary, that pre-release tag, which is 1.0.1/dev. And let me take a quick look at our order page. We'll see that it is, again, the community label. I'm not going to refresh because since it's running behind a container, it does take a little time to refresh. So I'm saving you the pain of watching a screen load. Okay, so what do we have? So we're coming back here. We're back at we're back at our terminal. So I showed step one, which was the auto generation of docs, right? Oops. Struct markdown. We have the release, sorry, the render docs, right? So, okay. So we generate these docs. We get part of the release, and then I showed the adding them to the GitHub website, sorry, the Packer.io website, and you simply once your local environment looks good to you, you can go over to Packer.io. Let's see. And open up a pull request to add plugin documentation, and we happen to have one right now. Right, and there you go, simple as that. And then once that's done and that gets merged, your files show up here alongside your plugins show up here alongside all the other plugins. So when folks want to come and find your great plugin, whether it be a provisioner, a post processor, or some new builder, they'll see it right here alongside all the other ones. And to finish it off, when they want to install it, right, I'm gonna sort of demo a different plugin here. This is a third-party plugin called Packer Plugin Comment. It's also one of our demo plugins. So when folks see your plugin on Packer.io and they want to try it out, they can take a simple build script, which I have right here. What's it called? Build. So here we're using this required plugins, calling the name of the plugin. Okay. So I'm going to go ahead and do Packer init. It's going to download that remote plugin automatically for you, and then you can start using your plugin. All that. So thanks again for tuning in, and I really hope you enjoyed this demo. And if I have some time, I'll answer any questions.
Awesome, awesome. Thank you so much, Wilkin. That was incredible. Really liked the ASCII art there at the end with the thank you. It's clearly an incredible plugin.
Yes, yes. Love it. Thanks. Much love to the folks on the Packer team for creating that demo plugin.
One question that I had for you was for people out there looking to kind of create these plugins and release things and kind of get that overall experience. It's something that I don't feel like can be taken lightly. It takes a lot of effort, takes a lot of thought, definitely something that you want to measure twice or thrice and then cut once. What are some things that make it onto your checklist when it comes to releasing something? What are things that you, the absolute have-to-haves when it comes to that?
Well, are you talking just like the last mile release, or are you talking like the whole process?
I'd say more the last mile would be interesting to hear.
Yeah, I think one of the biggest things for cutting a release is, does the plugin actually work, right? I think, as it's very simple to sort of make changes and see that how, that things don't register the way that, they were registering before. When I say register, I mean when you run packer.build, it can no longer find that plugin, right? And sometimes we make these little mistakes that it just kind of changes things up. So I think the first thing is, I have this release, I have this version that I want to release. Let me go ahead and build it locally, right? And all this, we have all this documented on our website on Extending Packer. We can build it locally, we can run it, install it locally, and we can run some test cases against it, right? And then once we know that that's good, it's a matter of checking the version. Okay, does this contain the latest version information for this plugin? Is it still referencing something old? Updating that. And then, double checking the documentation. So, I think this is where the tooling comes into place, right? So we always forget to update docs. So we go through and we comment everywhere we can, and we use our tools like Go Generate, that call Packer SDC that will generate all this documentation for us. So it's test this thing, validate the version, test the docs, right? And then run the local unit tests. We do it in that order because sometimes the unit test will pass, but when you actually run this thing, it doesn't quite work the same way, right? So we figured, if you happen to have acceptance testing for your plugin, I guess that accounts for the first part. But checklist, test it with an actual config, check the version, check the docs, and run Go Generate, test the unit test, and then push up, tag it, and we're done. It's a four-step process.
I love it. I love it. Great way to check for integrity. I really do feel like that's a big thing. I have been at places where I felt bad about asking, did this work before? And then hearing, no, it didn't. And then being like, oh, well, then we, let's reset our expectations and kind of talk about what we need to fix then. But all wonderful points. Awesome. Thank you so much.
You're welcome.
Sweet, Wilkin, I have a question.
Oh, yes.
Which is, we've talked about what y'all are using this plugin for. We talked about the HashiCorp plugin. I'd love to hear about if you know of any interesting use cases or kind of out of the box use cases for Packer plugins from the community or even from within your own team, where you're using them for something unconventional or interesting, or that we wouldn't think of when we're thinking of how we would use Packer.
Oof. I don't have a good answer to that question. I wish I did. You definitely gave me some homework. I feel like other people on the team might have a better answer. I might have an answer. But I guess, yeah, I mean, the HashiCorp is an interesting one because that one does coffee and toppings and very interesting things. But I don't know off the top of my head. I can't think of any plugin that's doing something sort of out of the box. But I will go ask around now, and I'll drop that in the chat because I'm very curious to what's out there.
I'm looking forward to it. Thank you.
All right.
And I did
You're
not
welcome.
mean to give you homework, but I'm excited to hear about what you find.
No, it's good. I appreciate that because it's. I think one thing we're finding, especially as we move away from this monolithic repo of having all the plugins in bundled into Packer is that we're finding all these great plugins that do various things, right? So this is all part of this discovery work, if you will. So I think a great question, and I'm sure they're out there.
Really looking forward to the day that when we're able to run some of those Git clones and don't have to download, petabytes of data. But unless it's fast, then maybe it's fine. Awesome. Wonderful. Well, thank you so much, Wilkin. It was a pleasure to have you today. Hope you can stick around and find some fun sessions for you to watch and not be in the driver's seat for. And awesome. Next up, we have a talk. Anytime. Next up, we have a talk by John Boro, and that is Fuse clients for HashiCorp REST APIs. So we'll get that kicked off here shortly. And thank y'all for attending HashiTalks Build. We'll see y'all in a second.
Get to enable our partners. I live in London and I cover Europe, Middle East, and Africa. Now, I'm here today to talk to you about HashiFuse. So this is a project that I've had going for almost 3 years now in various stages. And what I do is create some Fuse file systems that map the HashiCorp APIs into familiar environment, a familiar file system structure, which you can easily use with your CLI, any APIs you have, any language you have that can read and write files. So why do I do it? It simplifies the APIs quite a bit. It allows things like auto-completion, some real nice features that we'll see and towards the demos at the end. Now, if you're not familiar with Fuse, it's a file system in user space. So really, it's just a simple little application that interacts with a kernel module, the Fuse kernel module, which will actually do switches between user space and kernel space to present an application, inputs, outputs, and a couple of mappings that I'll talk about later into what the kernel views as a traditional file system. So it's a simple, tiny binary. I've done Vault, I've done Console, I've done Nomad, Terraform Enterprise, and Terraform Cloud, and also a generic Open API one, which is really interesting because as more of our products adopt Open API version 3, we have a more uniform way and a single client which can actually be used to access any of our projects potentially. And I'll talk about the future plans as well. So why does it matter? Again, if you're old school Unix, Linux user, one of the beautiful things about the standards presented by POSIX, everything has been a file. That's not actually part of the POSIX standard, but common way to use just about anything in a Linux environment today is via file. Your sound devices are files, random numbers are files, right? Everything in your system tends to be represented in some way or another as a file. Now, the great way we do this is we do the same thing with Vault Secrets or Terraform workspaces, right? So you can browse your workspaces, you can browse your secrets just like you would a normal file system. Now, in order to implement one of these, Fuse has a couple of prerequisites that you need to implement to make a file system, right? The most important one at the top is get attribute, right? So if you're given a path, what is this? Is this a file? Is this a directory? What permissions do I have? Ownership, etc. Is it a socket? Is it a symlink? So you have to fill a stat buffer based on a path. Now, the APIs don't necessarily have those defined, right? Open API version 3. The specs that we have for Vault are really good. They tell you exactly what paths you have available, what those paths represent, what operations you have, a post, a get, a patch, whatever you have. Now, for the rest of them, and for the early Vault client that I made, I had to approximate that, right? I had to use a bunch of regular expressions. If the path looks like this, it's a directory. If the path looks like that, it's a file. Now, it's actually not as complicated as it sounds. It's only about 800 lines, I think, tops of C++. So everything is pretty straightforward, pretty simple. And it's not feature complete, right? So there's not exactly every feature built in, but a pretty good basis for most of the Vault secret engines and like Terraform Cloud API, etc. All right, so when you implement a full CRUD-L, I call it CRUD-L, create, read, update, delete, and also list, or in this case, read directory, we get a fully browsable file system. So what this looks like, and here's an example of me running the Fuse client for Terraform Cloud. So I use libjson C++, libcurl. You do need to use direct IO, because if you don't use direct IO, the kernel will attempt to cache things, and a REST API will not have the same response most times if you're going to repeatedly fetch it, right? So we will recommend, you will have to use Fuse in direct IO if you're going to use any of these clients. The Vault one, the Terraform one, will use the same environment variables as you're used to, right? So Terraform token, or sorry, TFE token, Vault token, Vault address, all of those translate directly from your existing CLI into the Fuse file systems. And in the case of the Open API one, further on, I actually have implemented fetching your client's environment variables. So you can do things like your headers. Obviously, it's more complicated when you have to do things like a header for namespace, header for payload, whatever kind of flags you're having. That can be pulled from your environment variables now, which is really helpful. Okay. Feel free to take a look at the code. It's only something like 3 pages if you print it out. I'm not a full-time coder anymore, and I would love to port these to Go, but all of my stars and stripes are in C++ land still, because I still like to code in C++ occasionally. Okay, new feature that I recently added since the last HashiTalks when I did this, we, as users, it's never been easy to do a complex transaction with a file system, right? You do a read, you do a write, but you can't do a write and get a read out of it. So if you've ever used Bash's dev TCP device, this is a really interesting concept. So it was a virtual path within Bash. You can echo something to it on a port and get a response out via your third file descriptor. So if you're familiar with Linux or normal Unix file descriptors, every process has FD0, which is standard in, FD1, which is standard out, FD2, which is standard error, FD3, which is actually a bonus one, right? Not many people use FD3. So now I have implemented to the point where if you do a write or a post or a put or any REST call that returns output, but required a write, you weren't able to see that previously, right? The Fuse process is not attached to your client process wherever you're reading it from. But what I do now is an experiment is I take your Fuse context, I get your process ID, and I dump any output to that standard out, right? So your proc/u, whatever your client is, /fd/1 gets any, I attempt to write any output to it. So it's really helpful because you can actually use this for complex transactions within Vault. You need to copy a base64 payload into encrypt or decrypt, or assign in this case, where I do this example in a GIF. So you echo the plain text with the base64 to a file, whatever you take to get that into a file. And then you can browse the transit secret engine or any path really within Vault, copy that to Vault, and note that copy, the CP command normally wouldn't have standard out, right? Unless there's a problem, it would go to standard error. But here we see we copy a payload to a file, and then we get standard out, we get JSON dump, right? So you can actually pipe that into JQ like I did right here. Now, if you're writing your own process, you're doing a read or write transaction, you can do the same thing, right? You can actually switch it to use FD3 if you don't want to interfere with your standard out. You can choose which file descriptor you want to put that out to if you do a build. So I'd be curious if anybody finds that useful, or I've certainly not tried it on every endpoint. You can do things like generate random numbers. You have to tell it, Vault, how many bytes of random numbers you would want, how much entropy, whatever you want to specify as part of the API. Now you can get that out with a simple file operation. So anybody, feel free to experiment with that. Let me know in GitHub if you have feedback on that. Okay. If you are using this for a Kubernetes sidecar, the good news is it's a great option for a sidecar. It's tiny, something like 28K dynamically linked, and maybe about 40K, I think, statically linked with libcurl and libc++. libjson C++. So it's a great option to say, use this, you effectively mount it as a volume, right? You can use Fuse file systems as volumes that would be bound to your pod and your Kubernetes deployment. Use your service account to authenticate to Vault, for example. that service account exposes you to policies, and you get access to whatever secrets that policy gives you, right? So here in this case, we say within the pod, if I tree my mount VoltaFest or wherever I'm going to mount that volume, I can browse my PKI certificates. I can even request my own, right? So each pod will get its own certificate, and I don't have to worry about the Vault, the vol Vault binary being injected as a sidecar, right? Because that is kind of a heavyweight sidecar at this point. So really lightweight. It's, again, a simple process just to have a separate file system mounted as a volume, and you treat it as your normal Vault without having to worry about any of the API mappings. Okay, future enhancements, again, I would love to deploy it to Go. Again, I'm not a full-time coder anymore, so I've started to do it a little bit. So one of the engineers at HashiCorp actually did a really great job porting an early version of the Vault client to Go, and it actually works pretty well. If there's more interest in that, I'm happy to work with the community and devote some more time to it. In the meantime, I just experiment a little bit more with the Open API support. So that's my target now. I'm developing mostly on the Open API one because in our near future, we will have more products that will support Open API specs. Nomad is being discussed right now. I'm hoping Consul will have it eventually. And obviously Terraform Enterprise has its own API. I don't know that that will support Open API version 3 specs, but schemas, I should say, but fingers crossed. So as we do that, as we get more products implementing Open API standards, then we essentially could have one agent that is used to browse any of our products, right? You don't have to worry about complex and bulky CLIs. All you have to do is have this universal client, okay? Number 3, indirect IO cache. I would love to support that. It's not easy. It's not easy in concept because you can obviously take advantage of the kernel cache, which would cache your secrets, cache your whatever you're fetching out of Terraform Enterprise, etc. The problem is you don't know necessarily how long to cache that, right? Also, with direct IO, you must read or write the entire payload at once. A file system normally will divide up into 4 kilobyte chunks, or I should say whatever the default block size for the operation is. So once you use direct IO with big writes as a fused file system mount, you get the ability to write larger payloads. Otherwise, if you exceed that, you have to divide that up into smaller blocks, and that tends to break this functionality because you fetch the same API request twice. So I think that's 130 kilobytes is the maximum payload that you can transact right now, depending on your fuse implementation. Okay, also Git support, and this is an interesting idea, not necessarily something that I need to implement, but the fact that you could mount a Git repository, view all versions, view all branches, etc. locally, and then not have to worry about the Git CLI. That would be interesting as well, wouldn't it? Possibly, we'll see in the future. And 5, again, I talked about the HashiCorp Open API support. It would be great. I would love to see it more developed. I have the draft actually that I've put together as part of the last talk, and I have improved upon it a bit actually with the standard out, right? So I talked about when you copy or write something to a post endpoint, you normally wouldn't get anything out because that's not how file system transacts. But now you can do that. You can copy whatever your payload is to a post endpoint, to a put, and have that standard out dumped to your terminal, which is really useful. And whatever process you use, it doesn't matter. It all comes to your standard out. So that is growing in support. I think the Open API client, again, will be big. I do think that there's a problem with the Open API version 3 standard that I wish I could have everything laid out as a tree. The Open API version 3 spec, if you've ever looked at one from Vault, isn't really a tree, it's a list of endpoints, right? So that is difficult when you have to do a get attribute on each directory along a path. You have to say, okay, path root is a directory, transit is a directory, and then, but if there's a large path that has something like 5 levels deep, you have to actually parse each one and make sure that you're a directory along each step of the way. So we'll see if I could actually have the Open API 3 spec, or maybe Open API version 4 spec be modified. That would be on my wish list for sure. In the meantime, it's not impossible. It's not difficult. I will implement that at some point as well. But you can see for yourself. You can browse your Vault API. The Open API version 3 support in Vault is actually really good. It's fantastic. So if you're a user of that, give it a try. Again, it's open source or in enterprise since I think version 1.1 or 1.2. So really helpful feature. Look for it soon in Nomad. I'm thinking that's going to make a big deal to Nomad. And yeah, if there's any other product that you want to push for OpenAPI support or engineering teams to support the Fuse clients as well, just let us know on the community on GitHub or discuss. So anyway, I hope that's been informative to you. I would propose a conclusion and a challenge. All of the repos you see are available. HashiFuse contains all of the repo clients that I have. I build all of the HashiFuse clients. They're a single file, most of them, a single C++ file. And I do build automation on the Fedora Copper system. So if you want a repo where you can download these and track with the updates, feel free to jump on board. Otherwise, you can build from source anytime. It's just a simple make file. As long as you have libfuse, it works. So repo for all of the clients is there. Repo for this presentation that I use is there as well. Pull requests and ports are welcome, and I love feedback. So anybody has any feedback, I'm happy to hear it. Okay. In the meantime, thank you. Enjoy the rest of your HashiTalks. This is John Boyle again, and have a great day. Cheers. Bye.
Welcome back, everyone. A fascinating session. While we were watching the session, one of my dogs came in and sat right next to me, and hoped that she was able to get some good bits of information and knowledge too. Might help with some rubber ducking and other engineering type conversations later. At least that's my hope. Thank you so much, John. So I really like that point about using that as a sidecar and just being able to use that as a good way to test things. And I've heard about fuses. I try to have a longer one than a shorter fuse, but always fun on that front. Excellent, wonderful. Well, I think we are going to take just a moment while we move into our next talk. Just take a quick break for a few moments, and then we will catch you in just a few moments. See you in a bit. Thank you.
Hi, I'm Chloe. I'd like to thank HashiTalks Build for the opportunity to speak today. Should We Build It is a response and update to a talk I gave almost exactly 3 years ago and is the product of learning, reflection, and iteration on my part. I'm writing this at a strange time in the world where it occasionally feels difficult to acknowledge that our previous approaches, such as prioritizing profit or increasing user engagement at the expense of ethics, has contributed to a wide variety of disastrous consequences. That those consequences have been mostly unintentional makes this talk feel even more crucial to me. I hope this talk can be a continuation of the conversation about how to engage in ethical development at a time where, more than ever, that requires a willingness to change in the face of new information and a commitment to long-term good over short-term gain. What follows is a collection of my thoughts on the topic. Chapter 1, Empathy, Ethics, and Hard Problems. There's a saying, technology is neutral. It's complete garbage. Technology isn't neutral because it's made by real people. Technology is better considered impartial in the sense that it cannot make conceptual exceptions to its underlying functionality and effects. No matter the best intentions of its creators, technology can only exhibit the traits encoded in it. Its creators must supply any empathy built into the system through their own guiding principles, design choices, and final implementations. As I was working on this talk, I read a tweet thread about a woman whose Nigerian mother couldn't communicate with her smart home devices because they couldn't understand her accent. Voice recognition has one set of recognized sounds for any given set of words, and if the way you speak isn't in its dictionary, it can't understand you. Like an automatic faucet that can't recognize Black users whose skin is too dark, these devices demonstrate the gap between their creators and their end users. The impact of or effect of the technology was considered without complete context about the people whose lives it would touch. This tweet thread caused me to think about how many people I know who've had a hand in the design and implementation of something they were proud of, and stories of when those features or creations had to be updated or fixed due to a similar gap in their creation. About the conversations I've had with friends where we talked about what we were making and around the edges of it, trying to feel out whether we were really comfortable with what we were doing. Ethical development is a huge subject, and it gets pushed off too often as a hard problem. Rather than tackling ethics as an upfront investment of time, effort, and yes, money, it's treated as something that can be addressed if it becomes a problem later. In community projects and personal projects, it's often shoved aside with the argument, but we don't have the resources to invest in that. In some ways, human history is a story of technology. Every major change in the way we live has been brought on by technology. Access to technology can be a great equalizer. Many of the world's communities have limited ability to access or influence technology and instead find themselves on the negative side of the equation. From victory in war to success in surviving natural disaster, who is able to survive and rebuild and who is not is often a matter of technology and wealth. Approaching this fact with empathy and humility, I find myself returning to the idea again and again that in some small part, my work in technology contributes to the possibility for human advancement. And because of that, I think about what my obligations are as an engineer and a creator, how to understand the impact of my work on a community or system. Chapter 2, This talk isn't all the answers. Ethics is the kind of thing people make a career of studying. Trying to distill the totality of moral philosophy down to a little over 20 minutes would be impossible. This talk isn't a specific ethical code. It assumes we share broad, similar community goals, creating work that is uplifting, beneficial, or generally constructive, likewise avoiding work which is destructive or causes harm. This also won't define good technology and bad technology, because the real ethical questions are almost never, am I about to clone a T-Rex that will try to eat the guests at my super illegal animal zoo? I wish ethical questions in technology were ever that simple and straightforward. If we were always facing villains with volcano layers, we would never have to have this conversation. The real ethical questions are about whether small decisions will have great impacts and whether our principles can tolerate compromises that we're looking at making. Or More succinctly, if we get to inventing Skynet, we've already lost. Chapter 3, hindsight is 2020. It is my judgment in these things that when you see something that is technically sweet, you go ahead and do it, and you argue about what to do about it only after you have had your technical success. J. Robert Oppenheimer, father of the atom bomb. In 1954, Oppenheimer spoke these words while discussing the creation of the atom bomb, an invention he contributed to and would begin working to see abolished shortly after it was completed. The history of technology is full of similar stories, both factual and fictional. The story that haunts me most is that of Asa Raskin, the inventor of Infinite Skull. Raskin's regret is that something he created in naive idealism has ultimately become an agent of harm. He estimates Infinite Scroll wastes a truly mind-boggling number of hours every day. This technology is now considered so integral to how our apps work that we get angry if it glitches. As technologists, we have the awe-inspiring responsibility of being the people who are building the social and societal infrastructure of the future. Technological history is also the story of constant iterative change, innovation emerging not with a lightning bolt from the sky, but with an aha as some change or shift or new perspective leads to building on the past. Call it remix theory or recombinatorics, iteration accelerates creation. Over time, simple systems become more and more complex, enabling us to do things that once seemed impossible. But iteration also has the tendency to magnify flaws and complexity the tendency to hide them. The risks introduced are often highly technical, requiring experts even within the subset of people who are technologists. Chapter 4, butterflies and hurricanes. And so we return to the heart of this framework. Every technical decision we make has material consequences, whether physical or social. From what frameworks and languages we use to what we design and build, the results of our decisions impact people we'll never meet in ways we still don't grasp. Technology has changed the world so quickly in the last century that it only superficially resembles the world of 200 years ago. But just as society shapes technology, technology shapes society. What technology makes frictionless will become standard. For a hyperspeed microcosm example, in roughly a decade, self-check has become standard in grocery stores across the country. And in less than that, Apple Pay has become a standard payment option, not just in large cities, but in small towns. The butterfly effect is a pop science just so story that is ultimately used to either promote or refute the idea that a complex system can be reduced to a perfectly predictive model given enough data. A butterfly flaps its wings in Asia, a hurricane touches down in the southeastern United States. But if the goal is to prevent hurricanes from causing damage and injury, measuring butterfly wings is the wrong way to go about it. Butterflies are not the instigators of hurricanes. Complex systems like weather or technology can't be pragmatically considered in that way. If all of our decisions have material consequences, but it's impossible to treat them as naive assumptions or formulaic heuristics, the framework for ethical development has to rethink the problem entirely. I offer 5 tenets: prioritize ethics, diversify perspectives, reduce harm, iterate towards better, just say no. These are designed to change the focus of the question. Not should it be built, but should we build it? Chapter 5, prioritize ethics. Voltairine declares words to the Unity congregation in Philadelphia may have been composed in 1890, but 121 years later, they are just as true. You will never get right until you start right. Development doesn't start in a design document or a Git repository. It doesn't start in architecture diagrams or deployments. Development starts when we begin thinking about how to solve a problem. The way we frame the question to ourselves and the aspects of it we decide to care about will be the first principles from which the technology emerges. Later developments will have to be grafted to this structure, which makes changing these underlying principles difficult. Meanwhile, having a good intent and a big heart aren't enough to ensure that we're building ethically. Ethical development requires a commitment to prioritizing alignment with our ethics above other concerns, such as profit, speed of development, or innovation. Everything we create should be asked the question, does building this contribute to a world in alignment with my principles? This question is a powerful reframing of the concept of ethical development. It moves us, technologists, from trying to interrogate whether a technology is good or bad, to thinking about the technology in the context of a larger system. When we ask if we're in alignment with our principles, we acknowledge our greatest ethical guide, our conscience, and trust it to guide us. Rather than saying technology is neutral, a cliche which isn't really true, we might say more technology is indifferent. Our creations will not care about anything that isn't built into them, and so our commitment to ethical development as a first principle means returning over and over to this question. Chapter 6, Diversify Perspectives. I've watched technology change the world immensely in my life. From a childhood where my family still had a rotary phone because it worked perfectly well, to carrying a futuristic iPad around like a notebook for my idle thoughts. And I've watched the world around me expand as fast as technology could enable it. From my first dial-up BBSs as a teenager, to watching international conferences and community days live over the internet in a few decades. It is a misspent youth on the early internet I can credit with my love of technology and my eventual career. I am fortunate to know technologists from all over the globe, from dozens of countries. I think I'm beyond lucky to live in a time where I get to be part of a global community like that. But it has also made me conscious of how often I still make assumptions about technology, access, and knowledge that assume my frame of reference is the default. In a previous job, I worked with journalists, and thinking through technological safety in foreign countries was an entire education on the subject, one I got very quickly. Every new technology changes the world, and the system is now much wider than our individual frames of reference. In order to fully understand how our work will impact the world, we have to fill in the gaps in our awareness and understanding of its effects and consequences. We can't do it by ourselves or with people who share our gaps. We need to see who isn't in the room and make an extra effort to include them. We must make the choice to build our work in teams based on shared goals and principles, rather than shared perspective or proximity. Technology that is created in monoculture tends to be brittle, difficult to change, and insecure. Diverse perspectives, however, tend to be more dynamic in thinking. This allows them to build things which are more resilient and creative. While it's easy to say diversify perspectives, the truth is that it can be hard. Technology is creative, and it's difficult to receive feedback on our creations that feels critical. Gathering feedback from people who aren't already in the room also requires humility and proactive cultivation of a community to get feedback from. When pursuing ethical development, it is our responsibility to be fully informed about the potential risks of our creations and their effects in order to determine if they truly contribute to a world in alignment with our goals. When we diversify the perspectives in our development processes, seeking feedback from a variety of voices, we ensure we are not missing weaknesses, flaws, or risks in the technology we create. Chapter 7, Reduce Harm. A woman and lawyer I very much respect once said to me, software engineering is not a profession. She's an incredibly smart person and not generally in the habit of having what I think of as spicy takes. So I asked for an explanation, wanting to learn me a thing. She unpacked for me the idea that professions require some sort of professional certification that you are qualified to do the thing, whatever that thing may be. Professions have professional codes, which their members follow, such as legal ethics for the bar or medical ethics for doctors. She's right by that measure. Software engineering isn't quite a profession, but having a commonly held professional code of ethics seems like a fairly solid idea. And every professional code of ethics in the world starts with some sort of harm reduction tenet. From the oft-quoted but not quite right, first do no harm of the Hippocratic Oath, to the actual words of the Institute of Electrical and Electronics Engineers, whose code begins with a tenet reading, hold paramount the safety, health, and welfare of the public, to strive to comply with ethical design and sustainable development practices, and to disclose promptly factors that might endanger the public or the environment. Because I was torn, I'll also mention the Association for Computing Machinery's first and second general ethical principles, which paraphrased, set the expectation that member computing professionals will contribute to human well-being, acknowledge that all human beings are stakeholders in technology, and avoid harm. These are the baseline ethics all members are expected to share. For what it's worth, that one's a pretty neat document, and if you're interested in this sort of thing, you might want to give it a read. The practice of harm reduction requires asking not just how our designs are vulnerable, but how they can be misused or made harmful. It requires evaluating whether the impact of our decisions will be in alignment with our principles. And then it requires committing to building in a way that minimizes the negative impact of our creations. Chapter 8, iterate towards better. One of my favorite sayings about sculpting is that to make a sculpture, you simply take a block of marble and chip away everything that isn't the sculpture. Improving our work is a lot like that. The first thing we create, the design, the proof of concept, the first draft code, all of it will eventually have pieces chipped away or changed as it is used, and as we think of features to add or ways to improve functionality. When considering the social and physical impacts of our work, we must think in the same way. What was good enough yesterday must remain open to review and refinement so that when ethical debt is found or new risk is uncovered, we are ready to iterate it towards a better state, to change it towards a greater alignment with our principles. Sometimes this is easy. In some situations, the solution is completely technical. Something like adding encryption, changing a logging function to mask sensitive data you don't need to collect. Frequently, it's more challenging and becomes another exercise in accountability and humility if we're lucky. But iteration is the giant job we signed up for, and improving the ethical stance of our creations is as important as improving their security stance or accessibility. In many cases, as I've said before, it's the same thing. When new information or context reveals to us that our previous decisions are no longer enough, ethical development requires us to seek ways to improve it or change it. Should we build it does not end at release. As long as we are responsible for the things we create, we must remain accountable for them too. Chapter 9, just say no. As a kid, my parents had some rules they shared every time I left the house. The usual be home before dark type stuff. But they always ended with don't take any offers you can't refuse or join any clubs you can't get out of on your own 2 feet. While I'm pretty sure that rule originally had more to do with a cinephile father's love for mafia movies than anything else, it's advice I've always held on to as a reminder that there are times one must say no. As technologists, we are frequently sought after. We're considered experts. In many places, we're seen as somewhat special, the type of people that hear, I could never learn to do that. In our projects, whether professional or personal, we're seen as the last word, the person who knows what can be done and how to do it. And that is why when we are asked to do that which we cannot ethically do, we must say no. In personal projects, by which I only mean those we are not being paid for, saying no is often more straightforward than in professional projects. However, I only mean that deciding not to build something will probably come with social consequences rather than material ones. In our professional lives, when we are confronted with objecting, we may be risking much more. Our livelihoods, our health insurance, in some cases, our visas or working arrangements that provide accommodation for our needs and would be hard to replicate with another employer. These risks are real, but if we cannot build in alignment with the principles of harm reduction and contributing to a world in alignment with our principles, they are also required. This is why ethics are truly a hard problem, not because we don't know what's right, but because we know what doing the right thing can cost. Chapter 10, Avoiding Raptors in the Suburbs. My favorite morality tale about technology and ethics is Jurassic Park by Michael Crichton. While the movie version is more commonly known, in the book, the character of Ian Malcolm has even more room to make cynical, if accurate, observations. His quote, cut down for film digestibility, was originally, "Scientists are actually preoccupied with accomplishment, so they are focused on whether they can do something. They never stop to ask if they should do something." His echo of Oppenheimer's words is assumedly intentional and meant to be as precautionary as their predecessors. The idea of cloning murderous dinosaurs who will someday escape their dangerous electrified cages and rampage across an island so you can fill a theme park with them seems laughably absurd when delivered in a single sentence. But Tiger King, one of the most popular pieces of media online for a while last year, was a documentary about an exotic animal zoos full of large cats kept by private owners. Rampaging Dino Theme Park is just a version of the truth that's exciting for fiction, so hopefully we'll pay attention. When I'm asked about my getting into tech story, I often say it was about video games, and in a way, this is true. But it's not the complete truth. The whole truth is I grew up an optimistic kid with their eyes on a Star Trek future, one where problems like cancer, world hunger, violence would be tackled by the best available minds, rather than being limited by corporate NDAs and fear of competition. I learned my first ethics from science fiction, a never-ending parade of the ways unethical behavior leads to disaster, not just for a handful of people, but for the whole human race. I've been a hacker since my first Commodore 64, but in the last 5 years, I've become a professional engineer and now manager. I've watched a move fast and break things ethos war with a be kind and solve problems one. It seems ironic to me that being disruptive is something praised in tech when a disruption is usually a negative event and one we hope to avoid. I mention this because I think how we talk about it matters. And if we're going to be successful with an ethical development framework, we have to use one that keeps us looking in the right direction. Rather than disruption, ethical development calls for us to look for innovation, change that creates or improves. If human history is the story of technology, then we, technologists today, are writing history with our decisions. The things we build and the communities we build around them deserve to be more than afterthoughts or compliance checklists. The costs of waiting to consider ethical risks until change is inevitable include ecological damage, political unrest, and human harm. As technologists, we have immense power. We are still so very rare in the world, and what we build matters. Our work touches the lives of strangers no matter what we do, and we may never be able to truly see the impact of it. Our ability to predict the future, and anyone who says otherwise is overconfident, but we owe it to that future to make the best choices we can now in terms of minimizing harm and destruction. So, as we draw to a close, I've appreciated your time today. As I've mentioned before, I think about this a lot, and I hope we as a community continue the conversation around ethical development and accountability. We can't rely on our best intentions to save us, but we can use them to guide us to building better things. Thank you.
Welcome, everyone. Happy to have you back. And we are joined today with Chloe. Chloe, thank you so much for stopping by. A fantastic talk. I feel like that's something that not a lot of people focus on, is the whole, should I be doing this thing? It's one of my favorite things to examine is and probably one of the more common ones is the VW the issues that happened around exhaust and kind of manipulating those results. And you saw the effects of people that just said yes and didn't really think about what the downstream effects were. And then developers, people that typically can, say, I was just trying to get this thing done or this feature added, got, into legal trouble around some things like that. So the things that you do can affect the world in positive and negative ways. And just a really colorful, wonderful example that you were able to set with your talk. Really loved the artwork and the dinosaurs and everything else too. So thank you so much.
Awesome. Thanks. Yeah, I feel like ethical talks are always hard because people always think they're going to be very dry and difficult and tough. And so I was like, all right, well, I'm talking about Jurassic Park. Let's just go all in on that 90s arcade aesthetic. And let's show you how approachable the topic can be, even in the slides themselves, right? Because ultimately these questions aren't these big, huge, like, am I about to clone a raptor? They really are, what are the downstream effects of this decision I'm making now? And am I comfortable being the person who's accountable for those things?
Absolutely incredible. I do want to welcome Jackie to the stream as well. Parting is sweet sorrow. Unfortunately, after this, I will be jumping out of MC duties and welcoming in Jackie. Mary had to leave us and go do some other things, but very, very excited for all the things that HashiTalks Build has to offer today. To get back to ethics, though, one other thing I did want to ask you, Chloe, was you had mentioned that growing up, science fiction was a really good learning place for you to kind of understand ethics and how these things can be applied. Besides Jurassic Park, do you have any other examples of where you picked up on those things or kind of worked through those different thought experiments and such?
Oh my gosh. I mean, the classics, right? So like Octavia Butler, Parable of the Sower. So many of the books I hesitate to mention now because we've all grown up since we were younger, and attitudes have, changed over the years, and things that I might have once been like, oh, hey, I really love this. I can see some of the problematic stuff in. So instead of pointing at the past, I want to point at a couple of sort of more current books. So like, for example, I love Mickey Kendall. I love, honestly, some of the stuff that's been coming out of Marvel, like the Black Panther runs recently. But I mean, the real truth of it is, honestly, if you're a fan of genre fiction, I guarantee you are absorbing these lessons in everything you read, right? From Hunger Games through to, what was that one with the potatoes on Mars? I can't remember.
Oh, The Martian. The Martian.
Yes, The Martian. But anywhere in that range, right? You are being exposed to these concepts and lessons because they're literally what drives the stories.
I think it's Ted Chiang, if I'm pronouncing that correctly. I just read a lot of those short stories recently, and Blake Crouch is a recent author that I found that I really like too. And if you haven't checked it out, I think Dark Matter is one book that's definitely worth checking out. There's another one. I see the title in my head, but I can't remember what it was. But it was about basically memory and kind of figuring out ways to go back in time, fix how something happened, and then so long as that memory got passed on, you could be within that timeline. I won't spoil it for you. It's a fantastic read, but really, could talk for hours about that. And thank you so much, Chloe. It's just such an illuminating talk. Jackie, welcome. And did you have any questions for Chloe?
Thank you. I'm actually just really happy I got to see your talk because I didn't think I was going to get to have this overlap with you. And I loved your slides. You already know I loved your slides. I loved pretty much everything about this talk. So I didn't get to catch too much of the beginning, but a lot of your comparisons are great. I mean, I almost wore a dinosaur shirt today to MC just to go with the talk. So I don't think I have any
Thank
questions right
you.
now, but I did see in chat that somebody was wondering if you're going to be sharing your slides after.
Yes, I believe there are actual HashiCorp plans to put them out, but if not, I will make sure that they are available on the web and I will tweet about them. I think my speaker slide has my Twitter on it. There was also a live tweet thread where I gave you a little bit of behind the scenes and supplemental information. And anyone who wants to continue the conversation, I am happy to continue on Twitter. That's work related, right?
Absolutely, absolutely. One thing that you said too that gave me an idea was you said that we're not cloning a Raptor, but if we make a GitHub repository called Raptor, maybe we could clone it later. I'll talk to you after.
So I actually, there's a whole section of this talk that I cut out that I clearly should have left in, which is if you're thinking of naming your technology after something evil, that's a sign you should reconsider. So I'll write that as a B-side when we release this as a single. There will be a supplemental 5 minutes on the back. Yeah, let's not
Jeez,
clone Raptors.
I'm really regretting naming my package manager that I set up a few years ago after Smaug from Lord of the Rings now, or The Hobbit.
I mean, you know, I might have named some of my tools after Thanos when I was having, you know, a fit, but again, sign to reconsider. We all mature, we iterate towards better, right? That's the principle here.
And it's easy to see when only half of them work after some time too. So it makes sense. Awesome. Wonderful. Well, so I think we are going to get some talks queued up here. I believe next on the schedule is Building Better Tutorials by Rachel Sharp. We'll get that started here shortly. Thank you again so much, Chloe. That was a fantastic talk. I'll be talking about that one for some time to come. And welcome,
Awesome.
Jackie. I'm going to bounce out. I'm going to hop on later on in the stream, but hope y'all enjoy HashiTalks Build. It's been a pleasure emceeing, and I will see you around the proverbial water cooler. Have a good one.
Hello, everyone. Welcome back to HashiTalks Build. We're just coming back from, I believe, well, from a break, and we've already had about 8 hours of content today. So I'm coming in now. I will be your MC for the next 2 blocks of content and talks and sessions, and I'm really excited to have you all here and joining me today. With that said, I think we're going to be kicking right off and getting straight into building better tutorials with Rachel Sharp. And thank you for joining, and I hope you enjoy.
To talk a little bit about the tutorial design process and communication and reflection to build better tutorials. My name is Rachel Sharp, and I'm an education engineer here at HashiCorp working on the Terraform product. In this talk, I'd like to go over what the education team has learned while making tutorials, some of the processes that we've used and improved on, and how maybe these processes can help you going forward in your documentation or tutorial writing. We'll look at the tutorial design process, how we collaborate, some style guide standards, and some tips to help you peer and self-edit your work. You may be asking, why are we talking about writing tutorials at a technical conference? Well, you build a lot of things and you learn a lot of things, and you'll be wanting to implement those things at your place of employment or in one of your projects. But this quote may come to mind whenever you think about writing your own documentation. If you can't explain it simply, you don't understand it well enough. If someone asks you to document a project that you've been working on, you may think of this quote and think, well, how can I condense all of this work simply? And how do I even know what simple is to my audience? And that's because simplicity is really hard. When you are a subject matter expert, when you have a lot of expert knowledge and you're tasked with documenting a feature or documenting something, it can be a little bit daunting to think about how to simplify and distill your knowledge for someone else. So hopefully this talk will help you face some of that complexity with systems to give you more simplicity in the process. If you have a repeatable process for capturing your features, addressing your audience, and then sharing knowledge across your team, you can create tutorials that make onboarding or educating your customers seem simple at any level of expertise. So the first part of this process will be the tutorial design process, and that's a few different steps here. In the tutorial design process, we have 4 main steps. The first is to find our topics. So when you're thinking of things to document or things you want to write about, where do you get those topics from? Does this come from an engineering team or a support knowledge base or from a project manager? Then you'll be working on building a design template. This template is a design doc where we capture all of the research that we've done, any of the other information from other teams, and then what is in and out of scope for the tutorial. You want to make sure you capture a really tightly scoped topic so that other context doesn't creep into your tutorial and make it longer and off point. Then you'll create a tutorial outline. This will give you a wireframe to start writing and filling in whenever you do start the tutorial writing process. And then throughout, you'll be reviewing your work with coworkers. So one question that you might ask when finding new topics is, what should you document? Well, depending on the needs of your team or your organization, you may have several different types of content that you want to highlight. First, the foundational content can be great for introductory users. These are your getting started guides, core concepts, and best practices. The Terraform education team started with content like this, and as the team grew, we saw the need to document new features and even intermediate and advanced features. And we're continuing to go down that path to get more advanced topics on Learn. So as your team grows and changes, you might want to document new features or more specific use case examples, and even teaching your users how to scale up in the use of your product. So in the tutorial design process, we create a template for our content, and this is the design document. So in the design document, you'll want to capture a few things. The first is the research that you've done on this topic. Why do we want to cover this? What are the high-level concepts? What benefit would it give us? Would we see more user engagement? Would we see more people using a particular feature? And then you'd want to include any additional documentation such as RFCs or PRDs from other team members. After you've done your research, it should be a little bit easier to narrow down who your audience is. So based on the topic, who would benefit from this tutorial? What is that person's job title? What environment are they working in? This environment is very important to think about, because if it is an onboarding document, then that user has a little bit more time to spend going through a longer tutorial than someone who is only given 30 minutes on their lunch break to learn something new. So two very different audiences and two very different types of content that you would want to convey. And then their level of experience. So how much have they worked with a product or product like this before, and how comfortable are they with the core concepts associated with it? Then you'll want to start mapping out a scenario. So how will you convey this topic to a person? What is the specific task you want them to do? And what is the desired end state? So what will they have at the end of this tutorial to show that they've learned something? And then why do we want them to go through this tutorial? After they have done the tutorial, will they learn more about the topic itself? Will they have a new feature in their production environment, or will they just have more confidence when working with this in the future? So with your thoroughly researched topic and your audience research and scenario, you have everything that you need to start going through a tutorial outline. This will fill in the rest of your tutorial, but right now we're using this as wireframes for your documentation. So we know the exact formula that we want to follow. We want to give an introduction as well as capture any prerequisites, then tell the user what they'll be doing. Then the bulk of the tutorial outline will be the scenario steps. So these are the action items that you need to capture in bullet points to make sure that those are all in order and all clearly explained to go to your main goal. Finally, you have your next steps, where we'll go over a little bit more of what is included in that, but it's typically a reiteration of what the person has done and more in-depth content that they may want to explore. So we've designed something, we've gotten a tutorial outline and a scenario that we think will get us to giving a user more knowledge than they started with. So to ensure that we have everything that we need, we want to start the collaboration process. And that is the review, editing, giving and receiving feedback. So our team collaboration of giving and receiving feedback happens in a few phases. The first is to ask. You have to put your content out there, and you have to do it early and often. In the design phase, in the scenario building phase, this is particularly important because getting more people to review that means that you have more context and more collective knowledge to get anything that you may have missed. This is also important to clear up any questions that may be left unanswered in the design document. So one thing would be, how does this scenario tie into the larger topic? And with that feedback, you may want to include some information on how to tie your scenario back to the topic at hand. Next, you'll want to run the scenario steps. This is the run book portion of the collaboration phase. Once you've built out your scenario, and because you've been working on this for a long time, there may be things that you missed. So having a new user try to run that from end to end as written will expose any hidden or implied steps that you need to document. Then there's reading the scenario content. So based on the research and audience analysis, does this scenario fit that? Or does the audience analysis fit the research? You want to make sure that your topic choice and your audience analysis are correct and drive towards the scenario end goal. And then asking for approval to integrate that feedback. So at different points during this process, you may have comments or concerns or questions from your coworkers and collaborators. And it's important to address and integrate that feedback so that they can give approval so that you can move on to the next phase of the process. This is an example of a design doc template with a stakeholder table. This is where we have collaborators and coworkers sign off on what they've read, and if they have any additional comments that they think should be addressed here. This is great to capture the people who have worked with you so that you can kind of later on in the process go back and ask them again, does this clear up any questions that you have, or does this address your concerns? And then they can give you a check mark and you can go right on to the next part of the process. The next part of the process is writing your drafts. This cycle will start all over again when you start actually writing and filling out your outline and making more content in this tutorial. So of course, there's a relevant XKCD for this. A person, we'll call them the reviewee. The reviewee is asking for a review from the reviewer, and the reviewee says, you know, I'm self-taught, so it's a little bit messy, and the reviewer just roasts the content that they're going over. So it can sometimes feel like this to receive feedback on your work, but communicating with empathy and being able to reflect on your end goal always facilitates better documentation. When you are giving feedback and receiving feedback, it's important to process that thoughtfully. You want to make sure that you're giving something constructive and applying that constructive commentary into your documentation because it's for the good of the end user. And at the end of this roasting, the reviewee says, okay, I'll read a style guide. So speaking of style guides, what are they and why should you have one? Well, style guides are an agreed upon set of standards to apply in your writing. You can find these online. I believe the Google Technical Writing team has a style guide that's public that you can review and add additional information to, but some standard good style guides always include a few things. So the first thing is to keep it simple. You want to keep your audience engaged with simple, direct language. So an example of this is click the update option or click the update button. And sometimes the easiest way to keep something simple is to give them a screenshot instead of having to give a lot of additional context in maybe an online user interface or a graphical user interface. Just give them a screenshot. That can be the easiest, simplest thing. Next, using clear and direct language. So why would you waste time saying a lot of words when a few words do the trick? An example of that is to say you will create. We're using you here because it is a direct reader-centric sentence. So we want the person reading this, you, will create this, and it keeps the audience engaged. Next is consistent tense and active voice. So the apply command builds. Active voice keeps the action driving through the rest of the tutorial, and consistent tense makes sure that the user is always doing something in the present. If you need them to do something in the future, then that should be in a future tutorial. And then using shorter sentences. Longer sentences lead to longer paragraphs, and longer paragraphs sometimes have people skim over them and miss important information. So using shorter sentences like create a virtual machine. That is a direct sentence that you can't really skip over if it is the entire point of the tutorial or the point of the step. And then next, some don'ts. So these are some things that you want to avoid, like excessive jargon. It can be difficult to avoid jargon in a technical document, but you don't want to use buzzwords like streaming leading edge paradigms. And if that is in someone's talk today, I apologize. But in your tutorials, you should avoid jargon like this because it doesn't really give the user something to do. Next is passive voice. So passive voice like infrastructure is built by Terraform. We don't get to Terraform until the very end of that sentence. Then we have to do some sentence remapping to say Terraform builds infrastructure. And that is a little bit, it slows us down a little bit whenever we're reading a tutorial. Next, there's ableist or insensitive language. There are some great examples of substitutions for ableist language online. I would recommend that you check those out. But one that comes to mind for me would be see the return output. Some people use a screen reader to have output read to them. So you want to be able to be inclusive in your writing and just say what you expect in the output. So the output returns this. Insensitive language, like it's so easy my cat could do it, that's a judgment call that is not necessary in your tutorial writing. And then finally, you'll want to avoid being funny or friendly. Trying to be funny in a presentation or in a person-to-person class is fine, but humor can be hard to translate sometimes in a tutorial. And if a person doesn't find it funny, then that can be off-putting. Then finally, being friendly. For newer technical writers or people who are writing tutorials for the first time, using a lot of direct active language can feel unfriendly. But remember that by being direct, you're doing exactly what you need to do for the user. So now that we get into the actual writing, so you have your outline where you've already documented your prerequisites and what the user will be doing. How does that get filled out into an introduction template? Well, we can do this by breaking it down into a few separate questions. So what is the topic? What will the user learn? And what do they need before starting? Here is an example of that introduction template filled out. That is a short beginning sentence to give additional context. And then the next sentence is exactly what the user will do throughout the rest of the tutorial. So that makes it easy for the user to see those first few sentences and know exactly what the topic is and what they'll be doing to illustrate that topic. Then we have our prerequisites. So we've filled these out in our tutorial outline as well. Here, it might be best to capture these as not just tool prerequisites, but things that the user needs to have configured already or any additional information that they may need to know. One thing that I do like is that we've started pinning versions, or we've been pinning versions to tools that are essential to the tutorial process. There's nothing more frustrating than going through a tutorial and realizing halfway through that you're not using the correct version, and then you have to update things and go through the whole thing again. So it's best to document the version that this tutorial was tested on and let the user know that this is where you need to be to make this tutorial work. Now, the bulk of the tutorial will be these step-by-step instructions. These are the action items for each part of the process. Now, for the Learn platform, these tutorials contain a limited number of steps, and depending on your audience, you may want to divide those steps into separate documents. So we tend to do no more than 10, no less than 5, so that there is enough content that the user can follow along, but it's not too long that they may need to stop and come back to it. So the outline that you have has the scenario steps in order. To fill these out into full sentences and full action paragraphs, you can do these sequentially. So first, do this. Next, create this. Now that you have that, you can do this. So all of this is done in a step-by-step sequential order so that the user always knows what they just did and what they're going to do next. Here's an example of our step-by-step organization in the Learn platform. Each of the action items are captured as headers, so the user can easily navigate between one action item to the next, and each of these steps clearly states exactly what the user will do and how that builds to the final goal of the tutorial. Next are writing patterns for next steps. So you're going to repeat what the user just did or learned, and then give them additional reference material for the next level of this topic. Here's an example of this where we say, in this tutorial, you did this. And for more information about the Terraform Cloud API or Terraform State, here's some additional information. So although the tutorial touched on all 3 of these subjects, you didn't have to be an expert in all of them to do the tutorial. Now that this user has done the tutorial, they may want to use that knowledge and learn more about the Terraform Cloud API to do more advanced or more specific things now that they know how to do this thing. So in this final section, we'll look at some editing tips for when you're reviewing someone else's writing and how to review your own. So some things to keep in mind, there are 3 main questions that you want to ask yourself during the review process. And you may want to review something 3 times to capture all of these. So first, does it meet your goals? Remember what the topic, scenario, and goals are. If this doesn't illustrate the topic or distracts from the point, cut it. Don't be afraid to remove or revise to make sure that your topic is clearly illustrated. Does it flow? If you run the scenario as written and end up not getting the intended output, there's something that's not documented. That's why getting outside reviewers is so important. If you've been researching and building something and then you write this step-by-step document, try to reimagine yourself as a new user or someone new to this content. That way you'll see, does this actually flow as though you were a new user? And then finally, is it grammatically correct? This is where you can use built-in tools like spell check or other tools like Grammarly. There are some other language tools as well, but these can capture things that can be distracting to your audience. Also, for something more analog, just reread your text out loud from start to finish. If it is hard to speak, then it might be hard to read, and that's a good indication that you need to change something, move some things around, or just make things a little simpler. Now, even though this process might pause for releasing this documentation, you'll always keep taking feedback and want to continue to edit and update your documentation. So in this example on the Learn platform, after each tutorial, we ask the question, was this helpful? And then you can give us a thumbs up for yes or a thumbs down for no. We do read the feedback that people give during this. So anything that is unclear, we want to address so that we can measure the success of the tutorial. If there are a lot of people who don't find the tutorial helpful, then something was wrong and it wasn't successful. If a lot of people do find the tutorial helpful, we want to measure why and how we can keep that going through other tutorials. So I'd like to end with a quote that's borrowed from Toni Morrison. If there is a book, or in our case, a tutorial, you want to read, but it hasn't been written yet, you must write it. The best way to learn is to practice. And the best way to practice in this case is to start writing. Keep going. Thank you so much for attending HashiTalks Build. I'm so glad to be here with you and to continue learning through the rest of the day. Be sure to check out the Learn platform if you've liked what you've heard so far, and thanks for coming.
All right, thank you so much. Oh, we're live now. Awesome. So I just realized as an MC, I have like one job, which is basically to introduce myself and welcome you in. And I kind of skipped half of my one job. So we're going to recap really quickly. My name's Jackie Grunrod. I'm a developer advocate here at HashiCorp, and I'm going to be your MC for the next roughly 4 hours still. And what we just had was Rachel Sharp just talked to us about how to build better tutorials. She makes amazing content. I've had the privilege to work with her a few times now, and she really does make great Learn guides. So it was great to kind of hear what she has to say behind the scenes about that. So coming out of her talk, we're actually going into Philip's talk now about Flux CD controllers in Kubernetes with Terraform.
Hello and welcome to my presentation called Flux CD controllers in Kubernetes with Terraform. My name is Philip Lane. I work as a DevOps engineer at Senet. We are a Swedish-based company who helps customers with their Kubernetes deployments. I'm also a part of the Flux maintainer team, and I'm a HashiCorp core contributor. So this presentation will be all about how Flux and Terraform integrates with each other and how Terraform has simplified the installation process of Flux in Kubernetes clusters. To understand fully this presentation, I think we need some background into the different topics that we're going to talk about today. So first off, Kubernetes. Kubernetes is an open source tool that manages containerized workloads across multiple nodes. It deals with things like workload distribution, health checking, outscaling, and service discovery. So workload distribution is basically taking a container and placing it on a specific node based on the resource needs and other factors. Health checking is when it basically checks the status of an application and is able then to either remove that application from a node because it's not feeling well, or restarting the application on the same node. Auto-scaling features uses the cloud provider specific APIs to scale out a cluster and add more nodes when the need is there. And service discovery basically allows it to discover other applications and their endpoints in a simple manner. Kubernetes is configured through the use of something called manifests. So the Kubernetes API defines a spec, which you then use to create resources. These resources are defined in manifests. Manifests are basically YAML files that describe a desired state of a specific resource. There are multiple resource kinds. So the example to the left here is a deployment. A deployment is a obfuscation of a multiple replicas of an application. There are other types of resources like pods, services, and secrets. So what all you need to know really is that to create a resource or to make something happen inside of a Kubernetes cluster, you would have to write one of these manifests and add it to the cluster. Custom resource definitions is a slightly newer concept in Kubernetes, and it allows you to extend the existing Kubernetes API to add more custom functionality while at the same time using the same type of way to define and create resources. This has enabled projects like Cert Manager, which has a certificate resource, so you can automatically provision certificates from Let's Encrypt, for example, by just creating a certificate resource in your cluster. CRDs are made up of two components, really. So one is a core resource called Custom Resource Definition, which defines the API spec of your custom resource. And then there's the actual custom resource itself. So the image above is the custom resource definition. It has a specification of these are the parameters that are available in the resource. And the example below here is a Git repository resource, which is a custom resource added by the Flux project. So what is Flux? Well, Flux is a tool for keeping Kubernetes clusters in sync with sources of configuration. What that really means is that Flux runs as a daemon inside of your cluster. It pulls a Git repository for manifests. So it's constantly checking if there are new commits in a Git repository with new manifests there, and it will take those manifests and apply them to your cluster. Flux builds upon a concept called GitOps. GitOps, as an idea, turns continuous delivery on its head, really, by instead of you having a pipeline outside of your deployment environment that is pushing in changes constantly every time you commit. Instead, you really run a daemon inside the cluster that pulls in things. So it's going from a push-based model to a pull-based model. This has a lot of benefits, one of them being that you don't have to export any secrets or credentials from your cluster to some sort of external continuous delivery system. Another one being that if anybody would go into your cluster and manually update a resource, for example, Flux would detect this drift between the source of truth, which is Git, and what's actually inside the cluster. It also means that when you want to audit and see, for example, what is currently deployed in your cluster or who made a change and when a change was made, that could all be done in a Git repository, as Git keeps a history of changes. So Flux is built around a concept called Kubernetes controllers. Kubernetes controllers is this missing thing that I haven't really described yet, which is the last part of how custom resources works. So Flux consists of a couple of Kubernetes controllers. And what a controller does is it takes a specific resource kind and does work based on it. So what it's doing is it's running what's called a reconcile loop. So it's waiting for a specific resource kind for an action to be acted upon it. If it's a new resource being created, updated, deleted, whatever, it will then do the actual actions based upon that resource. So for full deployment of Flux, Flux consists of a set of applications called controllers that run inside your cluster, plus the custom resource definition manifests, plus any custom resources that you define, which then you add inside of your cluster. Controllers can be, with the help of some frameworks, be written in Go. The majority of Kubernetes controllers out there today are mostly written in Go. This works really nice, so as we'll show later, with the writing Terraform providers. a lot of the tooling around Kubernetes controllers and Go is its framework. So you can use Go structs that generate custom resource definitions, so you're not writing these custom resource definitions. So installing Flux is actually a multi-step process. There are the simple parts of it, and that's adding the CRDs to your cluster. It's adding the controllers and maybe configuring the bootstrap process. The more complicated part is linking these things together with external sources. So to bootstrap Flux, you actually need a Git repository that contains the manifests for the controllers that are deploying itself. So it's kind of a circular bootstrap where you need to have their sources in both your cluster and your Git repository for things to work. After that's done, you can actually just commit things into this new Git repository you have and have it automatically be pulled down into your cluster. But this initial step has to be done for things to work. And that includes creating a Git repository, committing the CRDs and the manifests to that repo. But also, if you're running a private Git repository, you would need to create some sort of credential, if it's a HTTP or a SSH credential, that you both need to configure with your Git provider, but also then add to your cluster so that Flux has that credential that it can communicate with. To deal with all this complexity, really, we built a CLI called Flux. Also, that automates a lot of this process. So you'd give it your GitHub credentials or an API token, and it would basically deal with the whole deployment for you. And that worked for a lot of people. The issue turned out to be that a large part of the Flux community that were heavy Flux users were also Terraform users, because they were creating their Kubernetes clusters with Terraform. This created some sorts of friction between Terraform and Flux, as a lot of people would use null resources to shell out to the Flux CLI and have it then deal with the installation process. I'm personally not a big fan of running local exec with Terraform, mostly because it requires the computer or CD or CI system to have other dependencies installed, but also there is no way of really defining the versions of these dependencies. So the Flux version could be really whatever Flux version that happens to be installed. So you'd end up with different results between runs on different computers, but also it would be hard to, in an automatic way, detect when a new version is used, so that the null resource could be triggered. What most people would do is they would have a trigger causing the null resource to always be run. So this wasn't really a optimal solution. There are a lot of people who including myself, who liked to use Terraform to set up the cluster. So it was only logical that we needed a better solution for how we would create or how we would bootstrap these clusters, because we really wanted it to be a single seamless process of creating the cluster and then bootstrapping it with Flux. And then we could hand over the rest of the manifest deployment to Flux instead. So when working with Terraform and Kubernetes, you have a couple of options when it comes to providers. All these providers really end up doing very similar things. They connect to the Kubernetes API that you specify, and it's kind of nice to link together the Terraform that creates your cluster, and as an output, you would get the API endpoint and the credentials, and you'd pass it to your provider. But the most common, I guess, is the official HashiCorp Kubernetes provider. You write your Kubernetes resources as HCL instead of YAML, but it's really just a one-to-one relationship there. Nothing really special about it. The downside of the Kubernetes HashiCorp provider is that each resource or each Kubernetes kind has to be defined inside of the provider with all its parameters. This means that if any update in Kubernetes adds a new field to a resource kind, the provider itself would also have to be updated, but it also means that any custom resource is not available with this provider. It's only the core resource kinds that are possible with the Kubernetes provider. If you want to use custom resources or do a bit more dynamic stuff, there is a Helm provider. I won't go into too much detail, but Helm is a packaging templating engine for Kubernetes manifests that allows you to template YAML files, really. The benefit of using the Helm provider is that you can write pure YAML and have it run the manifest generation and basically allow it to deal with the deployment of it. There are some downsides with Helm. One of the major ones is that Helm does not manage CRDs for you. So if you want to actually add the custom resource definitions with Helm, it will only install the custom resource definitions, but it will not update them for you. Then there is a third-party provider called kubectl that allows you with Terraform to apply raw manifest files without really it knowing too much about what you're applying. According to me, it actually works pretty well. And then there is the kind of the interesting provider out there, which is the Kubernetes Alpha provider that is trying to solve the problems that the current production use Kubernetes provider has around, for example, not supporting custom resource definitions and having to be updated every time that the Kubernetes API is updated. So it's taking a different approach to how Kubernetes resources can be created with Terraform. But the issue with that is it really isn't production ready yet. And then, as I stated before, you have null resources, a last escape hatch. If you're really out of luck, it really isn't a great solution using null resources and shelling out, mostly because you would need to take your Kubernetes credentials and write it to a file and have that file live somewhere. But also it creates a dependency on a binary that really isn't explicitly stated by Terraform. Yeah, so looking around, within the Flux team, we were looking at how we're supposed to enable these types of use cases of creating Kubernetes clusters with Terraform, but also then installing Flux. One option was, well, writing a Helm chart. I think the major downside of writing Helm charts was really the lack of functionality around managing CRDs, as the Flux project creates a lot of CRDs and these CRDs are constantly updated. We guess that we would end up in a situation where users would be very confused and bugs would be caused just because they would update the Helm chart version, but they wouldn't update the CRD versions. So there would be a drift there. So it would introduce a manual process that really wasn't that nice. Additionally, Helm charts required us to maintain yet another deployment method that couldn't really be automated. Another option was static manifests, just publishing the manifests and then allowing the community to, for example, use the kubectl provider to apply that to your cluster. It has its downsides of not really enabling any user configuration, but also it would be difficult to push and force updates for the Flux controller components, as my guess would be that a lot of users would copy these manifests and then have them live in their own Git repository, which would make the updating process a manual step. And last but not least, you would have the Kubernetes Alpha provider, and we had a look at it, but it really isn't an option as it isn't production ready yet. But all of these three options really don't talk about the other complexities of installing Flux, which is integrating with, for example, GitHub and committing things and committing files. So alone, these three solutions wouldn't really solve the problem anyways. You'd still have to do a lot of other work. So the solution we came up with was writing a Terraform provider that would kind of fit the middle ground between doing everything and doing nothing. We had some initial discussions about whether the provider was going to deal with all the complexities in the same way that the CLI does. But my feeling really was that it kind of broke the idea of Terraform. So Terraform is great when you look at it from the perspective of the available providers out there and the way that different providers or outputs from one provider resource can be used as an input for another provider resource. You're really just standing on the shoulders of giants and building on top of prior art, really. So our solution was to create a very, very simple provider that has two data sources. And the only thing they really do is they output YAML strings. The benefit of this is that the provider can share the same code by importing it as a package as the CLI does. So whenever we update the CLI to generate the manifests in a different way or to add a different parameter, because the code is shared, all we need to do is just update this dependency, as both the projects are written in Go also. And we also then expose the same configuration parameters as the CLI bootstrap command does. So there isn't really a difference in functionality between the two solutions. So in this example here, we're going to show how everything kind of comes together with different providers. So here we can see the different variables that we have to configure: the GitHub user, GitHub token, repository name, a Git branch, and a target path, and the repository visibility. So these are kind of the default variables. If we check the main file, we can see that there are a bunch of providers. The GitHub provider we're using, and then the Kubernetes provider, the kubectl provider, obviously the Flux provider, and a Kind provider. A Kind is a project that allows you to run Kubernetes clusters locally in Docker. So we're creating a local Kubernetes cluster. And then you can see below that we're configuring the kubectl and Kubernetes providers to both connect to this local cluster that we've created. So below that, we're also creating a TLS key for SSH communication between the Git provider and Flux. And then we are using these custom data sources, the Flux install and Flux sync data source. The Flux sync data source is what configures the whole Git syncing as it takes the URL for the Git repository, and the Flux install contains the custom resource definitions and the controller components along with that. Then this is kind of where the complex parts happen. So we're using the kubectl provider which takes the output from the two data sources in raw YAML and applies it to the cluster. And then we're creating a Kubernetes secret with the TLS or with the SSH key. Last but not least, we're creating a GitHub repository and committing the files, as the GitHub provider allows you to commit files with Terraform, which is pretty nice. So if we're going to apply these changes, we can see that it's going to create a bunch of resources. Mostly these are just files. It's really not that much of an infrastructure Terraform example. And after a while, we should have everything applied and successfully created. So we can now see that we have access to a Kind cluster or a Kubernetes local cluster running. And if we jump into the Flux system namespace, we can see that we now have 4 controllers, as we've talked a bit about before about the Flux controllers. And we can also see that there is a custom resource called Git repository that is synchronizing from the newly created GitHub repo that we created, and there is a customization resource that's taking that content and applying it to the cluster. We can also jump into GitHub and see this new Fleet Infra repo, this bootstrap repo that we created, and the files that are now present inside of the repository. Here, the Flux components are committed, which is basically a bunch of YAML containing all the custom resources that we need for Flux to work. And this is kind of becoming an obvious why we want to automate these types of things. And then we have our sync components, which is, as you can see here, the URL is pointing back to the same Git repository as we are in currently. And if you'd want to make any changes now, you could commit additional manifests to this repository, and they would be pulled down into the cluster. Another nice thing with this provider then is that if you'd want to change the version of Flux that you're using, all you need to do is go into your Terraform, and in the Flux install data source, you could add a version parameter that sets the version of Flux that's being used. So there are some downsides with the solution that we have built today within the Flux project. The solution isn't really that user-friendly from a UX perspective. There's a lot of Terraform that has to be written, and a lot of providers that have to be combined with each other, and some Kubernetes magic that has to be done to get Terraform to ignore some of the changes that Flux does after the deployment. And we've been looking for a while now at how we can make the experience of installing Flux a lot easier. One of the things that I really don't like with the solution that we have built is how we, in a way, abuse a lot of the resource looping. I'll show a bit of that in the next slide, as we have to generate unique IDs for the different manifests that we're creating. And it's really taking the looping of resources to an edge where Terraform core starts to have some issues with dynamic variables, and it starts complaining about sometimes if you have an output that you pass to the data source that is computed, Terraform will fail because it doesn't think it knows the output of the data source before the plan. So you get all these really weird edge cases with the current solution. And the other thing is that people both either expect the data source to do more other than just output YAML, while at the same time, a lot of the bugs that are reported towards the provider are usually related to other providers, but it's mostly because of how providers are connected with each other. It's a difficult balance between making the use case or the UX very easy, while at the same time playing into the strengths of Terraform. And the strengths of Terraform is really the fact that there are so many providers out there already that do a lot of these types of things. So it would be very stupid from our perspective to re-implement providers that already exist out there. But part of the complexity, for example, here in this example, is how resources are looped. So this is from the demo that was just shown, and what basically is being done here is that the YAML that's outputted by the data source is in a multi-doc format. What that means is that there are multiple YAML documents within a single string. The kubectl provider does not allow you to apply these multi-doc YAMLs in a single shot in the same. That is different from how the kubectl CLI does, where the kubectl CLI allows you to apply multi-doc YAML without any issues. So what we have to do is we have to split the multi-doc YAML for this data source, the kubectl file documents data source, into separate YAML objects. The issue there is then that if we were to do a count and then loop on the count, the ordering of these YAML objects in this multi-doc YAML file would actually matter. So if the provider were to output YAML in a different order, it would cause Terraform to want to recreate all the different Kubernetes resources that are in the cluster, even if the actual resources themselves haven't changed. And that we've actually faced this issue initially before implementing this solution. So what we're doing here is really we're using a lot of metadata, API versions, and kind data from every manifest to create a unique ID, which is used as a key for the resource. This works, but yet again, it's not really an optimal solution. And that's kind of what's gotten me to think about what other options are out there in the future. So looking forward, really, I think that there needs to be a better solution for Terraform providers out there, or a solution for Terraform to deploy Kubernetes controllers into Kubernetes, because the use case or the people using these types of things are already out there. There are people creating Kubernetes clusters with Terraform, and they're obviously they want to install controllers into these clusters. One option might be to build more of a generic provider, Terraform provider, that would support multiple different controller projects out there, because they're all built on the same framework. So that would be an interesting solution to just, not only would we then support the Flux project, but we could support multiple projects without having to do extra work. Another solution that I have high hopes for is the Kubernetes Alpha Provider. The way that the Kubernetes Alpha Provider works today would actually work really nicely with Flux, as we could, and I've seen this being done, take YAML and generate HCL representations of the same YAML data, and then somehow export this to a Terraform module, for example. Terraform modules may introduce the same issues that Helm charts already have today, unless it can't be automated. But I think that there is a gap right now that has to be filled in the space of projects building controllers that are more close to infrastructure layers rather than application layers in a Kubernetes cluster, that a lot of people will want to deploy with Terraform, and maybe not even with Flux. Even there might be other controllers out there that people would opt to deploy with Terraform rather than Flux. So there is a large need of coming up with some sort of solution to enable this type of use case, and Flux would probably be the most extreme use case out there, as it has to integrate with Git, and you have to commit things with Terraform, which really doesn't make anything any simpler. And that was all that I had for today. Thank you for listening in. If you want to reach out to me, my contact details are down there. You can reach me on the CNCF Slack, or you can follow me on GitHub if you want to do that. Thank you all very much.
Awesome. Thank you so much, Philip, for talking to us about Flux CD controllers and Kubernetes with Terraform. Coming up next, we're going to have Tu joining us, and he's going to be telling us about Terraform visualization and how he learned to stop worrying and love the Terraform plan. And just to give you a heads up, we are going to have a Q&A block after this session. So we'll be watching for your questions. Thank you. And here we go, Tu.
Hi, my name is Tu, and I'm a product education engineer at HashiCorp. This is Terraform visualization, or how I learned to stop worrying and love the Terraform plan. Before we get started, I'm going to quickly go through the Terraform workflow. First, you write your configuration, then you plan it. Finally, you apply it. You want to view the plan before you apply your changes, just in case there's something unexpected in your configuration. And for some cases, this is reasonable. So in this example configuration, when you run a plan, it returns this. You can verify that, yes, I want to create a random name for my dog that is at most 5 words long. But in many cases, your Terraform configuration doesn't contain 1 or 2 resources. This is the plan output to spin up a VPC and an EKS cluster on AWS. It shows that Terraform will provision 51 resources, and even though you're expected to review the plan output for each one of those resources, how many times have you just entered yes and wished for the best? You can usually get away with this for provisioning new resources, but this can be a serious issue when you're modifying existing resources. How do you know that changes to one resource doesn't impact the other? You can use the Terraform graph command, and this is the graph command and the output for the random pet example. You can tell that the random pet resource depends on the random integer resource, which depends on the max length variable. This is a lot less useful for bigger configurations like the VPC and EKS example. This is what happens when you run the graph command for that. I'm not sure if you can see it, but that's a very zoomed out version of the graph it outputs. The SVG file that the graph command generates is over 22,000 lines long. If you actually look at the graph, you can see that there's still the resources and the dependencies, but the further you get to the middle of the graph, it's a little harder to differentiate between the dependencies from one resource to the other. This is the moment I really started to worry about the Terraform plan. For a good amount of the configurations out there, the plan was turning into a terms and conditions page where you're technically supposed to read it, but people just often check the box, or in this case, type yes and apply the changes. Rover fixes this problem. Rover is an interactive Terraform visualizer that gives you a high-level overview of your configuration and your current state. It does this by parsing your Terraform configuration and your plan. Rover is also open source and runs locally, so nothing is sent to a remote server, including your sensitive variables or your credentials. So let's see it in action. So this is Rover. There are 3 main UI components. There's the graph, there is the resource detail, and then the resource explorer. Let's look at the graph first. As you can see here, the graph is organized and grouped by the file name first. If there's a module, it's grouped by that. Last but not least, it's grouped by the resource type. So let's zoom in on this vpc.tf file. You can see here there is a resource, and since it's green, according to this legend on the left, on the next Terraform apply, Terraform will create this. This resource with a red outline over it is a data source, and then the VPC module down here has a bunch of resources associated with it. For example, if you click on the data source, you can see and isolate all the dependencies from and to that resource itself. So this data source is dependent on the VPC module. Also, if you click on the resource here, if you go down to the resource detail, you can see that it will present all the information about that particular resource. So here you can find the configuration, the prior state, and the proposed state. Since this resource hasn't been created yet. The prior state is empty, and then the proposed state shows what this resource will be after you run the apply. If you go down to the Explorer, this is very similar to the graph. Everything is organized first by the file name, and then it shows all the resources in the file, and it's organized by the file line number. You can expand this EKS module to see all the resources associated with that module. So now that you've seen what Rover can do, let's go back and see how it was built and how Rover actually works. So Rover is made out of two parts: the Go code that parses the configuration in the plan to generate the 3 unique data models, and then the front end that takes the data models and makes everything look nice. So we're going to first talk about the Go portion because I find this a little bit more interesting, and this is where the core logic of Rover actually is. So if you remember from the UI, there were 3 main UI components: the graph, the resource details, and the resource explorer. These 3 components correspond to the 3 underlying data models. So the resource details corresponds to the resource overview, the resource explorer corresponds to the map, and the graph corresponds to the graph. And just as a refresher, Rover generates a plan and parses the configuration, and it uses both the plan and the configuration to generate these 3 unique data objects. We're going to first talk about the plan because that sits at the core of Rover. Rover uses the tf-exec library to initialize and generates the plan. It then uses the Terraform JSON file to parse through this plan. As you can see by the data model on the left, this represents the plan. It basically has everything. So in addition to the plan values, it also has the resource changes, the prior state, and the parse configuration. While this plan file is great for Terraform, it's very difficult to go through and retrieve information about a particular resource. Say you want to find information about a security group, what you would have to do is go to plan values, then root modules, then resources, loop through all the items in that array until you find one that matches that security group ID, then retrieve those information. You would have to do the same thing for resource changes, prior state, and the parse configuration. This is where the resource overview comes in, and it addresses this problem. With the resource overview, you can filter based on the item type and the ID. So for that same example for the security groups, all you would have to do is go to the top level resource attribute, then retrieve all the values for that security group ID, and it will return the resource properties. If you notice, this resource is very similar to the plan data model. The only difference is the children attribute. So this children attribute is really useful for things like modules where it has a lot of children, and it's also useful for resources that has a count or a for associated with it. That way, all the children's or all the resources associated with that parent resource goes into the children's attribute. Rover also parses the configuration. So it uses the Terraform config inspect library to do this. And this is different from what's returned in the configuration field in the plan file, because this library tells you what file and what line each resource is defined in. This is really useful for our map and our graph data models. Speaking about maps, let's talk about maps. The map is a JSON object that you can go filter based on the file name first, then the resource. The parse configuration helps Rover retrieves the file name and the line number for each of the resource, while the resource overview data model populates the rest of the properties for each resource. If you look at the resource properties in the map itself, you can see how you can use this to visualize that row in the resource explorer itself. Last but not least is the graph. It uses the plan and the map to return a data model with nodes and edges. The map data model provides the change action and the relationships between the file and the resource. This is how the graph knows how to group the resources together and then what color each resource should be. The reason why we use plan is the plan filters out the real resources provisioned by the modules. The configuration from the map shows all the configurations in the modules, even the ones that may not necessarily be useful, because sometimes a bigger module may have resources where the count is 0. And if you remember from the UI, nodes are grouped first by file name, then by modules if there's a module there, and then last but not least by resource type. So after Rover generates the 3 data models, everything else is just window dressing. The front end is Vue, paired with this awesome micro CSS framework named Chatka. The graph is generated with Cytoscape.js using the clay layout. So with the default settings, Rover will generate the data model, start a web server, expose it on port 9000, and the front end pings the web server to retrieve the assets and makes it pretty. In the standalone setting, which is more suitable for CI pipelines, Rover would generate the data models, add them to a zip file. You can unzip these files and open index.html on your favorite web browser to interact with the visualizations. Rover is also a Docker image, so you can start using it even if you don't want to download the binary locally on your machine. Here are some commands that you may find useful. This command exports your AWS credentials into a environment variable, and then it launches Rover with the environment variables, so you can start using your AWS configuration to see what resources are modified or are going to be created or destroyed using Rover. You can run this command to start Rover in standalone mode. Last but not least, you can also use the tfvars file and the tfvar flag to override or to specify which tfvars file you want Rover to run. Rover is only made possible by great libraries like the Terraform exec, Terraform JSON, Terraform config inspect, Vue, Chatka, and Cytoscape. I had a really good time working with the open source libraries in the HashiCorp organizations. So if you have a chance, please go into the GitHub HashiCorp org and look at those open source libraries because there's quite a few gems in there. Thank you for listening to this talk. So here's a link to the repo with instructions on how to run Rover. Let us know if you have any questions, feedbacks, or new feature requests by opening up an issue or submitting a PR. If you like this project, please give it a star. And if you want to learn more about Terraform or Rover, go to the Learn file and the docs. They had really useful information about the plan file format and things like that. Have a good one.
All right, and we're back for Q&A. Thank you so much for giving your talk today and for joining us for a Q&A session.
Yeah, for sure.
So we had a couple. Oh, sorry.
So go ahead.
No, you. After you. I'm sorry.
Yeah, it was really fun to give the talk, and yeah, it's just been a really nice experience throughout. So thank you.
Thank you. I'm happy to hear that. So one of the questions we did get in chat was if Rover works with TFC remote backend, because they were hoping that that might make them able to remove their -auto -approve Terraform apply alias.
Yeah, so currently Rover doesn't work with TFC remote backends. As I mentioned in my talk, Rover parses both the configuration and the plan file to generate those 3 data models. It's something that I'm currently actively working on. And once that's out, I'll add the TFC remote backend part to it.
Perfect, that makes sense. I typed the other ones too already, and I'm trying to find them now because I made mistakes. But the next question that we had come in was, what are you looking to add next?
Yeah, so I think right now the most requested features are the TFC backend, but also people are using TerraGrunt for their Terraform configurations. So they want to pass in just the JSON plan file. So just working out how to do that. Making sure that the visualization looks better might be good too. Right now, the edges kind of overlap each other, which makes it a little hard to decipher. So maybe improving that.
Okay, that sounds cool. I mean, all of it sounds cool. Like I told you already offline, I was like, oh, I'm so excited for this talk, and I'm probably gonna have to go play with this after, but later. So the next question that I had come in was, what was the hardest part about making this look so beautiful?
It honestly wasn't that hard because like the open source tools out there were amazing. I was looking through the HashiCorp client libraries and the Terraform parser, and it just worked, which was amazing. And then the graph itself, Cytoscape is great. I used it to make other graphs. Initially, I thought it was going to be a lot more complicated than that. My first attempt, I had nested layouts. So the resources inside the files themselves were grouped by grids, and then everything else was grouped by this layout called DeGraw, which made sure the edges don't overlap with each other. But like it worked, but it didn't look great. Then I discovered Clay by accident, and it looks really good. So huge shout out to these open source libraries. And if you have a chance, go visit them. Also, like I just discovered this new like micro CSS framework called Chacha, and it's been amazing. So like, yeah, support open source.
I can get behind that. We actually had one more question come in, so I sent you the other ones, but not this one. So surprise, sorry. The last question, I think this will be the last question for our session, and then I'll be bringing the next speaker in. But the last one we had was, what was the biggest challenge for you in development of your cool project?
The biggest challenge was shipping. I think like up to a certain point, perfect gets in the way of getting it done. So I've been working on this for the last couple of months, but haven't really shared it with the community because I was kind of nervous about like my coding skills. So it was really insightful to just share it out with the community. The community has been really great, and yeah, like they've been supportive. And if you like the project, please leave a star so I know to invest more time into it. If you want more feature requests, like feel free to add an issue. And then I'm going to start working on like the contributing doc so other people can contribute to this.
Awesome. That sounds great. Thank you so much for joining us today. It's been a pleasure. I'm really looking forward to playing with this. So
sounds good. Have a good one. Thank you.
Thank you. You as well.
Bye.
And I'm just promoting our next speaker to a panelist in Zoom so that they can come on and join us here live. Just want to make sure everything is going smoothly. Hello, welcome.
Hi. Can you hear me?
Yep, I can hear you fine.
Thank you.
Are you ready to give your talk? Also, thank you for joining us today.
Thank you. Yes, I am ready.
Perfect. I will leave it up to you then. Take it away, and thank you so much.
Very quick. Hi, everyone. My name is Natalie. I am going to present today on releasing software without releasing secrets. Let's start. So a little bit about myself. I'm working as a senior engineer at HashiCorp on the release engineering team. I joined recently, less than a year, so it has been a really fun journey being part of this whole release engineering process. So today we're going to talk about the release management process itself. We're going to define what kind of secrets are release secrets. We are going to review the ways of managing secrets in the release workflows. And the demo will be around GitHub app that my team is designing to talk to Vault and use in GitHub Actions. So let's talk a little bit about the release process, what it is. Release process, it is a process of one of the processes of software development cycle. It is complex and contains many different steps. So one of the steps are release for creation and management, configuring and setting different tooling, not just CI tooling, but everything around the workflows and automation. Releases processes most of the time should be compliant with security as well as audit. And there is always work of making them better, faster. And today we're going to look into the release pipeline example. So on this slide, I have a quick example of the pipeline. Here, after code completion, pipeline divides in two parallel ones where we are releasing, for example, open source software in enterprise. It has different stages like task, signing, authorization, staging, and publishing. And on this slide, we can see that during all those different stages, usually, most of the time, different secrets are used. So for example, in the test stage, we most of the time probably will use GitHub token or code coverage framework for test. In cases of signing authorization, we most likely have to log into third-party frameworks like Apple or Windows signing accounts. And if we're trying to publish something to prod, we are most likely going to use credentials which have high access. They probably use only during this particular stage in this pipeline. So what are the secrets? Every day we hear a lot of talks about credential secrets. We use them at work. So secrets, basically, it is something that should remain hidden from others. And the definition that I prefer is secrets are not open to public and they kept private or not revealed. And examples are passwords, API, SSH keys, could be different certificates, could be a lot of different things. And why in this talk I'm trying to position release secrets as something different is because as a release team, we most of the time during our work in automation, we are responsible for bigger amount of secrets, let's put it this way. They most of the time related to different release activities. It could be a CI pipeline, it could be release publishing or other steps. And in certain cases, these secrets are related to higher activities, right? From the previous slide, I had a production example where production secrets probably have more access to the things, and all the secrets, they should be managed accordingly, hopefully with security policies in mind, with certain rotation, with certain limit accesses and auditing. So when my team started looking into the release management and our secret management, we decided to research what kind of common practices these days are present in the field. And the practices we saw were that some of the secrets are coded in the code, some of them are part of the source code management, for example, GitHub secrets, GitLab secrets. Some secrets could be stored in configuration files, built in container images, or stored in CI/CD tooling. So after we review all these practices, we were trying to find what are the ways for us to probably improve that situation, as well as set our own goals and come up with more secure way of storing our release secrets within the company. So the goals we try to achieve is discover secrets we manage, right? Some during long period of time, configuring different pipelines, some secrets get lost, some of them may be not rotated. So a good idea is to audit your own secrets, understand which one of them actually needed to be a secret, even that, and then enforce good practices, enforce rotation, enforce access management to those secrets. We decided to apply monitoring, auditing, and logging to the way how secrets are used in release processes, which will make this process more transparent to understand in the future if the secrets used appropriately, as well as do they really need to be secret, and if there's any anomaly happen, this process should be able to signal this kind of activities. And the other part that limiting third-party tools is a good practice, specifically if those third-party tools are doing the same job, like, for example, selecting one CI provider, or if the company uses multiple secret storages, it's a good idea to probably aggregate them in the same one tool. And one of the goals we set up, which is not the low priority, but it's just the one I want to highlight, is enable every team in our company to actually manage the secrets during the releases, because our team is trying to create this process, the workflow where everyone should be able to release at any time. And that's why we're hoping that every team can be independently and not blocked by any of that. So if there is a better way to do it, yes, we've decided that HashiCorp Vault is a perfect tool for the case. We decided to use GitHub Action with the GitHub self-hosted runners for all the automated release-related workflows in the company. Setting up Vault cluster, one of the ways that we think like managing actual Vault for release processes seems like a good goal. And for that, we're going to use Terraform module, which is going to be released in the future for enterprise Vault integrated storages, which is recommended by practitioners. During this process, there were different ways how different parts of the Vault implementation and, for example, GitHub Action could be implemented. And by this talk, I'm trying to highlight that there are different ways of making this happen. And the way we decided to go will be covered later. And one of the ways is no manual steps are always a better way. So here is the change that we decided to do, is changing the workflow, most likely adding one extra step where it's still a release pipeline, but the stage which will improve that is where after creating certain GitHub repositories, for example, for certain releases, we will have a specific service. In this slide, it is Lambda, which will be triggered by repository creation. And what it will provide us opportunity to talk to Vault, and from Vault creating secrets and role IDs, which in the future will be used by different GitHub action to use in certain workflows. And after that, implemented, publishing those releases. So apart from setting up Vault, we decided to enable app role within Vault. The reason for that is app role is a recommended authentication method to use with different machines or services, and GitHub Action is actually a perfect case for that. With the app role, we can configure different policies where a specific action acquiring the token can access a specific set of secrets related to this particular workflow. This will, moving forward, implementing the Lambda from the previous slide will help us to solve the problem of the secret zero, because getting the Vault token to authenticate to get the secrets has to be done also secure. So AppRole contains two major things that we wanted to add to the repo. It is role ID and secret ID. Role ID is identifier. It doesn't have to be super secure. So it is, it doesn't have to be securely stored. So it was a good idea to add it to every GitHub repo on the run when the workflow starts. And secret ID is a specific credential. And the interesting part is that it could be configured in different ways, defined, for example, by amount of the time pipeline is taken, or amount of the times it could be used within the workflow. So the step I described is adding Vault to the actual workflow. And our implementation steps were next. Decision was as I said, GitHub Action acquiring the token. It creates the role ID and the secret ID associated with this role. And then when the action starts, it can actually get the needed secret. And the question was how to actually do it, because there is no a good way or common way or practices on the market at this point. So we decided to build a GitHub app which actually do exactly this work. And this slide is just describing what the GitHub app will do in this scenario. It will add role ID and secret ID to each and every repo in the creation. And then the secret ID can be configured. As I said, it could have TTL or number of users. And creating GitHub app was an interesting idea. We decided to implement it with AWS and Lambda. Before using Lambda, we would create certain policies at Vault in order how the Lambda could be authenticated with Vault. It should have specific IAM role in the Vault cluster and deploy to the same AWS environment. And here is, I'm going to present a short demo just to describing what I was just talking about. So it is hard to reproduce it locally, but at this point, I already have Vault running. I went ahead and pre-configured GitHub app, which actually will be the app to monitor activities around GitHub organization. And on the repo creation, add role ID and secret for specific repositories. So over here, I already predefined all this needed information. And I'm currently using for the webhook the third-party service just for demo purposes. So over here, I can see all the activities on what's happening on the org level. And locally, I have my Lambda running. We will be monitoring Doggish org with a demo repo. It just so the way this proxy is working, I already went ahead before the demo and created different events. And here we can see that this repo was created. I can replay, excuse me, I can replay it, and replaying it meaning I can create certain events. Like here we can see that my Lambda just got request, and this request was initialization of repository, meaning create demo repo was created. Just to describe what just happened, excuse me, is that I have this demo repository, and if I refresh the page, we can see that some reason the role ID was already created, so the secret ID just got updated from Vault. And just to describe more in depth, I can probably describe by showing the code, where here in this GitHub app, we have just basic Lambda, and it implemented by handler. Our handler, after getting all the configuration for talking to GitHub repo, for getting information about Vault, it monitors all the activities. In this scenario, I try to reproduce the repository creation, which is adding repository action to the org. And basically this action over here is going to be this event, and the webhook monitors this particular event, and on adding the repository, it goes ahead and creates a secret, which was the current, excuse me, which was the role ID and secret ID. So this is basically the whole presentation. The summary we can have from it that the release process is not just managing the secrets, it's also auditing them. It's also making sure that specific secrets are used for specific job. And I guess thank you for listening to my talk.
Thank you so much for joining us today in your presentation. This was great.
Thank you.
Sorry, I'm just checking notes really quick here. Let's see. Okay. I believe, oh, we've got both our speakers here in Zoom for our next talk. So that is great. And they're going to be talking to us about maintaining a provider from the GitHub perspective. And we will be doing a Q&A after it.
Hello, everyone. Thanks for joining our talk. My name is Jeremy Udick, and I'll be joined by Keegan Campbell, and we'll be going over what it's been like to maintain GitHub's Terraform provider. Starting off with some introductions. So I've been at GitHub for about 4 years now. I originally started out in the infrastructure org and primarily working on data center automation, so taking care of bare metal, virtual machine, and containerization resources. I've since moved on to more of a product focus, and I'm maintaining our GitHub Pages product. As for my involvement with the GitHub Terraform provider, I've been maintaining this project over the past couple of years. I had originally gotten involved through my work with HashiCorp to deploy Terraform Enterprise internally at GitHub, and during this time, a maintainership position was offered. I remember thinking back on that, and I figured it was a good opportunity to grow my understanding of GitHub's products, APIs, customer experience, just overall understand what it's like to be a maintainer of an open source project. And I figured it would be a good complement to my existing infrastructure focus. Overall, just wanted to volunteer time to ensure the quality of this interface to GitHub stayed high. And Keegan will give a quick introduction as well. All right, so let's get this talk started. We've got 4 different themes to cover. First off is community, then we'll lead into testing, implementation, finally releases. Starting off with community, we'll cover topics like what it's like to inherit a provider, speak a bit about project governance, contributor onboarding, and round out with how we deal with opposing customer use cases. So this project started out within the HashiCorp GitHub organization, and contributions and support were mainly from HashiCorp engineers. And this was great because most popular use cases and resources were already implemented and being used. So things like repositories, teams, branch protection, anything that you'd want to configure for your team within a GitHub organization was just there. And it was also great because the provider was being meaningfully used by HashiCorp and other organizations at the time. So there wasn't really much missing, and it was a very comfortable starting point as a new maintainer. And as mentioned, this was my very first experience in a role like this, and it led to some growing pains early on. So first off was learning how to triage and prioritize issues, and just in general, what it takes to tend to a community. So what to read, what to listen to, and how to best reflect and express the community's needs through next steps. Also had to learn how to manage my own time. It's definitely an investment, and the expectations of the community originally didn't line up with the expectations of my time. So it was definitely an exercise in setting a sustainable pace and getting a good rhythm going that matched what the community required and what I was able to give. At some point in time, we migrated the project away from the HashiCorp organization and into a GitHub-owned organization called Integrations. And as part of that, we ended up reshaping the project a little bit, as you can see here. So it was mainly just fitting to the GitHub open source mold, matching on licensing, README style, adding a support disclaimer in there. So pretty cosmetic, but overall the process took a fairly long time. It was quite low priority, and getting reviewers and approvals along the way kind of slowed things down. But overall, we got it out there eventually. And another slip up that was made there was just communicating the change better. So when it did happen, it was quite abrupt for some users. And we had to publish documentation retroactively instead of ahead of time to help the community adopt the new project location. So on to some stories around contributor onboarding now. So furthermore on the community theme, let's start talking a bit about opposing use cases. So we've definitely had some friction here, and I believe it's a reflection of the complexity it takes to ship a feature for a product within the GitHub suite. So GitHub has a lot of use cases that it covers, a lot of personas that it tries to address, and some features only make sense for .com, so that's the github.com deployment, and other use cases may only make sense for the enterprise deployments, and some are just shared and don't cause too much friction. Some features are only available to some subsets of accounts, so users versus organizations. And then there's also some features that are only enabled for specific plans or tiers of plans. And originally, the provider's feature set and testing and release process were very much geared towards a single type of use case, which was the GitHub Enterprise Cloud Customer. And that's a .com deployment with paid features. So over time, as shown in this issue, the community began raising red flags whenever a new release would come out. And their concern was the release would be incompatible with their version of GitHub Enterprise Server. So this raised the call for better messaging around feature compatibility as things went out. And thankfully, the call was partially handled by the community. So it's great to see the community chip in and offer reporting, working solutions whenever there's ambiguity on whether or not something would work. And it's one of those things that really helped at the time. I think even to this day, we don't have very good testing around the full suite of enterprise server offerings. So it's just a very big thanks whenever someone can share their story and their experience with a specific version, and just give people a heads up and save them some time whenever an issue jumps up. Moving on to the users versus organization tug of war. So originally we had good support for organization accounts being managed by a full token or token with full admin scopes. And we've since grown that specific use case, and really has been driven by the community. So this example shows how we've added anonymous support, and just in general, growing different use cases has led to friction in the past due to changing code that wasn't very well tested. And got a couple of other examples here. Here we show a regression that was added when we made a change to our most common authentication scenario. So just the organization authentication method. And then we've tried to move away from that and abstract just organizations and individual users behind something called an owner. And by implementing that, it wasn't very well tested, and we ran into some detection issues whereby an owner was interpreted as a organization instead of a user. But those rough edges have been smoothed over, and yeah, it's a really good example of how someone can be affected because of how a product is being used in a use case that is completely different from their own. And that rounds out the community section. So let's move on to testing. So as for acceptance testing, we started out with a private Team City instance, and this was a resource managed by HashiCorp and used internally there. So I found that it had good highlighting of where and when a build broke, and it was a good enough early solution, but very geared towards internal use. So it did require coordination to update secrets, as I had limited access, and there was no contributor access to the feedback that the system gave. So a lot of the testing results would have to get proxied back to the community through a maintainer. Eventually, we migrated to a dedicated GitHub action, and I'll show that right here. And this is primarily to provide contributors with a feedback loop for their changes and give maintainers better access to secrets management. Throughout the lifetime of this action, we've done things like add label-based runs. So at some point, we would be able to just pick a label from the PR page and add it with a specific prefix, and that would kick off a subset of tests. That evolved to detection-based runs, where you didn't really have to figure out the prefix you were looking for. The code would do it itself. And then we also added multiple test suites so that we would test against github.com deployments. And then at one point, we had a test instance up for GitHub Enterprise Server, but that just became too expensive to run. Returning the slides here, we also ended up shaping our test cases a bit differently from other providers. And our main focus was to make sure that we could test the documented HCL that would come along with a resource. So we made it so that we're not building up a string here, but instead just pasting in a block that we could paste into a Terraform config file and run it. And then we also made sure to address the different use cases explicitly and ensure that we could test against them. So another characteristic of our test code is it's highly duplicated, and the repository resource is probably the most amount of duplication. It just makes it very easy to add a new test, to not really couple tests together, and then also readability. It makes it a bit easier to understand what's going on within a single test. So there's not too many of these files, but it definitely gets a bit hairy with the amount of duplication. Looking for a specific test can be a bit difficult, and we started to group related features in a single test. So that's helped, but overall it's quite verbose. And the final little pattern that we've also jumped into is investing in this examples directory. So this allows us to test bugs that may be very difficult to exercise through the normal testing route. And it doubles as documentation as well. So if there's any big new features that land, it's good to give possible users a nice working example to start off with before they jump into their own implementations. So that's that leads us into our lessons learned for testing. And I could say that we went through a period of just gaining confidence with the project itself via the tests. And this was early in my maintainership story. So the pace of releases ended up being traded off here as I was investing in tests. So it was kind of a time-bound effort, and it was a good learning experience to scope out the level of investment that was needed to keep tests stable and usable. But we ended up scaling back investment on testing and just relying on documentation. So getting strong contributor documentation on how to run tests locally and set up a proper testing environment was kind of the pragmatic choice to keep the project afloat and moving without investing too much time in keeping tests alive. Some other little tidbits of knowledge. Tests are written with an understanding of them not being free. There's a reliability cost to it, mainly due to API limits and such, but we try to just add tests that cover most important and used use cases, and just want to decrease the probability of introducing bugs, but not make it zero. The investment to make it zero might be a bit too much, and it tugs on reliability of the test suite as well. This is definitely not where the project wants to be, but it's where we've settled with the amount of time afforded to it. So being pragmatic has helped us here. So with those lessons learned in testing, we can move on to the next section, which is implementation. All right, so following along with the implementation theme, we'll discuss what it's been like to consume multiple versions of an API. So at GitHub, we've got a couple of versions. We've got the V3 REST API, as well as a new V4 GraphQL API. And the Terraform provider for GitHub had originally shipped with only REST implementation, which is great because it's a simple mapping to Terraform's CRUD style operations. But moving off of this over time became apparent as we had a couple of motivations. For one, features started to be released only to the GraphQL API, and some of those features were very highly coveted by the community. And then on the other side of things, the V4 API promised a more lightweight way of retrieving data, which has benefits for rate limiting. More on that later, though. So once we decided that we did want to pick up this new interface, we had a few different adoption paths ahead of us. There's some discussion around that, and one of the suggestions that came out from the community was to switch to a completely new provider or publisher, an additional provider with a beta suffix to it. So this would have allowed for complete separation between development of a new feature and graduating over to the kind of more stable provider that was in existence. We ended up upgrading just a single resource as a starter, and the resource that we chose was highly used, so it was fairly risky, but upgrading to V4 allowed us to get a highly coveted feature for GitHub branch protection. So it was the way that we pursued. So adopting the V4 API on a resource by resource basis is good for gradually adopting the new API and allowing us to evaluate compatibility, as not all resources perform the same. And just a quick look at the implementation. So we added multiple clients instead of overriding the additional one. So this allowed us to keep using the V3 client and pick up the V4 client for whichever use cases made sense. So all resources within the project could just lean on one or the other client, or maybe even both. So with that gradual approach and the flexibility and the implementation, we still ended up shipping a few regressions reported by the community. So after migrating our branch protection resource, we got a bunch of issues that came out of it. And as you can see here, there's issues with the overall runs being slow. And I think there was some functionality bugs as well. So shipping it gradually was a good idea, but we still ended up with things to clean up afterwards. So one of the tactics that we used was just to kind of roll forward, but also provide an option for people that didn't really need the new implementation, was to ship just a pinned v3 resource for GitHub branch protection that could be used by some community members. And this would allow them to move forward with all the other improvements within the project without having to wait on or fix their branch protection rules. All right, moving on from consuming multiple API versions, let's talk a bit about API rate limiting. So there's a couple of ways this affects the project. One is on the acceptance testing side of things. We have a limited throughput that we can get through because of the rate limiting that our authentication provides us. And that mirrors the same types of issues that users of this project face when they try to push through large runs of against their infrastructure. So rate limiting is kind of just what you got to deal with whenever you're using cloud resources, or really any resources, because there's always limits. GitHub has a limiting implemented as a shield for us, and it really helps us keep load predictable on our infrastructure and keep a shared utility up for everybody that needs to use it. In practice, using the API, you can expect that searching would be the most expensive operation, and then that would be followed by just like targeted REST calls that return JSON blobs, and that's followed by GraphQL queries that are very targeted as well to return an even smaller amount of data compared to the REST API. So some mitigations that we've added, I can show a bit of code here. So we added a rate limit transport early, like very early in the project, as I think the goal here was to make sure that Terraform runs would complete, and the sporadic errors that would get thrown back due to hitting limits in the API would be smoothed over through retries and inserting delays. So here's an example of how we inject delays during our write operations. I think there's just like a quick little sleep here, and we respect whatever GitHub recommends as our retry after value. And then for read traffic, we attempt to use caching best practices by leveraging the etag header here with the if none match directive. So in the best case scenario, we just get a 304 not modified response back from GitHub instead of a full payload, and that might help us out with our rate limiting budget. And we've also added the GitHub app authentication method for the provider, which has a better budget for API use. And throughout all of these efforts, we've received mixed feedback from the community. In practice, there's a fair amount of use cases that still stress the API rate limiting mechanism, and it happens enough that whenever new features are being rolled out, we should be reviewing for the impact on performance, and really actively trying not to do too much with the API or be as efficient as possible. Just a quick example of things that have popped up in the past. So here we see that our GitHub repository file resource has suffered from limiting in the past as well. And it's a good reminder that the mitigations that we do have in place, they're not one size fits all. We definitely could benefit from exposing tuning of this mechanism, as some users are able to just crank up the parallelism, and they just don't have a ton of resources to manage. So they'd be able to really speed up their runs without having to go through the best practices that GitHub recommend. So that rounds out the implementation section and types of things we've had to battle over time. Next, we'll move on to releasing. All right, so continuing on with the releasing theme, let's talk about tooling and how it's grown up over the past couple of years. Originally, when picking up this project, the workflow was to ping in a shared Slack channel, and other provider maintainers were there, as well as HashiCorp folk. And depending on the day of the week and the size of the request, maybe you'd get your release out the same day, but so there'd be definitely times where there'd be nobody around and you'd want to push a release, but you needed that coordination. So it was definitely something that was a pain point for the operators of the process, and maybe a little bit for the consumers of the process. And it definitely was an unscalable way to trigger releases. So HashiCorp began working on better automation through the Terraform registry. And just a quick visual here. This is what we ended up with. Here's our provider on it. And you can see that there's good documentation integration with it. So overall, I think this was a great success. Adopting it was a little bit rough for us, but getting onto this tooling has really helped us out with our rate of releases and our ability to size releases. Another benefit of working within this community has been receiving communications of the best practices for the provider community. So in this example, an issue I think was open in various providers to adopt a new target, a build target that moving to the latest release of Go had unlocked. And staying up to date with that kind of stuff, it's not something that I personally have a ton of time to do. So I really do appreciate it when this type of information comes up into my existing channels that I watch. So this just showing up as an issue in the Terraform provider GitHub repo was great. And I really appreciate that these community-wide efforts get spanned out to our individual projects. So tooling has definitely been upgraded over the past couple of years. And to go along with that, I think it's unlocked our ability to change philosophies around releases. So I remember early on having to dig through just a large release to go and find out what breaking change was in there, or what commit broke a specific use case. And being able to advance in release tooling has allowed us to ship smaller and more frequently. And on the flip side, that also allows us to isolate risky changes, so that if something is going to go out that maybe wasn't well tested, or there are willing testers out there that just want to play around with it, we can just ship a small release now and really shield people from large breaking changes that are very difficult to backtrack from. Another thing that we've tried is bundling related changes. So our project tracker makes use of labels fairly well, and we label our issues by resource. So we have a pretty good understanding of which resources are lacking and where. And the goal there was to ship releases based on resources, so that we could tackle things without context switching too much, or maybe provide some type of wholesale change that fixed multiple issues at once. So that was the aim, but it worked well for the small resources. Over time, we just ended up continuously getting very random contributions and PRs, and we switched the aim to just kind of keep the queue moving. So instead of dictating what would change, just be responsive to whatever showed up and tried our best to batch them up. And I believe our improvements to contributor documentation might have helped increase the rate at which PRs were showing up, but who knows, it could be just more adoption as well. So yeah, and I think that's the current state of our philosophy to this project is just keep the queue moving. We don't want to unnecessarily block momentum. Even if we ship something that's not really ready, it'd be quite easy to test things out and recover from it with our increased ability to ship. So keeping the queue moving is definitely what we've settled on nowadays. And the very final thing is just staying humble and empathetic. I'm super glad to have the opportunity to grow as a maintainer, and I'm really appreciative of the community's patience as this has gone on. And on the other side of it, it's just being empathetic to various use cases. This is a shared provider. It's got a lot of different environments to work in. And just being flexible to all of those needs is really important, as we're not trying to exclude any uses of GitHub. We have a fairly flexible product that we have to give access to. So staying responsive is very important as well. And with those learnings on releasing, that can close out this section and most of the talk.
Hi, I'm at KF Campbell, or Keegan Campbell, and I'm a software person at GitHub. I work on the Frameworks for Services team, which means I'm primarily working on internal tooling for Go and Docker, as well as getting loaned out to various other product teams periodically. I've been in GitHub for a little over a year and 8 or 9 months or so. I got started working on the GitHub Terraform provider when Jeremy put out a call on an internal Slack channel for people who wanted to write Go code for fun, I don't know, about 6 months ago, and it really has been a fun experience. In general, I'm knowledgeable about Go, Docker, and Azure Resource Management. Let's talk about our contribution model on the GitHub Terraform provider. The provider's project governance is an interesting situation. We are not paid to work on it, and we don't really get reserved work time for it either. We just happen to work at GitHub, use the provider, and care about others in a similar position. We've taken the stance here that our maintainership is primarily centered around nurturing the community rather than being drivers of specific changes ourselves. In practice, this means the majority of our time is spent reviewing, testing, and merging community PRs. Our goal is to balance safety and stability with an openness to contributions that benefit a wide variety of use cases. In order to grow involvement with project stewardship, we've primarily looked internally to Hubbers who like to write Go. We've established our own Slack channel to foster communication separate about the provider, separate from general Terraform discussion at the company. And we've also scheduled a recurring get-together to discuss the project, pair on code reviews, team up to tackle bug fixes, and talk about feature requests from customers. As I've mentioned, most of the new feature code is provided by users of the provider, and the door is always open for new contributions and contributors. One thing we have tried to take advantage of with the Terraform provider is that onboarding new contributors is a great opportunity to improve the state of your services documentation. When anybody is taking the time to learn your project and is starting from fresh eyes, you can do like we did and easily use that effort to make it easier for the next person in their position. Let's talk a little bit about testing the Terraform provider. When I think of types of testing for a project, I tend to bucket them into either unit tests or acceptance tests. Terraform's plugin testing overview, as you can see here, references both unit tests and acceptance tests, but spends far more time discussing acceptance testing. Terraform's testing patterns documentation deals only with acceptance tests, as they comprise the bulk of any provider's testing strategy. We make every effort to adhere to the recommendations given there and provide standardized test helpers to use, which Jeremy will talk more about in a moment. In general, for our provider, unit tests tend to not be super relevant unless they're testing the functionality of some sort of helper. We tend to test most behavior with what we call acceptance testing, but is also known as functional or integration testing. We require these kinds of tests for all applicable functionality that is introduced to the provider. Manual testing of added or change behavior, which is a type of acceptance testing, you could argue, generally accompanies a change as well, but is not as specified. Maintainers and contributors should exercise the affected workflow with several different parameters as applicable when validating their changes, both in acceptance testing and manual formats. Now, there are a couple of interesting things about our testing strategy that are specific to the GitHub provider. For starters, GitHub has a couple of different products the provider works against. Regular GitHub, which is what we call .com, as in github.com, as well as both managed and self-hosted variants of GitHub Enterprise exist. It's not required to be an employee to work on the provider or test against enterprise instances, but it definitely helps to be able to access internal tooling to be able to spin up these instances for testing. Another interesting thing is that there are multiple different ways to authenticate to GitHub. As you can see here, we can have anonymous users performing read-only actions, user personal access tokens, and GitHub app authentication for each type of client that we use. Any of these methods can perform actions on a user's content or an organization's content. Because of these complexities, we occasionally run into bugs or obnoxious trade-offs about authentication fallback. Jeremy will take over now to talk a little bit about the way in which we've managed the orchestration of our test suite runs. The joy in implementation might be my favorite part of the product and software in general, really. And we'll talk now a little bit about some of the fun and interesting challenges we've had in the past with the provider. In general, we'll discuss three main pieces: tactics for smoothing over the rough edges of an API and fitting them into Terraform's plan, apply, and destroy pattern, consuming both GraphQL and REST interfaces, and we'll discuss problems with rate limiting. Now, Terraform's primarily plan, apply, and destroy pattern fits some types of resources quite well and some types of resources not well at all. As an example, let's consider the pull request feature, which you can see was first proposed here in October 2019. Now, how should we treat a pull request on this project? The data is kept around indefinitely by GitHub in a close or merge state once the pull request has been dealt with. Should we offer a pull request resource with a status that tracks created or merged, along with exact attributes to specify the content at each commit, like is proposed here? We ended up going another path instead, which is more oriented around declaring a pull request on top of a repo, as you can see here, with a repo and branches based references, and then providing only a title and body at creation time and letting the repo attribute handle all of the actual file changes. Another challenge we've dealt with recently is working around archived repositories. In that case, the problem statement is basically, given that GitHub allows both deleted and archived repositories, what should the action taken be when Terraform destroy is run? Do we destroy or archive your repo? The approach decided upon was adding an archive on destroy flag to the repository object, which the provider can then use to determine the desired action to take for Terraform destroy. We've also seen, and here's an example of that archive on destroy flag from the pull requests. We've also seen some friction with GitHub repository visibility options. The valid states for GitHub repo visibilities are public, which means anybody can read your code, issues, and PRs, but write access is managed by the repo admins. There's private visibility, in which only the repo admins and those they delegate access to can read or write to the repo. And recently is a new feature called internal visibility, which is an organization-only concept that gives your organization members read-only access to the repo by default. We've had several bugs as a result of this feature, notably issue 580. In general, sometimes peculiarities of Git or Git constructs require us to be creative with the provider in order to neatly convert HCL files into GitHub resources. That is one of the more fun and challenging parts of being a maintainer. Another interesting facet of life for the provider concerns the API versioning that we are dependent on. let's talk for a minute about releasing new versions of the GitHub Terraform provider. Specifically, we'd like to go over a typical life cycle of a feature, the evolution of our release tooling, and the evolution of our release philosophy. Most frequently, feature requests come in via GitHub issues, and usually the community proposes fixes in the form of PRs as well. Frequently, contributions come initially with less testing than we really want, so that's a common request or contribution from our side when reviewing and shipping PRs. As a group, the team that maintains the provider meets up once every other week, but may respond to issues and PR feedback more often, especially since we're working in GitHub all day. A typical workflow might begin with the user of the provider opening an issue and later providing a PR to resolve their or another's issue. As a team, we will review the PR and go through some testing scenarios together, and occasionally this will include using multiple versions of a GitHub Enterprise product in order to make sure we don't break features for our enterprise customers. Now, one of the external factors that can limit our rate of feature adoption is the API support. You'll notice that of the two main Golang GitHub APIs, Go-GitHub and GitHub v4, which is the GraphQL client, Go-GitHub is the REST client, neither of these are owned or maintained by GitHub. We're in sort of a weird position this way, in which we work on the underlying project, which is then built upon by other folks, and then we use that platform to build our Terraform provider. Because of this, we occasionally have to wait some time after a feature launches on GitHub in order for the new API to gain support from the wrappers we use before our Terraform provider can adopt it. Once the team has reviewed the PR and the acceptance testing is in an appropriate place, it's time to pick an upcoming release, which Jeremy will talk about more in a moment, and ship the new code. In our session today, we've talked a lot about what it takes to maintain the GitHub Terraform provider. We try to foster community with a project, governance, and developer onboarding strategy that is focused on contributions from users of the provider. Occasionally, this means being forced to reconcile opposing customer use cases, and we've experienced some growing pains learning to be a dependency for others. Our testing strategy on the provider has evolved over time, and we attempt to adhere to HashiCorp's best practices when Terraform testing. GitHub-specific behavior, such as various enterprise flavors and authentication types, complicate matters a bit more. In our implementation section, we discuss tactics for smoothing over the rough edges of an API, consuming GraphQL versus REST interfaces, and rate-limiting challenges. Together, we've examined our release strategy, the lifecycle of a typical feature, and the evolution of both our release tooling and release philosophy. Jeremy and I would like to thank you for coming out today. If you have any questions or comments, we'll be around virtually after the talk, or you can reach out to us on GitHub. Again, I am at KF Campbell, and Jeremy is at JC Udit. Thank you again, and I hope you all have a nice day.
All right. Thank you so much for your talk today and for joining us. We are now live for a Q&A session.
Glad to be here. Thanks.
Just checking. I think we got a question in chat earlier into your talk, wondering what the URL for the acceptance test repo was.
Yeah, we use a dedicated organization for acceptance testing, and I stuck the action workflow in there. It's probably not the safest place to put it, but we'll add a link to the chat, and it's just Terraform testing / acceptance tests.
Perfect. Thank you. So one of the questions that we did have come in through back channel was they were wondering if the provider development was affected as Terraform was on its journey to 1.0.
So I can't say it has. We've been pretty late to adopt the newer changes, and that's usually because we want to stay back with the community. So it's usually the community that brings forward the new features, and we're pretty open to it. But we're watching and excited for any changes that we can eventually adopt.
All right. And another question that we got was, what, if anything, could be improved in the Terraform SDK testing framework from your experience using it?
From our perspective, I'm not sure if this is something that affects everybody, but if there was more attention paid towards the transport layer. So we have a custom implementation that was put in, but I'm not sure if it's something that other providers have had to implement as well. But things around retries, obeying retries, and just making sure that rate limiting doesn't affect the overall run. Seems like something that most APIs would be subject to. So maybe things along that line would be nice.
Okay, I guess there was a lot covered and it was really cool to listen to. Is there anything that you didn't get to cover in your talk that you would have liked to?
Keegan, what do you think?
I can't hear you. Oh, yeah. Not yet. Wonder why. Okay, no worries. I guess, Jeremy, did you have an answer for that one while he's fixing his mic?
Well, I think the future, really, where it's going, and I guess there's not much I can say about GitHub's plans in the future, or there's definitely things I'm excited about, but yeah, just the future of the Terraform provider, I can totally see it blending in with where GitHub is going. So just overall excited to follow that story.
Check. Are we any better now?
Oh, I can hear
Okay,
you. You're a little
yeah.
bit quiet, but I can hear you.
Okay, wonderful. Thank you. Apologize for the difficulties. I like the categories that we covered, and I think if I could adjust anything, it would be fun to go more in depth on what we did, especially some of the code investigations that Jeremy discussed. I found super fascinating, and I think that would have been the direction I would have wanted to explore further.
Perfect. That makes a lot of sense. I think that actually brings us to the end of our Q&A block for today. So I just want to take a moment to thank you so much for joining us with your talk and for coming on to answer some questions with us today. Yeah, thank you.
Yeah, thanks for joining us. It was great.
Thanks, and have a great day. Yeah, thank you. Perfect. So coming up next is going to be Patty Carver, and he's going to be talking to us about going into the unknown.
Hi everyone, welcome to Into the Unknown, a talk about Terraform's type system. My name's Patty Carver. I'm the engineering lead for the Terraform plugin SDK team at HashiCorp. I use he, him pronouns, and I'm at Patty Carver on Twitter if you would like to heckle me about this talk. I want to talk today about types. I want to talk today about types specifically in the context of being a Terraform provider developer and trying to understand how these types that I enter in my schema are going to translate into a user experience for a Terraform practitioner. Because I think that's a piece that's missing from our documentation. And as we build out more and more software, as we release things like Terraform Plugin Go, I think it's something that Terraform provider developers are going to be exposed to a little bit more. Helper Schema and Terraform Plugin SDK v2 both try and obscure some of the information about types from Terraform provider developers. It smooths over everything a little bit. As we kind of get new modern Terraform provider development SDKs and tooling available, we're going to expose those a little bit more. And so I want to talk today a little bit about an overview of what Terraform's type system is and some of the concepts and tools that you'll be able to play with soon. Let's start with the old standby, the stuff that you can do in SDK v2. There's strings, numbers, booleans. We're all familiar with them. Fun fact, Helper Schema has the distinction between floats and integers, but Terraform doesn't. Terraform doesn't actually care whether it's a float or an integer or infinity. It's all a number to Terraform. We also have lists and sets, sort of. I'll explain the sort of later. And then we've got maps. Maps are also a sort of. We'll get to that in a second. And that's the stuff we know, but there are some lesser known types. For example, here's an object. An object is a lot like a struct in Go. It's got a set number of attributes, and those attributes have a set type. And the attributes are accessed by using a string name. If you remove an attribute, or if you change the type of an attribute, it's suddenly a different type, just like in Go. Tuples are a lot like objects, but they're a list format. So instead of being accessed by a string name, they're accessed by an integer position. So it still has a set number of attributes, or set number of elements in this case. And the elements still have a set type on them. And if you change either of those things, it's not the same type anymore. But now instead of having a string key associated with them, they're just put into a list syntax. Now, remember how I said that lists and sets were only sort of lists and sets? Terraform parses the configuration without any understanding of what types the provider developer has specified for those fields. And so it parses it into the most permissive types that it can. So anything that looks like a map or an object is going to get parsed as an object, because every map can be represented inside an object, but not every object can be represented inside a map. Similarly for lists and sets and tuples. So those are sort of sets and lists and maps, but really Terraform understands them as tuples and tuples and objects until it gets the type information back from the provider, and it's like, they expected a list here. I'm going to convert this tuple into a list because all of the elements are the same type. If it can't do that conversion, it throws a syntax error for you. Very helpful. There are also the ability to have maps of not strings. I know that helper schema in SDK v2 expects all the values in a map to be a string. That's not actually necessary. They all just need to be the same type. That's all it takes. And so here's a map of numbers. Terraform doesn't really care. You can have a map of list. You can have whatever complex weird type you want. Doesn't matter. Terraform's just happy. Helper schema in SDK v2 is where the limitation on using only strings as values for maps comes in right now. And then finally, there's this weird dynamic pseudotype. It's just one weird type. We're going to talk about that in a minute. We're going to establish some context. We'll come back to it. Stick a pin in it. All this is neat, but why do I care, right? I want to talk about how you're going to see this data. There's a couple new concepts that I want to introduce in this talk, and to do that, to examine what values these things can hold. Because Terraform sends over whatever's in the config, state, and plan. If you have a field that's a number and the user enters 1, 2, 3, you're going to get 1, 2, 3 in the provider. Usually. There are two edge cases, and those are the concepts I want to talk about today. What if there's nothing in the config? The user just doesn't enter a value. It's an optional field, whatever. They just don't put anything in there. What do you get as a provider at that point? What gets sent over the wire to you? Well, you get what we call the null type, or the null value, sorry. You get a null value, and the null value is just, I don't know, there wasn't anything here. It's the absence of a value. And I want to pause before I introduce this next concept. I want to talk about interpolation and the graph. And you'll see why. It's going to be important in a minute, but I want to explain why this next concept is necessary. Let's take a look at this Terraform config. It's a simple disk. It's got a name, size, and image, right? And then it's an instance that's using that disk. It's attaching the disk to the instance. So Terraform's going to go out and create the disk, and then it's going to create the instance. And we all kind of are familiar with the syntax. It's a pretty common use case of Terraform. If we apply that, we're going to get this plan. And the idea of the instance is going to be, or the disk is going to be known after apply because it's something that the API generates, sure. And therefore, the disk value for the instance is going to be known after apply as well. What I want to know is what gets sent over the wire in that case. What does Terraform send to the provider for that known after apply value? Because we have, for example, in SDK v2, customized diff. So we get the opportunity to modify the plan before it gets presented to the practitioner. How does Terraform represent those values to us? Well, it's time for us to go, and you can all say it with me, into the unknown. That's what we call an unknown value. That's Terraform going, I don't know. I'll know eventually, probably after apply. I'll get you a value at some point for this. It's an unknown value. And so we're reaching the end of the talk here. I want to talk about dynamic pseudotype because I promised we would get back to that. We're running out of time. Let's get to it. What is a dynamic pseudotype? It's an unknown type and an unknown value. That's Terraform saying, look, not only do I not know what value this is, I don't even know what type it's gonna be. Who knows? It could be a list, it could be a string, it could be an object. Who knows? It is the empty interface of Terraform. They take on whatever type the practitioner or provider uses. So if you put one in your schema, for example, you send it back down to Terraform. Remember how I said Terraform parses the config and then converts the types into whatever the schema type is? It can't do that in this case. It's saying, just give me whatever was in the config. I don't care about what type it is. Just give me whatever data they give you. Send it back. Similarly, when you're setting values in state, if you've got a dynamic pseudotype in the schema, you can set whatever type you like. It can be a string, it can be a number, it can be a Boolean, object, doesn't matter. Terraform doesn't care. However, once written to state, they're not dynamic pseudotypes anymore. Just like when Terraform parses it and compares it to the schema and decides what type it should be, it's not a object or a tuple anymore. Sometimes it's a set or a map. They're not dynamic pseudotypes anymore. They've taken on a type. They've become known. And so you can't change it once it gets written to state. There is an exception to this. Data sources replace their entire state object on every read. And so they get to change what type is in the state on every read. So they can use a dynamic pseudotype that goes from a string to a Boolean to a number to an object. Doesn't matter. That was a quick introduction to Terraform's type system. I hope it was valuable. Thank you so much, and happy HashiTalks.
And we are live for Q&A now. Thank you so much, Patty, for joining us today, and welcome.
Thanks so much for having me. Can you hear me okay?
Yes, I can hear you. Perfect.
It worked.
I always love watching everything you talk about, and like it's just always just like, oh my God, he has so much to say, and it's great. It just
Thanks so much. I always love coming to your events. You guys do such a great job with all of these 18 hours of talking about developing stuff.
What even is sleep?
Wild.
Yeah, I was on for kickoff and I'm still here, so it's going good, but it's getting harder to ask questions. I'm like, I want to ask insightful questions, but mostly my questions are things like, oh, you might as well just do that anyway. So you talked a bit about kind of going into the unknown, and I guess what is one of the more tricky parts of working with unknown values?
Knowing where they're going to crop up, because you want to work with these values in a way that you can access them from Terraform provider code. But normally when you're working with your provider, you're trying to get regular Go types that you can send to an API or that you can manipulate programmatically. And so the fact that they can kind of appear anywhere and it's not super clear where they can appear, it's easy to forget about them, and you're going to run into problems when you do that. And so trying to find the right balance of checking for unknown types when you need to worry about them, without checking for them all the time and losing kind of the forest for the trees of your code, if that makes sense. It's been a really interesting balance for us trying to figure out how to strike that.
Yeah, that definitely makes sense. So a question I had come in through a back channel was, how does Terraform decide what type to map it to, or does it decide that at all?
It's based on what the Terraform provider says. So the provider sends back a schema, and the schema is like, hey, I've got, I expect this type for this field. And that's the provider developer's job, is to pick that type at that point. So then Terraform gets the type from the configuration, parses it, and it just chooses from any type that can hold that value. There's a set of defaults. We use objects and tuples instead of maps and lists and sets. But then it checks that it can conform, is the word that the Terraform core library uses for it,
does it conform to the type that the provider developer sent back? And if so, we're going to translate it into that type. And I'm definitely going to be getting angry DMs from Terraform core people in like 5 minutes being like, that's not how this works. I kid, they are lovely. Terraform core people would never send me angry DMs. Yeah, no, it's kind of a matching process where it reads it in as something that Terraform can reason about, and then gets information from the Terraform provider and sort of matches those up if it can. And if it can't, that's where you get validation errors.
So I've got one question left for you and then we'll wrap up. But the last question I have is, what does Terraform's type system do well or not so well?
Terraform's type system is really great for the purpose it was built for this situation where you've got a graph and you're going to be filling values into the graph over time. Like it's fantastic for that. What does it do not so well? I've seen the places where I've found myself running into the edges of the type system have been in places where I wanted a less strict type system, where I wanted to be able to create a map of different elements, or I wanted a list of different elements where, tuples can have different types in it. But there's only a set number of them. You still got to have that statically defined type. It's the situations where you want to have these dynamic types where it's like, I want a list. I don't know how many items are going to be in it, and I want it to be of any of these 4 different types. You're going to run into problems with that because Terraform's type system doesn't really know how to model that, and it wasn't really built to model that. Because that's not kind of how Terraform sees the world. It sees the world in these strict definitions of what resource boundaries are. So yeah, if you're looking more for like, I always compare Terraform's type system to Go's type system because they feel very similar to me. But if you're looking for, say, Python's type system, you're going to run into some trouble there.
That makes sense. Well, that brings us to the end of our Q&A time. So thank you so much for joining us today and coming and giving a talk. It was lovely as always. It's great to have you on pretty much whatever we do, whether it's HashiTalks or community office hours.
Absolutely. Thank you so much for having me, and happy terraforming, and I hope you have a great rest of your HashiTalks.
Thank you. Speaking of HashiTalks, there is still quite a few more talks left today. So we're going to be giving you a 10-minute break for everybody watching. So we're going to be throwing over to a 10-minute break, and then Rosemary and I will be coming back to MC for our next block of talks. And yeah, thank you so much for joining us, and see you in about 10 minutes, everyone.
Recording in progress.
Hi everyone, my name is Emily. I'm a software engineering
Perfect. And we are back from our break. And as you can see, we've now got another MC here. So I'm excited to welcome Rosemary on to MC with me. It's actually our first time MCing together.
I know. It's not like we collaborate on anything else, but for some weird reason, we've never introduced speakers together or coordinated event stuff together. I don't know what it is. Anyway,
yeah, we always end up on different stages or tracks. Like
I know. I am very glad to be pairing with you on this. I'm very excited. I had the chance to do a panel earlier today with Jeremy Udit, and I now got to see his talk, which went into more detail. So I feel like that continuity or that loop has been closed. That was pretty great. And I'm really excited that we have many, many, many more speakers continuing.
Me too. So I guess so that you don't make the same mistake that I made earlier, do you want to do an introduction of yourself and say hello as the new MC coming on?
Yes, that is correct. Hi, I'm Rosemary Wong. For those who are in the Twitch and YouTube, hello. Appreciate your interactions. I did ask a question in the chat, and we have discovered there is apparently a quite dead language named T. So today I learned. This is excellent. So I cover primarily Vault console, but you'll see me talking a lot about Terraform and some of the other ones too. So I am a developer, accidental developer. And so as a result, I end up coding a lot of random things too. So today you'll actually see me code a secrets engine for Vault. Please, everybody, ask the demo entities to grant me a working Vault plugin. I did code it. I promise you, I did code it beforehand. I swear it works. It compiles, everything works, but I can't guarantee that I won't forget in PEBCAC and forget some line of code. So that's that. I did my introduction. Jackie, is there anyone you're looking forward to?
Oh, geez, putting me on the spot. I mean, I'm kind of looking forward to a lot of things. This is our application runtime block that we've got coming up, which is pretty much my jam. That's the space I like working in. So we've got some Nomad stuff coming up. We've got some Vagrant and more Terraform, and we've got some Waypoint things. So I'm pretty excited for this, to be honest.
And was there any talk that you were like, oh my gosh, and you learned something earlier today? Because I know you've been on for quite some time already. So I imagine that like all of the talks are sort of in your head right now.
Yeah, when you're emceeing though, and you're kind of listening and you're like, oh, this is really cool, but you can't really like deep intake it because you're kind of always looking at the next thing coming up and checking the time and making sure everything's on track. So there's a couple that I noted as like, I'm going to have to go back and rewatch this and take some time to actually dig into it. But so far I've been really enjoying it. It's been a pretty good schedule. Like this has been a nice edition of HashiTalks, a different perspective, and that's been really enjoyable. So I said that already.
I know. Well, that's the thing is that I don't think we ever really thought about that. We have a lot of people who use our tools, but then we have a growing number of people who are developing on it. And what was really fun was that I was learning from people who said, I didn't know Golang before this, so this was my way to dip my toe into the Golang getting started opportunity. And that was the one way that I could say I'm learning it, or I'm able to apply it to some kind of production use case. And that happened to be with a HashiCorp tool. So I was pretty excited.
Yeah, that makes sense. I think that's pretty much all I have to say right now during this block of time. Kind of looking forward to the next talks. Is there anything else you want to say?
No, that's all. Now, for those tuning in, thanks for joining us. Please ask your questions in the chat. Some of the talks do have live Q&A, so we are able to read them, whether you're on Twitch or YouTube. Drop them in the chat. We'll be able to ask the speakers as well. All right, so let's get started with our next talk. We have Emily Neal with workflows when you have a released API.
Hi everyone, my name is Emily. I'm a software engineering intern here at HashiCorp, and I am working on the releases engineering team. So today I'm super happy to share with you the work that folks on the releases engineering team are doing, and we are building a new releases API service to track and manage release metadata on the HashiCorp releases site, with the goal of providing more information about specific releases to the user while still maintaining external workflows. So to give a bit of context to the problem space we wanted to address with this service, I'll show you the existing structure of the current releases site and the internal HC releases binary that is responsible for building all the data on the current site. So the current releases site contains static HTML and JSON release metadata built by our internal HC releases binary. And these pages are very minimalistic. They only really provide links to product downloads and SHA-SUMs, which is okay for people who are simply grabbing these downloads through scripts, but it leaves those who are searching for other relevant information such as change logs, release notes, license information, searching in different places to get that information. So I'll just show you what the current releases site looks like. So this is an example of the latest release from Boundary. And as you can see here, there's really only the SHA-SUMs and the downloads, which is not a super comprehensive set of data for this particular release. So we're building something to fix that. So let's explore a bit about the future of the releases site. So two key objectives that we want to hit with our solution is to create a solution to simplify the life of the user by providing a single source of truth for relevant release metadata and gather all of the relevant information about a particular release in one location. We also want to do this while maintaining external workflows, so the user doesn't really have to change anything that they're doing. So now that you've learned a bit more about the problem and our objectives, let's talk about solutions. So some possible solutions. The obvious one would just be to add this additional information about releases that we want to provide to the current HC releases site and keep the existing structure. However, this would require a lot of back-end work in terms of how we go about validating this new metadata for each release and publishing that to production. So instead, we opted to use an API, which allows us to control that workflow and implement it a bit easier. So let's talk about the benefits of implementing this new releases API. I'm going to be a bit selfish for a few minutes and talk about the key benefits that it provides the releases engineering team and other internal users. So it really gives us three key benefits. The first is that it gives us a lot of flexibility with implementing specific internal processes around how we go about validating releases and then eventually publishing them. So if we have a releases API, we can run a different service a different instance for each environment. So we can have a staging environment wherein releases are validated and they might never be published, right? We can put nightly builds on this. We can put releases that we intend to publish in this environment and they can be validated. Then we can have another environment with a different instance of the service, which is production, and that can provide all of the release metadata for any user to grab. The second key benefit of implementing a release API for internal use is the ease of implementing our internal authentication and authorization flows. So using an API, we can easily implement auth flows for internal users who are creating and updating new releases. And then we can also implement auth flows pretty easily for machines who are simply running automated tasks. The third and final key benefit for us for creating a new releases API is that it provides easy logging support, audit logging support. So we can easily implement audit logging so we know when a release is either created or updated. We know what the event was, who triggered the event, when it was triggered, and the status of the event. And this just increases our security posture and provides super transparent logging. So I'll talk a bit about the current internal API workflow, just if you're curious. So every time that someone creates a release, that would be posted to the new releases API service. And then it would go through a staging process. And then when it's published, it would be updated in that releases API service.